In this section, we're going to talk about asynchronous JavaScript, which basically is just a fancy term for some code that keeps running in the background while our main code is still executing. And typically that is for stuff like requesting some data from a remote server like an API. So in this section, I'm going to give you the tools to work with asynchronous JavaScript in a very modern way, because it actually works quite differently from what we've been doing up until this point. So let's now quickly move on. In this lecture, we will take a look at a very simple example of asynchronous JavaScript. So this is a completely new concept that we've never touched in the course up until this point. And so I'm very excited to show you what asynchronous JavaScript is all about. Now, before we actually start, you're maybe noticing that I'm using a different code editor here. And that's because this part of the course was recorded shortly after the rest of the course. And so now I switched to a new editor called VS Code. And if you're interested in that one, you can simply go download it here from this website. But of course, you can also simply follow along using the code editor that you already have. So let's close this one here. And I already opened the file for this section here and also the browser here on the right side. Now, what's also different here is that before I used to have an external JavaScript file called script.js, but right now I chose to simply write the code here in a script tag right into the HTML. I find it easier to just do everything in one file instead of having multiple files here. Okay, so let's just write some code here right into this script tag. And we're going to start with just some old school synchronous JavaScript code, just the way we've been doing up until this point. Okay, so let's write a function called first. And you're noticing here probably already that I'm using the new ES6 syntax, right? So I'm using the const keyword here to declare a function expression using then here the arrow syntax, right? So that's the new stuff that we learned in the last section where we talked about ES 2015 or ES6. And so from now on, I'm going to start using this new syntax here in this section and also in the next one. Okay, so let's just log something to the console here. Hey there. And then we're going to call this function here as well. Give it a save, reload it here, and then open up our console. And so now we know that everything's working here, right? So our hey there text is actually being printed. Let's now add a new function. This one, just call it second. And in this one, for now, I'm going to log some other text, and I'm going to log second. Then in the first function, we call the second one. So just second. And then a new console.log down here, simply saying the end. Okay. And this will make more sense to you in a second when we start adding something different here into the second function. For now, we simply have hey there here as the result, which comes from here. Then the second function is called, which logs second, as you see here, and then finally the end. Okay, so all of this is synchronous JavaScript, just the way we've been doing up until this point. And with synchronous, I mean that all the instructions are executed one after the other, line by line, just in the order that they appear in the code. And so that's exactly what we have here. But now let's actually add some asynchronous code here. And in order to do that, we are going to use the setTimeout function, which is basically to set a timer in JavaScript. And that will then allow us to write code that should be executed later. Okay, and so that is asynchronous JavaScript. So let's get rid of this one here. And now I can call the setTimeout function. So setTimeout function is a function that we can pass a callback and also the time. So first is the callback. And again, I'm going to use the arrow syntax. So no arguments here. And then the content of the function in here. And then the second argument we pass into the setTimeout function is for how long we want the timer to run in milliseconds. Okay, so I'm going to put here 2000 milliseconds, which means 2 seconds. And after these 2 seconds have passed, then this callback function that we pass in here will run. Okay, And this callback function here will be very simple. All I want to do is to actually log something to the console. Let's say async hey there. And let's get rid here of this side panel. Okay, so let's review what we have here. First off, we call the console log, then we call the second function, and then in the second function, we call this timer here, which after 2 seconds will then run this function here. Okay, and then after that, we run this console.log, which will log the end to the console. So what do you think the result of this code will be? Can you guess that? So let's take a look. And well, you saw that appearing here after 2 seconds. So first we had hey there, then the end, and only after 2 seconds then appeared the async hey there. Let's try that again. Let's wait for it. And here we go. Now maybe you expected that first only the hey there appeared, then we call the second function, then this timer is run, and then after 2 seconds it would then print the async hey there, and only after that it would print the end. Maybe that was what you expected, but that's simply not how JavaScript works with asynchronous code. Okay, and I'm not going to go into a deep explanation here at this point, because that's what I'm going to do in the next lecture. So in the next lecture, you will learn exactly how asynchronous JavaScript works behind the scenes with the event loop and the web APIs and some other parts of the JavaScript engine. For now, I just want you to notice that all of this code here run, and that basically the timer run in the background, and then after it finishes, only then it printed here the text to the console. But that didn't stop this code here from running even before the timer had finished. Okay? So this was just a very simple example to show you what asynchronous JavaScript is. And in the next lecture, you will then, as I mentioned before, learn all you need to know in order to deeply understand how asynchronous JavaScript works behind the scenes. So after checking out an example of asynchronous JavaScript, let's now dive in a bit deeper and learn everything you need to know about synchronous and asynchronous JavaScript code, as well as the event loop. So all the code we've been writing in this course up until this point has always been synchronous code, which simply means that one statement is processed after the other, line by line, in a single thread in the JavaScript engine. So something like this is an example of synchronous JavaScript, where the first function is executed, logs hey there to the console, calls the second function, which then prints how are you doing to the console, and then finally the end is logged to the console. So one instruction after the other in a synchronous way. Now this here is an example from our previous lecture, and as we learned, this one involves some asynchronous JavaScript. So again, the first function gets called, logs hey there to the console, and then calls the second function. Now this function calls the setTimeout function, which is basically like a timer that will execute the callback function that we passed into it after 2000 milliseconds. However, this will not make the code stop for 2 seconds, but instead the function returns, goes back to the first function and logs the end. Then, after the 2 seconds actually have passed, async hey there is logged to the console. Now, why does the code move on instead of waiting for the timer to finish? Well, before I show you how and why this actually works behind the scenes, let me quickly show you another example. So suppose we select an image from our DOM and pass it into a processLargeImage function that we created. Now we know that this function is going to take some time to process the image. And so just like before, we don't want the code to have to wait. So we don't want it to stop while the image is processing, because that would be terrible in some situations. So what we do here is to also pass in a callback function that we want to be called as soon as the function is done processing. And just like that, we have created asynchronous code. So that is the whole philosophy behind asynchronous JavaScript. We do not wait for a function to finish its work and then do something with the result. Instead, we let that function do its job in the background so that we can move on with the code execution. We then also pass in a callback function that will be called as soon as the main function has done whatever it had to do. We then move on immediately so that the code is never blocked, which means that it can keep processing the code in a synchronous way line by line. Because if the code is actually blocked, then nothing really works on the page during that time. Like for example, you can click any buttons or anything like that. So in summary, we can use callback functions to defer actions into the future in order to make our code non-blocking. But how does that actually work behind the scenes of JavaScript? Well, that's where the event loop comes in. So the event loop is part of the bigger picture of what happens behind the scenes of JavaScript when we call functions and handle events like DOM events. So we already talked about the execution stack and also about the message queue when we first talked about events. And so this should be nothing new to you at this point. Now, what is new here is the event loop as well as the web APIs, which together with the execution stack and the message queue make up our JavaScript runtime. So this runtime is responsible for how JavaScript works behind the scenes as it executes our code. And it's extremely important to understand how all these pieces fit together in order to execute asynchronous JavaScript. So let's now take a look at how the code from the last lecture is executed inside our JavaScript engine line by line. So it starts by calling the first function, and so as we already know, an execution context for that function is put on top of the execution stack, which can also be called the call stack. In the next line of code, the console.log function is called, and so a new execution context is created and the text is logged to the console. Then the function returns and the execution context pops off the stack. Moving on to the second function, a new execution context is created, and in the next line, the setTimeout function is called, which causes yet another execution context to be created. Now, before we move on, where does this setTimeout function actually come from? Well, it's part of something called the web APIs, which actually live outside the JavaScript engine itself. So stuff like DOM manipulation methods, setTimeout, HTTP requests for AJAX, geolocation, local storage, and tons of other things actually live outside of the JavaScript engine. We just have access to them because they are also in the JavaScript runtime. And so this is exactly where the timer will keep running for 2 seconds, asynchronously of course, so that our code can keep running without being blocked. So when we call the setTimeout function, the timer is created together of course with our callback function, right inside the web API's environment. And there it keeps sitting until it finishes its work, all in an asynchronous way. So again, the callback function is not called right now, but instead it stays attached to the timer until it finishes, okay? And so since the timer keeps working, basically in the background, we don't have to wait and can keep executing our code. So let's do that. So next up, the setTimeout function returns, pops off the stack, and so does the execution context of the second function, which now returns as well, and so we're back to the initial first function. Now we just log the end to the console, and so we give ourselves a new execution context, print the text to the console, and pop the context off again. Next, the function returns, and so we're back to our original state. So right now, we have executed all our code in a synchronous way, and have the timer running asynchronously in the background. Now let's suppose that our 2 seconds have passed, and so the timer disappears. But what happens to our callback function now? Well, it simply moves to the message queue, where it waits to be executed as soon as the execution stack is empty. And this is exactly what happens with DOM events as well. Remember that? And that's because it actually works the exact same way. So in the case of DOM events, our event listeners sit in the web API's environment waiting for a certain event to happen. And as soon as that event then happens, then the callback function is placed on a message queue ready to be executed. Alright, so how are these callback functions in the message queue executed? And that's where finally the event loop comes in. So the job of the event loop is to constantly monitor the message queue and the execution stack, and to push the first callback function in line onto the execution stack as soon as the stack is empty. Okay, so in our example here right now, the stack is empty, right? And so we have one callback waiting to be executed, and so the event loop takes that callback and pushes it onto the stack, where a new execution context is created for that function. And that's it. That's what the event loop does. So inside that callback function now, we simply run the log function, which logs async hey there to the console. Then the context pops off the stack and we're done. Now, if there were some more callbacks waiting right now, like data coming back from an AJAX request or the handler of a DOM event, then the event loop would continue pushing them onto the stack until all of them were processed. And that's how the event loop works. It's actually quite straightforward, right? But still, if you ask 95% of the JavaScript developers out there, they will not really be able to explain you this stuff. And so you just gained a huge competitive advantage over them. Now, please just note that the setTimeout function that we used here as an example is really more to simulate a more real-world asynchronous function, like doing an AJAX request to fetch some data from an external API, just like we're going to do in one of the next lectures. Okay? So I hope this made sense to you, so that you're now ready to move on in order to use this stuff in practice. After learning exactly how asynchronous JavaScript works behind the scenes, over the next couple of lectures, we're going to learn how it can be used in practice in our code. So in this lecture, we're going to take a close look at asynchronous JavaScript with callbacks, which is the more traditional way of dealing with asynchronous code. So let's get rid of this code here, but instead of deleting it, I will simply comment it out, okay? So that we keep it here like for future reference, okay? And you can do the same, or you can delete it, you can do it however you feel like, okay? Now, in order to learn about asynchronous JavaScript with callbacks, we're gonna build a very, very small fake recipe reader, okay? And here, we're gonna simulate AJAX calls to get some fake recipes using setTimeouts. So basically, we're going to simulate loading data from a remote web server, which of course would be asynchronous using some timers, like we did in the last lecture. Okay, so let's create a function here called getRecipe. And then down here, we call that function. Now, the way this is going to work is that we simulate first that we get a bunch of recipe IDs from a server, and then based on that, we select a recipe and then get that recipe from a server after that. Okay, so first we get a couple of IDs and then we get a recipe. So again, we're going to use the setTimeout function here, as I mentioned before, basically to simulate the AJAX call, so the call to get the data from the server. So our callback function here, and then let's say this is going to take 1500 milliseconds. So 1.5 seconds. Then in here, let's simply create an array of recipe IDs. And then some numbers. It doesn't really matter here. Okay, and then let's just console log these. And just to see if everything is working, we are reloading it here. And yeah, so after 1.5 seconds, then this code here appears on the screen. Okay, and again, this setTimeout here is just to simulate that this data here comes back from a server. Now, once the data comes back from the server, we then want to get the recipe for one of these IDs. Okay, and so in here, we now need another setTimeout, right? Okay, so basically after we receive this data here from the server, then we need a new setTimeout where then the data comes from the server for the recipe. Okay, and once more, this doesn't really come from the server, of course. All of this is just to simulate the asynchronous behavior. And don't worry, in one of the future lectures, of course, we're going to use a real API and real AJAX calls. But for now, we don't want to mess with all that. And so we just use the setTimeouts to simulate that behavior. Okay, here let's just put 1 second, and actually into the setTimeout function we can pass a third argument, which can be an argument to the callback function. So let's say we want an ID argument in this callback function here, so ID, and then we can pass a value here as a third argument, and that will then be passed into the callback function. Okay, so let's then use the recipe IDs that we got from the server in the beginning. Okay, and so now basically this recipe ID 2, which will be 432, which will then be passed into this callback function here as ID. All right, so let's create a fake recipe here in this callback function. and we're going to use an object. So this recipe will be fresh tomato pasta. And then let's also add a publisher. And that will be Jonas. Okay, so that's the fake recipe. Now let's just log it to the console. Console.log. And now in here, I actually also want to use this ID. So just to know that everything's working. And so let's use a template string here. So one of the new ES6 features here as well. And remember, if you want to use one of the variables, then we use the $sign and curly brackets, ID, and close the curly brackets. And then we can just write our code. So we say the ID and then just the title of the recipe. So recipe.title. And that's it. And now let's check out if it works. So after 1.5 seconds, this one here comes, and then after 1 second, we get the recipe. And so basically we chained these two timers one after another by putting this one here inside of the first one. So we have the first set timeout, and then in there we have a new set timeout. And like this, first the first one runs, and then after 1.5 seconds we get this data, and then after yet another second we then get this this fake recipe here. And you also see that the 432 here is actually being passed into this callback function here, just like I said, because we passed it here as a third argument into the set timeout function. Okay, just to see again if this works here, maybe you didn't get the timing here. Let's take a look here at this again. So 1.5 and now 1 second, and here we go. And now just to make things a little bit more complex, let's just add a third level. And let's suppose that we want to get another recipe from the same publisher. So in this case here it's Jonas, and so let's pretend that we want to get another recipe which is also from the same publisher automatically. And so now we use another set timeout with yet another callback function. Okay, so set timeout again. And now we also want an argument here again. And actually we don't even need these parentheses here, right? Remember that with the arrow functions, if we have only one argument, then we don't need to use the parentheses at all. Okay, so publisher, and then just a function body. And this one here, maybe after 1500 again. Maybe this one here as well. I thought this was a bit too fast. Let's get rid of the parentheses here as well. So just ID. Okay, and then of course we also have to pass the publisher into this callback function. And just like before, we do it like this. And this one is stored here in the recipe object. Right, so recipe.publisher. Okay, and so let's now create here another recipe. And this one is Italian pizza. And of course the publisher is the same. All right, let's call this one here recipe 2. Okay. So now we have 3 callbacks nested inside one another. Let's just check if this works. So the IDs, then the first recipe, and now the related recipe from the same publisher, and here we go. And so basically this now is like having 3 chained AJAX calls to get some data from the server. But you see that this is getting here a bit out of hand. Imagine that we had more and more and more chaining here, like 10 levels. Then we would have all of these callbacks here inside of one another. And that is the so-called callback hell in JavaScript. So this triangular shape here that you have here, so this shape here, what I mean here, this triangular shape that we have here, that is a sign of the callback hell, which simply means that we have callback inside of callback inside of callback, which after some time gets really unmanageable. Okay, it gets really messy. And so that's why in ES6, something called promises were introduced. And with promises, we can avoid all of this callback hell here and have a nicer and cleaner syntax when using asynchronous JavaScript like we have here in this example. Okay, and so in the next lecture, we are actually going to look at promises, which is one of the ES6 features that we didn't really talk about in the last section where we talked about ES6 or ES 2015. Okay, so make sure that you understand the logic behind this here, that you really understand what the callback hell really means, because that's a term that you're going to find frequently when you're reading about JavaScript on the web. Okay, so I had to show you what callback hell here is, so that after that it makes sense to you why we use promises. In order to escape the so-called callback hell that I showed you in the last lecture, let's now learn about promises, which is an ES6 feature designed specifically to deal with asynchronous JavaScript. Now, before we start, what is a promise actually? Well, it's a complex topic and it's easier to understand in practice, but in simple terms, a promise is an object that keeps track about whether a certain event has happened already or not. And if it did happen, then the promise determines what happens next. And with events here, I mean an asynchronous event, like a timer finishing or data coming back from an AJAX call, okay? So, a promise kind of implements the concept of a future value that we're expecting. It's like us saying, hey, get me some data from the server in the background. And the promise then promises us to get that data, so we can handle it in the future. Okay? Does that make sense? Now, since we're dealing with time-sensitive code now, a promise can have different states. So before the event has happened, the promise is pending. Then, after the event has happened, the promise is called settled or resolved, which is the same thing, okay? Now, when the promise was actually successful, which means that the result is available, then the promise is fulfilled. But if there was an error, then the promise is rejected. Simple as that. And this is actually important to know, because we will then be able to handle these two different situations in our code. Now, in more practical terms, we can produce and consume promises. So when we produce a promise, we create a new promise and send a result using that promise. Then when we consume it, we can use callback functions for fulfillment and for rejection of our promise. So let's now produce promises in order to recreate the example that we built in the last lecture and then consume those promises. And again, let's start by cleaning up here our code from the last lecture by simply commenting it out. So with promises, just like every other object type, we use the new keyword. So we say new promise, and then into that promise we pass in a function called the executor, which is a function that will be immediately called once the promise is created. Okay, so let's just add that here as well, without actually for now adding any code. So again, an arrow function here, and so that's our promise. And of course, let's also assign this promise here to a variable. So const get IDs, okay? And that's because we're recreating the example that we had up here, okay? And so basically this first promise here will be responsible for doing that first part here with the first timer. So basically where we get these four IDs here from the server with this fake AJAX call here, okay? But now getting back to our promise here and this callback function that we pass into the promise, remember that this one here is called the executor function. And this function here itself actually takes in two arguments, which are the callback functions resolve and reject. So resolve and reject. And that's because this executor function here is used to inform the promise whether the event it is handling was successful or not. And if it was successful, we're going to call the resolve function, and if not, we call the reject function. So remember that we had these two states here, resolve if the promise was successful and reject if the promise was not successful. So if you don't have any result. And in that case, we can call the reject function. And I'm going to show you how we use these functions here inside our promise in a second. But for now, let's put some asynchronous task here in the executor function, because that is usually what happens in a promise. So something like an AJAX call, or in this case, a setTimeout function. So again, to fake the AJAX call, so basically the call to a server to get some data, okay? So again, we're going to use setTimeout. With a callback function after 1 second, okay? Or after 1.5 seconds, that gives us a bit more time to see the result. Now, when this timer finishes here after 1.5 seconds, we want to return the data with some of the fake IDs, just like we did before. And so now it's actually time to call that resolve function. And remember that we call resolve in case that the event was successful. So calling the resolve function here will basically mark the promise as fulfilled, so as successful, right? And that is exactly what we want here. Okay, so let's call the resolve function here. Resolve. Now that function actually takes an argument here, which is for the result of the promise. And so this is basically how we return our result from the promise if it was successful. And what do we want to return here? That's right, that's just this array of these IDs. So let me just copy it from up here and put it down here. All right. So again, what we do here is that after this timer finishes after 1.5 seconds, we say that the promise is successful and that we want to return this data here. And that's why we used the resolve function. And since set timeout is impossible to fail, so this timer will always finish, there's no way it is not going to finish, and so we don't need to call the reject function in this case. But we would need it in some other cases, like when we are dealing with data coming back from a server where there can happen all kinds of errors. But in this case, we don't need to call the reject function ever. All we do here is to call the resolve function, which marks the promise as fulfilled and returns this data here. All right, and so we produced our very first, very simple promise here, which is stored now in this getIDs variable. Okay, and so now it is actually time that we consume these promises. And in order to do that, we can use two methods on all of the promise objects. And these methods are the then and the catch methods. Okay, so all of the promise objects here inherit these two methods. And so we can now go ahead and use them. So getIDs dot then. And this then method allows us to add an event handler for the case that the promise is fulfilled. So which means that there is a result. So now all we have to do here is to pass in a callback function, which will handle what we do in case the promise was successful, which will actually always be the case here in this promise, right? So as I mentioned before, this cannot fail, and so it will always be successful, and so we can always call the then method on our promise. So let's add a callback function here, and this callback here actually can take an argument. And I'm going to explain to you in a second how this works. Okay, so I'm simply calling this one here IDs, and then an arrow function again, and then just like this. So here's the function body. Now this argument here that we pass into our callback function, which is this entire thing here, right? So this argument here will be the result of the successful promise. So in this case, it will be this entire array. Okay, and so let's now log this one to the console. So console.log IDs. And that's actually it already. So let's check it out and wait for it here. And here we go. So after 1.5 seconds again, it then printed these 4 IDs in this array here to our console. So let's recap what happened here. So we created this promise here with this executor function in it. Then inside that function, we usually have some asynchronous code, which is in this case here our set timeout, which after 1.5 seconds returns this data here in case it is successful. And that's why we use the resolve function. And the set timeout function will always be successful. And so all we need to do is to simply always use the resolve function here and then pass in the data that we want to return from the successful promise. So from the fulfilled promise. And we can then handle that successful, so that fulfilled state down here with the then methods that is available on all our promise objects. All right. So we have our promise object, and then on it, we use the then methods, which is used to handle the fulfilled promise. And into this then method, we pass in a callback function, which will always have as an argument the result of the successful promise. And that's why if we use console log of the IDs, we will basically console log this array here. Okay, does that make sense? Now, as I mentioned, we also have access to another method, which is the catch method, which allows us to add a handler for the case that the promise gets rejected, so that an error happened. So let's try that one as well. And so I'm going to chain these here in different lines. So just like this. and finally a catch. And here we usually call the argument of the callback function the error, and then we can log this error to the console. Okay, so again, right now it's impossible that this catch here is actually called because this promise here is impossible to fail. So we never called this reject callback function in here. But just to try it, let me actually use reject here instead of resolve, just so you see what happens here. And so you see the result is actually the same because we still return this data here, but this time as an error basically. So let's say we didn't have this catch here, and so now it shouldn't have any result. Okay, and so now we actually get this error here. Okay, but right now, since we're actually catching this error here, and we can also instead say something else here, just say error, and then let's try it out again. And so now it says we have an error. And again, we have an error because by using this reject function here, we basically mark this promise as rejected. And so therefore JavaScript assumes that there was an error. And so this part here is the method that gets called. Okay, but now let's put it back, of course, to resolve, because our promise is always successful. Okay, so now we translated this first part here of our previous example, and now let's write the two promises to handle the part where we get a recipe based on an ID, and then where we get another recipe based on the same publisher, like we did here in this part. Okay, so let's now add these two promises, and then we can put it all together down here when we consume our promises. Okay, so let's remember how this worked up here. So we passed in an ID into the callback function of this timer, which came from the recipe IDs that we got from the first step. And so let's do something similar here. Okay, and so what we're going to do is to actually create a function which receives this ID and which will then return a promise. So let's say const get recipe, which will be a function that receives the recipe ID, and with this function body here. So again, an arrow function expression here with the new ES6 syntax. Then in here, we can return our new promise. So we return and we say new promise, just like we did up here, right? And now we need to do our executor function. And this part here is always the same. We always say resolve reject, and then pass in the function body. Okay, and now what happens inside of this promise is actually pretty similar to what we have in here. So let's just get it from this part. Okay, but instead here, of course, of the console log, we will resolve this value that we have here. Okay, so just like in our other promise, we actually want to resolve the value. And actually I'm seeing that this is not quite correct because we're still missing our set timeout here, of course. So let's add that very quickly. So set timeout. Then in here we want to pass in an ID, and then this code, of course. Then 1500 seconds, and then we pass in rec ID. So does that make sense? So into this get recipe function, we pass in rec ID, so the recipe ID, which we then pass into this set timeout. And so then it will become ID. And then inside the callback function, we use ID here. So this needs to be ID in uppercase. Okay, now how do we actually consume this promise here? So let me show it to you. So what we could do here, of course, is to simply call the get recipe function here and then add a then to it. So just like this, like get recipe with IDs 2, just like we did before, and then this would return a promise, right? And then we could add the then, and so on and so forth. But this would not really solve the problem of the callback kill, right? Because then again, we would have this callback here, this then inside of another then. And that's not ideal at all. And so there's another way of doing this. And that's actually the beauty of promises, which is something called chaining. So we can return a promise from this then method here, and then simply add the next then method after it. So let me show that to you so that it makes more sense. So I do it like this, return get recipe IDs 2, and then I can add the next then after this. This get recipe here will return a promise, okay? So after this here runs, we will have a promise here. And what we do then is to return that promise. And therefore we can then add the next then to handle the result of that resolved promise. Okay, so we now have this promise here and now want to handle the fulfillment of this new promise. Okay, and what will happen when this promise is fulfilled is that it will basically return this data here. Okay, and that is our recipe. So let's call this parameter of this callback function here the recipe. And then simply log it to the console. And let's try it out here. So the IDs, and then finally the recipe. So it's working just fine without any of the callback hell that we had up here, right? So now our code is all nicely separated here into these different functions. And then down here we consume these promises. We could of course put this one here into a function as well, but that's not really necessary because we don't need to pass any data into this. So here this get recipe, we did it as a function because we needed to pass in this recipe ID into this promise here. Okay, and so that's the second one. And now finally let's work on the last one. So let's add another function here called get related. And remember that this one here is basically to fetch a recipe which is related to the author of the first recipe. And so of course this needs to happen in a sequence because we can only load a related recipe if we already know the publisher that we're looking for. And so we need to do this in these 3 steps just like we did before. So again, return a new promise. Then resolve and reject. And again, this is always like the same here. And oh, I forgot to put the parentheses here for the arrow function. And then again here, the set timeout. Let's just say pub here. After 1.5 seconds, so 1500 milliseconds, and then the publisher. So just the same logic as before. So this publisher is the one that we get here as an input to this function, which will then be passed into the callback function of the setTimeout and will then be called pub. Okay, and now I'm just going to copy the code that we have up here again and simply paste it here. And again, we don't want to log it to the console, but we want to resolve this promise and return this recipe here. So recipe, and let's call it recipe here as well. And let's actually also use this pub argument. I think up there we didn't actually use it, but let's do that down here. So let's use a template literal here again. And say pub. And then show the recipe here. So the Italian pizza. Okay, and so that should get the job done. And so now, in order to consume this promise, I'm going to do it in the exact same way as before. So we receive our recipe here. And now I will return the result of calling get related. So get related. And what we passed in here then is the recipe.publisher. Right? So recipe.publisher, because that's in this case here Jonas, right? So we get Jonas from our recipe, and then pass it into the getRelated function. And so all of this here will return a new promise. And so just like before, we can then use the then method on it. And again, we receive a recipe, and so I can call it recipe again, because it's a different function than this one here, and so I can simply reuse this name. And so now let's again log this recipe to the console. Give it a save, and let's try it out. So after 1.5 seconds this one, then the first recipe, and then the related recipe. And now we get an error here saying undefined and then this weird object. And I think I know why this is happening. And that's because our recipe here actually returns a string. Okay, so you see here that we actually resolve this entire string here and not just the recipe object. And so therefore we can then not read a recipe.publisher. Okay, and so instead I'm simply going to add Jonas here. Okay, so in this case it doesn't really matter. And so that solves this first part here. Then after that I have object, and that's because here I put this entire object here into a string, but instead I just want recipe.title, just like we have here in this line of code as well. Okay, and if I do this now, then it should work. And now finally, yeah, so Jonas Italian pizza. I could of course pass something else here, just like my entire name. And so 1.5 and 1.5 and finally another 1.5 later, we get this entire result. Okay, so that's how we do the same thing that we did before with the callback hell with promises. So instead of having this really messy and unmanageable code, which is actually a lot less code here, but it still is really unmanageable, especially if we had more code and deeper nested callbacks, then it would become really like a nightmare to maintain. And instead, we have very nicely separated code here like this, where we produced all of our promises, and then in the end, we simply consumed them here with this chain of thens, and finally then a catch to catch if there's any error. And that's it about promises. Pooh, this was a lot to take in. And I find promises to be one of the hardest, if not the hardest concept to grasp in JavaScript. And so please don't worry if you didn't really understand it 100% on this point, okay? Because what really matters is actually how we consume promises and not so much how we produce. Because that is oftentimes already included in some kind of libraries that we're going to use later in the course. So we learned how to construct and how to consume promises, but the syntax to consume promises can still be quite confusing and difficult to manage. And so in ES8 or ES 2017, something called async await was introduced to the JavaScript language in order to make it a lot easier for us developers to consume promises. So let's now take a look at async await. So again, async await was designed for us to consume promises and not to produce them. So if we want to produce promises, we just do it the way that we learned in the last lecture. But most of the time, we're going to consume promises anyway, and async await makes that a lot easier to do. So without further ado, let's see how to use it in practice. And what we're going to do is basically to change the way we consume them in the last lecture, so this piece of code, and instead use async await. So these promises that we have here, these three, we will continue using them. We will simply get rid of this code here for now and do the same thing with async await. Okay? And so we start by creating an async function. So use the async keyword, then function, and let's say get recipes, and then I'm going to call it AW for async await. Okay? And then we can also just call it down here. All right. So this is a new special kind of function, which simply means that this function is an asynchronous function. So one that basically keeps running in the background just the way that we've learned before. This async function then returns a promise, but more on that a bit later. For now, what's important is that inside an async function, we can have one or more await expressions. So in order to consume our first promise, we can do it like this. We simply say const IDs await get IDs. So this get IDs here is our first promise, right? So get IDs is this promise here. And then to consume it, we simply say await IDs and assign the result to this IDs variable. And what happens here is that this await expression here will really stop the code from executing at this point until the promise is fulfilled. So in this case, this get IDs promise. And if the promise is resolved, which remember means that it was successful, then the value of the await expression is the resolved value of the promise, which is then assigned to this IDs variable. Okay, so again, in this case, our promise will resolve to this value here, so this array, and so this IDs here will then become the value of that resolved value, so that array that I just showed you. Okay, and to demonstrate this to you, let me then just simply log this to the console. So IDs. Run it, and let's see it, and here we go. So after 1.5 seconds, we log the resolved value of the get IDs promise. Okay, and so again, what happens here is that we fire off the function, so we start the function, and it then keeps running asynchronously in the background. And then here, we wait for this promise here to resolve, assign the value to this IDs variable, and then simply log it to the console. Now, if the promise is rejected, then an error will be thrown. And if you want to handle that error, we have to include some more code here, but that's not really important for now at this point. And so I'm leaving that for the next lecture. Okay, so let's now consume our other two promises. So this one I'm going to call recipe, and we will await the result of our next promise. And that one we get simply by calling get recipe, just like this here, right? So we have our get recipe function, right? Which is this one here, which will then return a promise. And so we await that that promise finishes. And after it finishes, we can then log the recipe to the console. And now the next one, let's simply call it a related and await the next one. So we can actually use, again, this code here. And that's it. So let's check it out here. And this should work the exact same way as before. And yeah, here we go. So here we have our result, just like we had when we consumed the promise in this way here. Okay, and I think that this way here is really a lot easier. So all we do is to simply await until each of these promises here gets resolved. And in each of these lines where we use the await keyword, the execution stops and we wait until a promise returns. So that's how async await works. It allows us to consume promises, but without all the callbacks that we have with the callback hell, and to some degree also in promises with the then and the catch methods. Now I just want to make it very clear again that the await expression can only be used inside an async function, okay? And this async function, remember, it runs in the background. And that's very important because we can never have the main code stopping. And so all we do here is to block the code in the async function, which runs in the background anyway, okay? And so again, stopping the function here is not a problem because it just runs in the background anyway, okay? So in here, in this line of code, we synchronously call this getRecipes function, which then does all this stuff here just in the background, okay? Now, this is all really great already. Now, just imagine that we actually wanted to return a value here from this async function. So let's try something which is not going to work, but I'm going to show you anyway. So let's say that we want to return the recipe. So we can assign then this return value here to this result, right? And then we can log it to the console. Now this is not really going to work, right? So let me show it to you. So all this logs here is this promise, and it says pending here. And so that's not really the result that we were looking for. We were hoping that it would log to the console the result of the recipe. So basically this here, right? And so why didn't this work? Well, it doesn't work because this function here runs asynchronously in the background. And so by the time that we try to run this console.log here, this getRecipe function is still running in the background. And so all that is logged is this promise here, which simply says, well, this rec here, it is a promise, but we don't have any result yet, and so we cannot log anything to the console, right? Because remember that this code here is, of course, run synchronously, right? And so it runs this here, then it puts it off to the background, and then immediately it will run this next line. But by the time we run it, this getRecipes function here will still be doing its job and will then log this data here long after this line here has already run. Okay? So how could we actually solve this problem? Well, remember how I told you a bit earlier that an async function always automatically returns a promise. And so if we return a value from the async function using the return keyword, so just like I did here, then the promise will automatically be resolved with this returned value. Okay? Now this may sound a bit confusing, but it's very straightforward. So let me just show it to you. So this one here doesn't really work, but what we can do here is to then simply use the then method, just like we did before. Because again, this function here automatically returns a promise with the resolved value of recipe. And so we can now use this then, into which we pass a callback function where the argument is the resolved value of the promise. So let's just say a recipe here, or result, it doesn't really matter, let's just call it result. Okay, why not? And then we can simply console.log this result to the console. And we can maybe add some more text so that it's different from this one here. So let's use the backticks here. Then we of course need these curly braces. Is the best ever. So something like this. And so now let's test it again. And wait for it. And here we go. So fresh tomato pasta is the best ever. And so now it works just the way we wanted it to work, right? And so what we did here is to use then, which is basically to consume this promise, just like I showed you before up here, right? Which is possible simply because of the fact that this async function here always returns a promise that we can then consume. Okay, and we will actually need to use this trick here later in the big project that we're going to code. And so it's important that you familiarize yourself with this piece of code and that you really understand and that it makes sense to you at this point. Okay, so I hope you saw that async await makes it so much easier to work with promises. And that's just because of the fact that it looks like the normal synchronous code that we're already used to. It just works in an asynchronous way behind the scenes. Okay, so again, this really looks like synchronous JavaScript code that we've been written all the time. We just need to understand that behind the scenes, because of this async and await, this is asynchronous code. But as long as we understand how and why all of this works, we can now use this fantastic new tool to our advantage. So we've been throwing around words like AJAX and API throughout the section, but before we move on, let's just take a second to understand what these terms actually mean. So AJAX stands for Asynchronous JavaScript and XML, and basically it allows us to asynchronously communicate with remote servers. So let's say we have our JavaScript app running in the browser, which is called the client, and we want the app to get some data from our server. But of course, without having to reload the entire page. Well, with AJAX, we can do a simple GET HTTP request to our server, which will then send back a response containing the data that we requested. And this all happens asynchronously in the background, just the way we learned before. Also, of course, this not only works for getting data from the server, but also to send data to the server, by doing a POST request rather than a GET request. Now, in practice, there are many ways in which we can do AJAX in JavaScript, and we're going to look at the Fetch Web API in the next lecture, which will allow us to make some AJAX calls in a very easy way. Alright, and since we were talking about servers, we also have to talk about APIs. So, API stands for Application Programming Interface, and on a very high level, it's basically a piece of software that can be used by another piece of software in order to basically allow applications to talk to each other. And that's not just valid for web development in JavaScript, but for programming in general, okay? But now in reference to web development and AJAX and servers, well, the API is not the server itself, but it's like a part of the server, like an application that receives requests and sends back responses. So let's distinguish between two types of APIs that you can use in JavaScript, which are your own APIs or external third-party APIs. So let's imagine for a second that you're building a traveling app, and you have a database with different destinations and tours that you're offering. So on your server, you could build your own API that can receive requests from your front-end app in JavaScript and send back the results. So that would be your own API hosted on your own server. But now you also need some current weather information for each destination, which you don't have in your database, and so you can use a third-party API to get that weather data. Okay, that makes sense, right? And there are actually all kinds of third-party APIs out there, like to include Google Maps into your app, or to embed YouTube videos, to get data about movies, or even to send emails or text messages from within your app. There are really endless possibilities, and that's why APIs are getting so popular in web development. Okay? So these are the very fundamentals about AJAX and APIs, but it's all you need to know in order to get started. So let's move on now and use some AJAX in practice. Welcome back. And this is a very exciting lecture, because now you're finally going to use all the skills you learned about asynchronous JavaScript in order to make an AJAX call to request some weather data from a real weather API. And in order to do this, we're going to use a modern web API called Fetch. And by web API, I mean these parts that are available to us in the browser, but are not really part of the JavaScript language itself. Remember that from the event loop lecture? Anyway, with Fetch, we can do AJAX in a very simple way. So we can do asynchronous network requests across the internet to fetch data from other servers or even from our own server. Okay, so that's just what we talked about in the last lecture, right? Now we used to do this in JavaScript using the rather complex XML HTTP request interface, and maybe you have heard of that. It has actually better browser support than Fetch because it's been around for a long time now. But I'm still going to use Fetch right now here in this lecture, which is more modern, and it should work more than fine for us here. And so let's test it out now. So I'm gonna get rid of this code here first, just like before. Okay, and so all we have to do is really to use the fetch function. So just like this. Now in here we need to pass the URL where the API is located. So basically the URL to which we are sending the request. Now we are using a weather API called MetaWeather. So let's now talk a bit about that one. So I already have it here open. So it's on metaweather.com/API. And this page here is basically a simple documentation of this API. So normally APIs request a key in order to use it, but this one is a very simple one and it doesn't require an API key. And so that's why I chose this very simple MetaWeather API. Okay, so down here we have the documentation, and we can see here that there are three methods in this API. So the first one here is to search for locations. Basically, you put in the name like of a city or something, and it then comes back with a result which contains these fields here in the response. So the title of the location, the type, the latitude and longitude, this ID here, which means where on Earth ID, and then this distance here. Okay, now this is not the one that we want to use, but we want to use this location method here. And this is basically to get the weather data from a certain where on Earth ID. So this ID here that corresponds to a place on Earth. Okay, and so this is the API method or the API endpoint, which we can also call it, that we're interested in. And down here we have some examples. And so let's check it out. This one here for San Francisco, which is actually the one that we're going to use. So let's open it in a new tab. And then you see this response. Now maybe for you it looks like this in the browser, so probably this is here what you see, but I have this very handy Chrome extension installed which is called JSON Viewer, and so it makes it nicely formatted and more easy to read, just like this. So you see here that this is the URL of the API call. So MetaWeather/API/location, which is the endpoint, so which is the method that we're using, and then we also pass in the Were on Earth ID, which is this number here, right? So just following the format that we have here in this documentation, okay? So what we get back then is this object here, which is not really an object, but it's called JSON, okay? And so JSON is a text-based data format which is very similar to JavaScript objects, but the difference is that JSON is really just a single string and not an entire object inside the JavaScript engine. Okay, so this is like a string that we can receive from the server, and we can then easily convert it to a JavaScript object. And I'm going to show you how that works just in a second when we start using this API. For now, let's just take a look at the result here. And what we have is the first field is the consolidated weather, and so we get an array of the weather in different days. So the first one is for March 15, and you see the minimum temperature, max, wind speed, wind direction, air pressure, and all the good stuff like that. Then we have the same for March 16, 17, 18, and 19, and even 20. So I think it's a forecast for 5 days that we get. And then beside that array, we also have the current time, the sunrise, sunset, the time zone, and all of this data here. Okay, so we can get all of this just by calling the API on this location endpoint with this ID here. So basically with this parameter. So this works kind of a parameter that we pass into the API simply by using it in the URL that we call. Okay, so let's actually use this one here. And so all we need to do is to pass this one into the fetch. Okay, as a string, and here we go. That's it. Now it looks a bit weird because this moved to a new line here. So ideally it would be like on one line looking like this. Okay, but we have no space for that, so that's just how it looks. Now just to test what happens here, let's take a look at it. Okay, and so now we get this weird error here saying no access control allow origin header is present on the requested resource. So what is this strange error? Well, the reason for this is the so-called same origin policy in JavaScript, which basically prevents us from making AJAX requests to a domain different than our own domain. So right now we don't really have any domain here, we're just opening the JavaScript file, okay? And the domain that we're requesting this resource from is of course the MetaWeather API. And so because of this same origin policy, we can then not access this resource, okay? Now, in order to actually allow developers to make requests to different domains, something called cross-origin resource sharing, or CORS, was developed. And I don't want to bore you with all the details here, but in simple terms, the developers of the API that we're requesting from, they need to implement CORS on their server. And that's actually the case for many APIs, but unfortunately not for MetaWeather, okay? So this is kind of a problem, but we can actually still fortunately solve this. So what developers usually do is to proxy or to channel the request through their own server, like doing the AJAX requests on our own server where the same origin policy doesn't exist, and then send the data to the browser. So that is just a workaround to that problem. But of course we're not going to do that here because we don't have our own server in this example, and of course we want to keep it simple, but we can still use a service that does exactly that for us. And so we're going to use a proxy called crossorigin.me. Let me actually show it to you. And that's misspelled. So crossorigin.me. And so here it says what it does. So a CORS proxy is a service that allows developers to access resources from other websites without having to own that website. And it's actually very easy to use. All we have to do is to prefix our own request URL with this crossorigin.me. So let's test that and put it here. And that should actually be enough already. Let's reload it. And now we don't get any error, but we also don't get any result, right? And that's because we didn't yet handle the result of this fetch function, okay? So we simply fired off the request, but then that's really all we did. We didn't handle any responses or anything like that. So let's now take care of that. Okay, and what you need to know is that the fetch API gets our data and returns a promise. And this promise can, of course, either return the data that we want or an error if it couldn't somehow find the data that we requested. And so now we can use the then and catch methods on this promise, just like I showed you in the last lectures. So remember how I mentioned that most of the time we actually just consume promises and do not really produce them. And this is a great example of that. So fetch here, it automatically returns a promise without us having to write the promise ourselves. So we're just consuming it here. And so let's now use the then method on it. And also the catch. So our callback function here has one argument, and that is the result value of the promise. Remember that? So let's just call it something like result. Okay, and so this means that the data that comes back from this fetch AJAX request will be called result here in this callback function. Okay, and so let's simply log it to the console. Console.log the result. And let's also add the callback here for the case that there was an error. And let's just log it to the console also. Let's see how that works. And all right, so now you see this response object here. So it has all of these fields here, but what really matters to us is this body field. And what you see now here is that this is a readable stream. Okay, so that's a bit weird. And what this means is that we first have to process this response here with JSON so that we can then get the actual result that we're looking for. Okay, so the body here is where the actual result is stored, but it's now as a readable stream. And so we actually have to convert it from JSON to JavaScript, just like I mentioned before. And how we do that? Well, it's actually very easy. We just use the JSON method on this result. And this JSON method, it also actually returns a promise. And so we have to handle the result of that. And so again, we use the then method, and we also chain it like we did in a lecture before. Remember that? So just like before, we can return a promise here and then add a new then method right after this. So chaining or asynchronous operations here, one after the other. So let's return result.json. Okay, and so this here will return a promise because this actually happens asynchronously, this conversion to JSON, because it can take some time. And so therefore it happens asynchronously in the background. And as soon as it's ready, it then comes back with the data. And so we need to handle that. And so we add a new then method. Okay, and so let's call this one here data now. And let's simply log it to the console once more. Okay, let's fire it off. And here we go. So that is our JavaScript object now containing the data that we were looking for. Great, right? So we just did our very first AJAX call using fetch and promises. Okay, and if you now take a look at this, this should be the exact data that we had here in this example, right? So you have the weather data here, which is an array. So consolidated weather, then this array with all of these days, and then the remaining data that we had here. And you see that this is still San Francisco. Okay, so all that we need is actually right here. Now to make this a bit more fun, let's actually log something more exciting to the console than just this entire object. Okay, so we don't want to log all of this to the console, but instead let's just get this weather here for the first day and then log some string to the console telling how the weather is today. So const today is data, because that's this entire object here. Then we have a consolidated weather, and let's just copy this one from here. So remember that this is the array, and then today is of course the first one. So number 0. So that is today. And so let's log to the console some kind of string. So we're using template strings here. Temperatures in, and let's add the name of the city. And you see that this one is stored in this title. Okay, so we have data.title, stay between, and so now let's just use the max temperature and the min temperature. So it is min and max. So min temperature, let's just write it out, okay, that's easier. So we have today dot min temp and today dot max temp. All right, let's check it out. It takes some time to get the data, and then temperatures in San Francisco stay between 7.52 and 1136 degrees Celsius. So this is probably in degrees Celsius here, which is what we use outside the US, as you probably know. So great. Let's just put this here maybe in a function. So let's just say function get weather, and then we pass an where on earth ID into it. So to make this a bit more like reusable. So get weather, and then we use this one here as our ID. And so in here we just want this ID. So let's use a template string here. Oh, that's not, yeah. All right, so let's take a look at here at the example. And so another one here was London. Okay, and so the ID here is this one. And so let's just call it now for London as well. So get weather. And so let's test it out now. And it's okay. So San Francisco, the first one, and the second one is London. So it's working just fine. Now let's just see what happens if we put some weird number here that doesn't really return any result. So something like this, which is probably not a valid ID. So let's see. And so what we get here first is a 404. So basically this means that it didn't find anything. And so that's an error coming right from line 98. So right from this fetch function here. But then we also get this error here, which is a type error, cannot read property 0 of undefined. And so that one comes from line 108. And so that means that somewhere here in this chain, there was an error. And so we could now add some more logic here in this catch method to actually handle that error properly. Okay, but this was just to show you an example. What we really want is, of course, for this to work just fine. And that's it. That's a very simple AJAX call using fetch and promises using then and the catch methods. So I hope that made sense to you, how we use fetch, how we handle the result, and how we convert it here to JSON, which returns this new promise. Then down here, we simply analyze the response, and based on that, we then simply printed these pieces of data to the console that we're interested in here. And so this is how you do it with the then and catch method to handle this promise. But in the next lecture, I'm going to show you how we can use async await again to handle the data that comes back from the server. And so once again, you will see that it's actually much easier and nicer to use also. So stay tuned for that next lecture. After doing an AJAX call with fetch and ES6 promises in the last lecture, let's now use async await to consume the promises in an easier way. So what we're interested in here is to create an asynchronous version of this same function that we did in the last lecture. So let's call this one here async function getWeather, then AW for async await, and again the where on earth ID. Okay, and then let's also call it just like we did here for the first one. Now, how do we do the code here using async await? Well, it's actually not hard at all. So let's first of all copy this line of code here because it's going to be the same. And so this is the one that actually fetches the data. Now with async await, remember we don't use then and catch, but instead we use await. So we create a new variable, const result, and then await the fetch. So the fetch will then get the data from the server while the execution here in this function stops. And then once it's done, so once the promise is fulfilled, it will then assign the result of this promise here to this variable. Okay, and that's it. So the execution stops here and then it goes to the next line. And so what we want to do now is just like we did before, is to then create this to JSON using the .json method. Okay, and that's also very simple because it is also a promise. And so we are simply going to await it. So again, let me call it data here and await the result .json. Okay, does that make sense? And finally, we will just log it to the console. And let's actually remove this logging here from this one so that we only end up with the strings. And here we go. So these are our two results for both London and San Francisco. Great. So once again, this is working, this time with async await. So in a much easier way, I think, than what we had up here. Okay. Once again, because it looks like it is synchronous code, while in reality it's not. All that really happens is that the function is called and then in the background it runs all of this code that we have here. And so it's okay that the code stops here with the await expression because this entire function here is running in the background anyway, and so it's not blocking the main thread that's running in the JavaScript engine. Okay, and so here we have our two sequential promises which are both awaited. First this one and then this one, and finally we log it to the console. Now let's do something similar to this one here. So just that we end up with a similar structure. And so, yeah, let's log it. And so we are sure that everything works the same. And so you see that for London, it's the same. For San Francisco, it's the same. Now let's just change it a bit to, we actually want it to tomorrow. And so we need the second element of this weather array. So let's add it here to the also tomorrow. And then up here we can say temperatures today. Take a look at it. And oh, okay, here we have an error now. And actually that's a good time for showing you how to handle errors with async await. So remember that I told you before that in order to handle errors with async await, we cannot use, of course, this catch method. But instead we use something else. And I told you I would show it to you later. And so now let me do that. And so this has actually nothing to do with async await, but it's just something that is available to us in JavaScript, which is called try catch. So let me just show you how it works, and then I explain it to you afterwards. So we basically wrap all our code into a try statement. And so this code here will all get executed, but if there is an error, then it will be catched. And so we add this catch statement here, and then we say what we want to happen when there is an error. And so let's once more just log the error to the console. Okay, so this is called the try catch statement again, and so it tries to execute this code, but if there is an error, then it will jump here to this part. And so let's try what happens now. Okay, and so now it doesn't really throw these errors, so it's not red like it was before, but it simply logged these to the console like this. And we can also say alert instead of logging it, and so that will like create this window. Okay, and so now you see here the today is not defined, and you don't see the error here in the console at all. Okay, and so we catch that error here with this part of the catch statement. Okay. Now let's actually fix this error that we had here, because it's of course not today, but tomorrow. And so let's see what happens now. And all right, so we have the weather for San Francisco both today and tomorrow, and the same for London. And it doesn't really appear in the same order here. So we called San Francisco first and London second, but for some reason the data for London came back first, and only then San Francisco came back. And so that's why it then happens here in this order. But that's not a problem at all. That's just a good proof that actually this function here runs in the background, okay? And so the results do not appear in the order that they were called, so that they are here in the code. Okay, so this is just working just fine. Now, a final thing is that I want to show you is that we want to return some data from this function. And you already know that an async function always returns a promise. And so let's use that. So let's return the entire data here. And so you already know that what we return from an async function will be the resolved value of the promise that this function here returns, right? So that's what we talked about in the last async await lecture. And so let's pretend that we want to actually store this data for this London. And let me show you how it's not going to work. So data London get weather AW. And then let's try to log it to the console. Data London. Okay, and again, this is not going to work, and I want you to think why it doesn't work. And so you already see the result here. So again, it says just the promise here and not really the result that we wanted. And that's again because this console.log statement here happens way before this data actually comes back. And so we run this function at a time where we don't already have that data. Now, if we want this to really work, then we need to use the then method in order to handle the result value of this promise, right? So let's actually do it the other way around. So we need to declare this at a variable that is not constant. And so for that, we use let, remember? And we can then very simply handle the result of the promise. So data. And now we can say that we want data London to be equal to the data that came back, right? So what will happen now? Let's take a look. And well, of course, it still didn't work because it's now undefined, because this here, of course, still happens only after this console log here finished running. So if we wanted to really log it, then I guess we would have to make a bigger function here. All right, and so now it is going to work. So that's the data for London here. So does it make sense? Again, this is because this async function here returns a promise, right? And the data that we return from this async function will be the resolved value of that promise. And so we can have access to it by using the then method on this promise here, right? Then we can log it like we did here, and then of course play around with the data as we wish. All right, so this is actually something that we're going to use later in the project, and it's also important to notice here for your own projects in the future. And so yeah, I wanted to really show you how this works once again. And so now we did AJAX calls using both promises and async await, and so you're now ready to start working on the big project that's coming up right in the next section. So I hope to see you there real soon. Welcome back to the next real-world project. So now it's time to use everything that you learned about ES6 and asynchronous JavaScript in order to build yet another beautiful real project. This time interacting with a real API to fetch and display some real food recipe data. And along the way, you're also going to be using some modern JavaScript tools that every modern developer uses these days. Things like Webpack to bundle together JavaScript modules, and Babel to convert ES6 code back to ES5. So besides applying all these cool ES6, ES7 and ES8 features to a real context, we're also going to be building a modern workflow that you can use in all your future projects. So this is really exciting stuff. And this is by far my favorite project in the course. And so I can't wait to show it to you now. Alright, now before we do anything else in this section, let's take a look at the project that we're going to build to get you really excited, okay? And so here it is. This is the project that we're going to build throughout this section. And it's a small app called Forkify, and it is a very simple recipe searching app. So in here it says search over 1 million recipes, and these recipes, they actually come from a real API that I selected for this project. And so of course we're going to do all that cool stuff like the asynchronous JavaScript and AJAX and APIs, all of that we talked in the last section. So to try it, let's search for something like pizza, because you know everyone loves pizza, right? And so now it's fetching this data here from a real world API, again, as I mentioned. And so we have then 30 search results, and we have this pagination here. So we hit page 2, 1, 3, and then we can scroll through these different results. And of course we can select one of these recipes, and again it then loads it from the external API, and as soon as it loads the recipe it stops that spinner and then displays the recipe. Okay, so we have an image, then we have here the ingredients, and we can also adjust the number of servings. So we can hit these buttons and you see that the amount of ingredients then automatically adjusts. So we can move up and down, and let's say we want this one to be for 6 people. We can then also add these ingredients to a shopping list like this, which then appears here on the right side. So cool, right? We can then also adjust these numbers here like this, or we can of course delete some ingredients if we already have them at home, right? What's more, well, down here is a button where we can then click, which takes us to the website where the instructions for the recipe actually are. Okay. And then finally, another cool feature is that we can save these recipes in our favorites. So we hit this like button here, and then you see up here we now have this list of our liked recipes. So let's now try another one. Let's open this one here, let's say. And we can now also add these to the list, for example. And you see that then we have the 3 down here now as well. And we can of course also like it. And so now you see that we have 2 here. And let's try it with another one. Let's add this one as well. And so now we have these 3 here in the list. And the coolest part is that this actually works even after reloading the page. Or let's say that we open this again. So let's copy the URL, open it to a new tab, close the old one, and you see that the likes, they are still here. And so this is by using something called local storage, which is a cool JavaScript API that we're going to learn a bit later. And so, yeah, I think that's the main parts, the main features of this app. And I really hope that you love it. Because once again, I tried to make it a real beautiful and real world app so that you're really proud after coding this app after all these lectures. So that is the app, and I already opened the starter code that I hope that you downloaded already. So I opened it here in VS Code by hitting here this open command. Okay. And so we simply have 2 folders in the starter file. It's the source folder and the distribution folder. And in the source folder is where, of course, the source code will go. So our JavaScript code and the index.html file. So our markup here. And then in the distribution folder here is where the final files go, ready to be deployed and ready to be served to the client. So of course, we're going to go a bit deeper into all of this a bit later. But for now, just know that the final CSS file is here as well as the image, and our compiled JavaScript file will also be here. But again, a bit more on that later. You can also see the CSS file here. And if you're interested in the styling of the app, then of course you can dive deep into this file and see all the CSS code that I wrote just for this app. And you see that I actually used some pretty advanced and modern CSS techniques like CSS grid here and a lot of flexbox as well. So this is really a cutting edge CSS as well. So if you're interested in that, then please take a look. It's for free, also included in this project. Okay, and so that's it for this video. Next up, we're going to talk a bit about modern JavaScript and the development setup that we're going to use to build this beautiful and real-world app. Now that we know what this project is all about, let's take a look at modern JavaScript. So the way we write JavaScript has changed tremendously during the last couple of years. Today, we compile ES6 and even newer JavaScript versions down to ES5. We use module bundlers, task runners, external packages, and other dev tools. So up until this point of the course, we have always coded JavaScript in the kind of old school way, okay? But that's about to change with this project, where we're finally going to use JavaScript the modern, more real-world way. Now, modern JavaScript is not so much about the language itself, but it's more about the whole JavaScript ecosystem and environment that we use to write it in, okay? And this one is important to understand. So we still write the exact same JavaScript, but we use it together with a set of tools that make it easier and better to work with. And the foundation of all these tools is the Node.js and NPM ecosystem, where we can find all kinds of third-party open source tools and libraries and frameworks needed for modern web development. And with libraries and frameworks, I mean stuff like React or Angular, or libraries like Lodash or even jQuery. Then we also have development tools, like for task automations, automatic browser reloading, or to compile JavaScript down to ES5. Now, in order to use and share these packages, we need some kind of tool to install and to manage them. And that's where the Node Package Manager, or NPM, comes in. So NPM is just a simple command line interface that allows us to do exactly that. Plus, NPM also allows us to write scripts to use our development tools, but more on that a bit later. Alright, so the first tool that we use in modern JavaScript is Babel, in order to convert cutting-edge JavaScript like ES6, ES7, or even ES8, which together are simply called ES-Next, back to ES5. So that all browsers are capable of understanding our code. In a couple of years, this might no longer be necessary, but for now, this is an important step in our development process. Next up, we want to use ES6 modules in order to make our code more modular and therefore easier to maintain by separating different parts of our app into different files. And ES6 brought us exactly that possibility by implementing modules. Now, the problem with these modules is that right now, browsers do not really support this functionality yet, and so we have to bundle these modules together into a single file using something called a module bundler. And the most popular one out there is called Webpack, and so that's the one that we're going to use in this project. Now, Webpack can actually do so much more than just bundling modules, like code splitting, loading many types of assets like Sass or images, decreasing our JavaScript bundle size using an algorithm called tree shaking, and much, much more. But in this project, we're not going to do any of that. We just want to use Webpack to bundle all the modules together. And there are other, way more simple ways to do only this, but I wanted to show you Webpack because, once again, it's really the most popular choice out there. So Babel and Webpack are the main tools that we're going to use, and as I mentioned, these are NPM packages. And the easiest way to run these packages is by using something called NPM scripts, which allows us to run all these tools automatically and very easily in our command line interface. Alright, and that's actually all we need in order to build our modern JavaScript setup. So now that we know all about it, let's set up our development workflow over the next couple of lectures with NPM packages, Webpack, and Babel. Now, before we can use the exciting tools that I showed you in the last lecture, we need to learn a bit about the command line. Yeah, you heard that right. These tools only work in the command line. And so now comes that time where you finally have to learn about it, at least the basics, like moving around in the file system, creating files and folders, copying files, and stuff like that. And I know that many people are afraid of the command line for some reason. And I was afraid myself some years ago, I admit it. But now I love the command line, and I really can't live without it, really. And so can't any serious web developer. It's just part of the job, okay? Now, if you already know this stuff, then please feel free to move on to the next lecture, as you're probably not going to learn anything new here. But for the rest of us, let's get to it. Now, the command line works a bit differently whether you're on Windows, Mac, or Linux. So on a Mac, it is called the terminal, and so let's open it up by opening up the terminal app. Make it a bit bigger so you can actually see me typing, and that should be okay. Now on Windows, the command line is called command prompt, and you can open it up by right-clicking on the Start button, and from there choose the command prompt, okay? Now, the commands are also a bit different on Windows and on Unix, which is Linux and Mac, okay? So here I'm going to type the ones for Linux and Mac, okay? But I'm going to tell you the ones for Windows as we go, so that if you're on Windows, you can follow this video as well. So that being said, the main concept of the command line is that we're always in a folder. And right now I'm here in the home folder, and I can see the contents of this folder by writing ls. And on Windows it's called dir, which stands for directory, so like this. But on the Mac and Linux for that matter, it is called ls, which is for list. So in my home directory I have these 8 folders here. And now I can actually move into these folders. So in the command line, I can use commands to move up and down in my folder structure, okay? So I'm on the desktop now, and so let's say we want to get into the desktop because that's where the project folder is. So you see, here on my desktop is where I have this folder for the project that we're going to work on in this section. And so now, here in the command line, I can also move into that folder. And in order to do that, I have to use cd. So change directory. And this one is actually the same on Windows. So I write cd, and then I write desktop. Hit return, and now I'm in the desktop folder. And you actually can see it here. So it changed here from this home folder, which is what this here means, to the desktop folder, which is now the current folder, or the current working directory. Okay? So I can do ls again, or dir on Windows, remember? And now I see the contents of the folder. Now to move into this one here, again I use cd, and then I can write the name of the folder. Now if I start writing it like this, then I can also hit the tab, and it will then automatically complete the rest of the path for me. Because if I started writing 9f, then there's really no other path here that it could be. And so automatically the command line knows that this is what I'm trying to write. Now if you have some folder names that are similar in the beginning, then you have to write the name of the folder until it is different from all the others. And only then you can hit the tab button in order to autocomplete. So now I'm in the Forkify folder here. Let's use ls again. And so you see the dist and source folder that I showed you before. Now if we actually wanted to move up, we can also do that. And again we use cd, and then we use ... Okay, so ... always means the folder above. We are in the Forkify folder now, and if I execute this command, then we're back in the desktop. Okay, but let's actually move back into it. And if we don't want to repeat the same commands that we wrote before, we can use the up and down arrow keys on our keyboard in order to run through the commands that we wrote before. So just like this. So here you see all of the commands that I wrote before. So this is the one that we want to move back into the Forkify folder, right? ls, just to make sure that we have the right folder names here. Now this is now getting a bit cluttered here, and so we can actually clear this up by writing simply clear. At least here in the Mac command line. On Windows you have to write cls, so cls like this. Okay, so I write clear, and then I am back to having this clear command line. Okay, let's now actually make a new folder here in this Forkify folder. So I'm writing mkdir, which stands for make directory. And again, this one is the same on Windows. So let me call this one here test. And so now we should see that we have 3 folders. So dist, source, and test. And we can confirm this by opening up the folder here in the Explorer. And here it is. So here is the folder that we just created in the command line. Now moving into that folder, so cd test, we can now create a new file in here also using the command line. So on Mac and Linux, the command is called touch, and then the name of the file that we want to create. So let's say I want to create test.js. Now on Windows, it is a bit different. Okay, so let me tell you how it's on Windows. On Windows, you have to write copy, null, and then the file name. Let's say also test.js. And this is actually only with one L. So this is not a mistake. It's not 2 L's, not like this. It's actually just like this. Okay, so it sounds a bit weird maybe, but this is how it works. Okay, so that's on Windows. Of course, I'm not going to execute it here, so I'm just going to get rid of it. But right now, here, if I'm in this test folder and do ls, I'm going to see this newly created file in here. Let's create another one, touch jonas.js. And indeed, now both of them are here. And again, I can confirm this here, of course, in the Explorer. So Jonas and test.js. Nice. So what can we do now next? Well, let's copy jonas.js into the main folder. Okay, so how can we do that? Well, it's actually very easy. We just need to use the cp command, and on Windows, it's simply called copy. So just like this. Okay, so cp, the name of the file, jonas.js, and then the directory. And I want to copy it into the parent folder. And remember how we write the parent folder? Well, just these two dots, right? So let's execute it, move up into the Forkify folder, and then let's check it out. And indeed, we have dist, source, and test folders, and then the jonas.js file that I just copied here. So again, I'm going to confirm it, and here it is. And of course, it's still here. Because we didn't move it, we did copy it. Okay, and since we're talking about moving, let's then go back into this folder and move the other file out of the test folder into the home folder. Okay, so cd into test. And now to move, we use the mv command on the Mac, and on Windows, just move. Okay, so mv, the test file, and actually this also works with files. So I can simply hit the tab key, and then it auto-completes the file name here as well. So mv test.js to the parent folder, so dot again, and here we go. Now if I do ls here now, we should only have the jonas.js file left, right? And indeed, here we go. And if we go up, well, you already know that it worked, I'm sure. And indeed, now test and jonas.js are both here. So that's how we create folders and files and copy and move them. Now, as a final step, let's also learn how to delete these files. Okay, so from here, I'm going to delete jonas.js and test.js. So in order to do that, I'm going to use the rm command. So rm jonas.js, and again, autocomplete, and then I can hit return. But be careful here, because this remove command will actually remove it permanently. So it will not move it to the trash, but instead it will delete it immediately from your hard drive, and it's gone forever. So be really careful with this command, okay? And on Windows, this one is actually called del, so delete. So rm, and I hit return, and now it should be gone. Let's confirm it. And indeed it is gone. And actually I could have done both of them at the same time. So jonas.js and test.js here in the same command, but let's now simply do it separately with the test.js right now. And so finally they are both gone, okay? Now let's clear this command line again, move into the folder, and then remove this file here as well. So this file here. Or actually we can do better. We can simply delete this entire folder containing the file. And this way I can also show you how to delete folders. So let's actually go back. Let's take a look here. And so we want to get rid of this test folder. So on a Mac, you simply do rm again for remove, but then you have to use like an option or a flag, which is the R, which stands for recursively. And this means that it will one by one delete all the files in the folder and then the folder as well. So rm -r, which stands for the flag R, and then test. Okay, let's check it out. And now it's gone. Now in Windows, this works a bit differently, and it works like this. So it's rm dir, then /s, and then the name of the directory. So it would be something like this. Okay, not going to do that, of course. So now we're back to the original state of our folder. Just one more thing that I want to show you is how to open files directly here from the command line. So let's move into the source folder, cd source, and in here should be the index.html file. Yeah, and so let's now actually open it, and it's as simple as using the open command. And on Windows, you use start instead of open. Okay, so simply start just like this. So index, then tab to autocomplete, and now it should open in the default program, which in this case is Google Chrome. So let's try it. And here we go. So that's the index.html file here. It's unstyled because it's not connected with the CSS. But yeah, so it actually opened up the file that we asked for. And yeah, so I think that's the really basics that I had to show you here with the terminal. So again, this is really important stuff to learn because all the tools that we're going to use next run directly from the command line. And so you really need to have some basics, of course. And so I hope this lecture gave you these basics. And so let's now move on together right to the next one. Hey there! Let's now set up our development workflow, which will include npm scripts, webpack, and Babel by installing Node.js and npm on our computer. So in order to install Node.js, just head over to nodejs.org, and then down here you should have the buttons for downloading Node.js. And make sure to install the first one, which says recommend for most users. And maybe you're on another version, maybe it's not 8.10, which is the most current version by the time of recording this video, but anything above 8.10 should be fine. So I'm not going to download and install it right now, because of course I already have it installed, but please go ahead and do that now. Then after everything installed correctly and you're ready, open up your terminal so that we can confirm if Node.js actually installed correctly. And in order to do that, simply write node and then -v. And this will check the version that you have installed of Node. And so in this case, I'm on 8.9.4. And if you see the version number of Node that you just installed, then it means that you were successful. So everything's working fine. Now, if you get an error here, then it means that Node is not correctly installed and you should probably go back and try it again or something. Also, we can check out if npm was also installed, because npm, the Node package manager, automatically comes with Node. And so by typing npm also -v, so flag for version, then you should also get your version number, which in this case is 5.6.0, but if you get anything above that, it should work just fine. Okay, and with Node now installed, let's go ahead and create a package.json file for our project. And I'm going to explain a bit later what exactly that is. For now, let's just move into our project folder and create that package.json file in there. So here in the terminal, remember we use cd to move to the folders. And I'm on desktop, and then I'm on 9.4kify. Let's check it out. And here we are with the dist and source folders, just as we saw in the last lecture. Now to create our package.json file, which is basically a file which contains informations about a project for npm, we just type npm init, and then it will start asking us some questions down here. So we can say the package name, and I will just call it 4kify. You see that here in parentheses, that's the default name that is automatically taken if we don't write anything here. Then the version in 1.0.0 is okay. Description, I can say something like 4kify project. The entry point doesn't really matter at this point. Test command, git, keywords, author. You can put your own name here, license. And now we have the final result here. And we just hit return again. And so this will be our package.json file. And if we hit ls again now, we see that we already have this file in here now. So let's now head over to our text editor. And indeed, you see that it is already here. So package.json. So you see the name that we gave it, the description, and the author. Then we also have something called scripts, and we're going to talk about that a bit later. And again, I'm going to explain a bit better what this package.json file is all about. But for now, let's go ahead and install Webpack using npm. So I'm going back here to my npm. And so in order to install packages, rewrite npm install Webpack, and then we also have to say save dev. Save dev. And what this save dev option here means is that it will save Webpack as a development dependency of our project. So you will see this in our package.json file in a second after Webpack has installed. And so that's it. Let's now go back to our package.json file, and indeed, here it is. So we saved Webpack as a dev dependency by using the save dev option, right? And so now in our package.json file, it created this dev dependencies field, to which it added the Webpack package on the current version 4.2.0, okay? So remember in the intro lecture about modern JavaScript that I mentioned that we basically have two types of Node.js packages. Ones are libraries and frameworks and stuff like that, and others are development tools. So libraries like React or jQuery, for example, they are really dependencies because we use this code in our project, in our app. But something like Webpack, this is really just a development tool. And so it's here in the dev dependencies field. Now imagine that we wanted to use something like jQuery here. Then we can also go ahead and install it. So let's say npm install jQuery, but this time we only say save. Okay, and so this will not save it as a dev dependency, but as a dependency. So let's go ahead and check that one out. And indeed, here it is. So dev dependencies is Webpack right now, and dependencies is jQuery. Okay, and so this file here now has all of these informations listing all of the packages, so all of the dependencies that we use in our project. And that's very important because if you want to move this project to another computer or work with another person on the same project, then everyone's on the same page, so everyone knows which dependency we're using in our app. It's also important because it allows us to install all of these dependencies here automatically if we don't have this node modules folder. Okay, so this folder here is where all the packages go. So let's take a look at it. And you see that these are all the packages right now in our node modules folder. And they are here because these are actually the dependencies of these dependencies. So for example, Webpack or jQuery, they themselves have lots of dependencies. And so we need to install all of these here automatically in order for Webpack and jQuery to work. Okay, now if we went to share our entire project here with someone else, we wouldn't have to share this huge folder here, which has these thousands and thousands of files. We really wouldn't need to share. All we need to share is this package.json file, which has this information about our dependencies. And the other person could then go ahead and automatically install these dependencies. And so let me actually show how we could do that. So let's actually go ahead and remove this folder. Okay, and so now all our dependencies are actually gone. So we have no more dependencies, but we have our package.json file, which lists the dependencies that we have, so Webpack and jQuery. So if we now go ahead and simply type npm install, then it will go ahead, grab our dependencies from the package.json file and install all of them. So let's go back, and here it is again. So here is the folder again with all the packages back in there. Now, one last thing is that we also can uninstall packages. So right now we don't really need jQuery here. So let's go ahead and delete it, so to uninstall it. And all we have to do is to say npm uninstall jQuery and again save. And so let's wait for it. And if we go back, now you see that this object here is empty. So no more dependencies. We have only this Webpack dependency right now. Okay, so that's installing and uninstalling. Now, before we leave, actually there's still one more thing that I want to mention, which is that these packages that we installed here with the save dev and save options, they are locally installed. So they are installed only for this project, but we can also install packages globally. Okay, so basically in order to make them accessible from everywhere on our computer. Right now this Webpack dependency only works inside of this project. But if we wanted to install it globally and make it accessible from everywhere, we could also do that. So let me show you how. And actually we're going to do that with another package, so not Webpack, but instead let's use something called Live Server, which is another package that I really like, which allows us to create a very simple and local web server to serve some static websites. So again, npm install, name of the package, and then instead of save or save dev, we can simply say global. And now let me show it to you. And yeah, so we got this error here, which is basically because we don't have permissions to do this. So on Mac and Linux, you have to prefix this command here with sudo in order to give permission to do this. On Windows, maybe this is not necessary, but usually here on a Mac, this is what happens when you install global packages. So let's try it again. I will put in my password, and now it should install globally. Okay, and so remember that this was installed globally, and so I should be able to run this command now from everywhere. So let's move out of this folder actually. And so now I'm back on the desktop, so on a completely different folder, and I can now run this command just like any other command in here in the command line. So live server, and now this is not going to work actually, but let me show what happens. And actually it did work. So it opened here a local web server here on this port, showing me the folders that are in the current directory. Okay, so let's go back to the terminal. And here you see, so serving users, and then here the URL. Now to exit this program here, let's hit Ctrl+C. And so in order to move out of this program. Okay, so this was just to show you that there are locally installed packages with safe and safe dev, and then we can also use globally installed packages, like we did here with this live server example. Okay, now let's move back into our project folder, clear this console, and yeah, so I think that's all that I had to show you in this video. So we installed Node.js, then we used the npm package manager in order to install dependencies, and remember there are dev dependencies, which are only tools that we use for development, and then they are like real dependency, so code that is actually used in our app. So imagine we're building a React app, then of course we need to use the React API, and so that's going to be a real dependency, okay? Then besides these two locally installed packages, we have the global packages, which we install using the global flag here in the command line, which can, instead of global, you can also write, so instead of writing this, you can also simply use the .g flag, okay, which is a lot easier. So that's it. In the next lecture, we're then going to go ahead and configure Webpack. In this lecture, you will learn how to create a basic Webpack configuration. So Webpack is the most commonly used asset bundler. So it doesn't actually not only bundle JavaScript files or modules, but it bundles all kinds of assets like JavaScript, CSS, and images, okay? So we see here, like on this left side, all of these dependencies, all of these files, like depending on one each other. And Webpack then bundles these together into just one JavaScript file, one CSS file, and then these images here, okay? Now in our case, we're not interested in CSS or the images, we just want to bundle all of our JavaScript files into one big bundle, okay? So I'm going to use Webpack 4 here, which by the time of recording is the most current version available, okay? And this version actually now supports something called zero configuration, where you don't even need to write a configuration file, okay? So if you want to do that, you just need to have one source folder in the root, and then in there one index.js file. And Webpack then will automatically create a distribution folder and put the bundled file in there. But that's just for really small apps, and so that's not really what we're interested in, okay? And so we will write some configuration. And in order to do that, let's go back to our text editor and add a file here called webpack.config.js. So this is just a regular JavaScript file. You can see it here, but actually Visual Studio Code identifies this file here as a Webpack configuration file with this icon here, okay? Now in here we have one object in which we can specify our settings or configuration, okay? So just one object, and then we want to basically export this object from this file using the Node.js syntax, okay? And that works like this. So module.exports, and then we export here this object, okay? So don't worry about understanding this part here. This doesn't really matter. This is just, again, to export this configuration object that we're about to write here, so that Webpack then can take this object and work with it, okay? Now, to create this configuration, we need to know that in Webpack there are 4 core concepts. It's the entry point, the output, loaders, and plugins. And we will just do a very simple config here because, again, our app is fairly simple. So starting with the entry point, all we need to do is to specify the entry property here in this object. And the entry point is where Webpack will start the bundling. So basically this is the file where it will start looking for all the dependencies which it should then bundle together. Okay, so we're going to start seeing how this really works once we start experimenting with this, right? Now in here we can specify one or more entry files, but for now we just want one entry file, and that is this index.js file. Okay, so let's now simply specify the path to that, and it is dot, and what dot means here is the current folder. Okay, so just like in the command line, when we have dot dot, So something like this. This means go up to the parent folder, but just one dot is the current folder. So current folder, which is the project folder, then go into the source folder, then JS, and here it's index.js. And that's it. That is our entry point. So that's the first property in this object here. Next up, we need to define the output property, which will tell Webpack exactly where to save our bundle file. So we specify the output property, and now in here we actually pass an object. And then in this object, we put the path, so the path to the folder, and then the file name. So path, and I'm going to leave it empty for now, and then the file name. And as a file name, we simply want bundle.js. So that's kind of a standard name for a Webpack output. Now about this path here, this actually needs to be an absolute path here. And in order to have access to that absolute path, we need to use a built-in node package. Okay, so let's include that node package here. And it works like this. Require path. Okay, so again, don't worry about the syntax here. This is just to include a built-in a node module, again, called path, and then put it in the path variable. Now in here, what we want to do then is to use a method which is in the path package, so path.resolve, and then we use the dir name variable that node gives us access to. So this variable here, this is the current absolute path. And so we use path resolve to now join this current path, so the working directory, the Forkify directory, with the one that we want our bundle to be in, which is dist, right? And then in there, JS. Okay, does it make sense? So again, this path resolve, which is a method which is available to us through this path package that we included up here in this line, we will then join the current absolute path with the one that we want our bundle to be in. So dist/js. So basically this folder here, right? And so now Webpack will output our file to this directory with this bundle.js file name. And that is now actually all that we need in order to get started. Now we can just make this a little bit better, because in Webpack 4, we now have something called the production and the development mode. So the development mode simply builds our bundle without minifying our code in order to be as fast as possible. But the production mode will automatically enable all kinds of optimization, like minification and tree shaking, in order to reduce the final bundle size. Okay, so that is another property that we can set. For example, by saying mode development. Okay, and so now it will be as fast as possible and not compress our code, because that's not necessary during development. Okay, so for now that's our very simple configuration. Later on we are going to look at loaders and plugins as well, but for now we just want to specify the entry and the output, and also the mode here. Now in order to actually test this out, we need to create a new JavaScript file. Okay, so right now we have the index.js, which is our entry point, remember? And so now let's say that we want to include a new module in here, so that we can actually test if the other module is included, so if they are bundled together. So just for testing purposes, let's add a new file here called test.js. And in here, let's say console.log imported module. Okay, and then we can also export something from here. So we say export default, and now let's just export some number here. So let's say just 23. Okay, and so this is the official ES6 module syntax that we're using here. So if you want to export something, we use the export keyword, and then we can have a default export or a named export. And I'm going to explain all of this in one of the later lectures when we're going to start implementing our app's architecture using ES6 modules. But for now, just keep in mind that this is the easiest and standard way of exporting something from a module. Okay, so we have a console log, and then we export something from this module. And now here in the index.js file, which is our entry point, we can then go ahead and import something. So we have to give it a name, a variable name. So import x from, and then the name of the module, which in this case is test. So the current folder slash and then test. And now when we import from a module, we don't even have to specify the .js. So all we need to do is write test, which is the name of the module, and what we exported. So remember, we exported this 23 here. This will then be saved into the x variable, okay? Because we called it x. We could call it also number or num, for example. So that doesn't really matter. But right now we have access to what we exported from this module here into this num variable. Okay, so let's now log that to the console. So console.log, and let's say I imported num from another module. Okay, and now right now this wouldn't actually work in the browser if we weren't to use Webpack. So we really need Webpack now in order to bundle these together. Okay, so again, this is only going to work with Webpack or some other bundler. And that is exactly why we're actually using it. So we have our example set up. Now there's just one last thing that we have to do, which is to go to our package.json and add an npm script. So let me now do that, and then I'm going to explain you what an npm script actually is. So let's call this one dev, which stands for development, and then we don't want any of this. So what we want here is to call Webpack, and actually that's it. So all we need to do here is to actually call Webpack. So as soon as we start the npm script called dev, it will then open up Webpack, look up our configuration here, and then do the work that we specified here. So it will read our entry file, do its work, and output it exactly here as we specified. And why do we have to use an npm script for this? Well, because that's just the only way, or at least the best way, to launch our locally installed dev dependency, just like Webpack is. Okay, now actually in order for this to work, we need to do one more thing, which is to install the Webpack command line interface. So right now we only have Webpack, but we need something to be able to access it through the command line interface. And so there's another package for that one. Okay, so Webpack, they could have done it all in one package, but they decided to put that functionality of accessing it via the command line in a separate package. So let's install that very quickly as well. So we already know how to do that. So npm install, and this one is called Webpack CLI. So it's also an official Webpack package from the same authors. It's just to get access to Webpack through the command line interface. And again, we want to save it in our dev dependencies, hit return, and wait for it to install. So here we go. Let's check it out. And here you go. It's now actually in our dev dependencies here as well. So right now we're ready to launch this npm script. And it's actually very easy. All we have to do is to go back to our terminal, say npm, and then run. So run is the keyword if we want to start one of our npm scripts. And this one is called dev. And so let's hit return and see Webpack doing its work. And that's it. So it's already finished. You see bundle.js with a size of 3.59 kilobytes. And so let's check it out. And here you see it's actually right here. Let's open it up, and you see it looks really weird. So it has all of this code. And down here, like really inside of this, you see some of the code that we wrote. So something like this here, I imported, and then all of this weird code. So it's really hard to understand what Webpack does behind the scene, and it doesn't really matter to us. All we want is for this to actually work, right? And now one final thing that we need to do in order to test this is just to create a quick HTML file here inside of this dist folder, just to include the bundle file and to see in the console if everything's working fine. I could just use this one that we already have here, but I can just create a new one as well. So index.html. Then I use Emmet here, and I'm not sure if you're aware of this tool, but in VS Code at least Emmet already comes pre-installed, and so all you have to do is to write this exclamation point, hit the tab, and then it will write this pre-formatted HTML skeleton for you. Okay, so let's just include a script here. JS bundle.js. Okay, so I'm going to call this one here test, and so let's open it up. And let's actually do that from the console, okay? So open dist index.html. Hit return, and here we go. So that opened that HTML document hit inspect to open the console, and here we see the result. So you see, imported module, and then I imported 23 from another module. So that's perfect, right? So this imported module here comes from the test.js. So this one here. Then we export 23 back into index.js, where it's saved as num, put into the string, and logged to the console. And you see that 23 is exactly the number that we exported from test.js, right? And you see now that it's perfectly working. So that's amazing, right? Webpack is already configured. Everything is working just fine. And so yeah, that's fantastic. Now one last thing here regarding this mode that we have here. So we set it to development, but once we're ready, we then want to set it back to production. But that's not really perfect, having to come back to this configuration file here in order to change this. And so we can actually move it here out of the config and into our npm script. So let me show that to you. So we delete it from here, come to the npm script here, the dev one, and then we can actually set that mode right here. So mode and then development. Okay, and then what we can do next is to add a new script called build, which is also for Webpack, but with a new mode, which is then finally production. Okay, and so let's use this one now. So the dev one is now for development, and build is once we're ready, we build it then with the production mode so that it will then compress our code. So let's test that here back in the terminal. Let's clear this here, and I can actually use Command K, at least on the Mac. I'm not sure how it works on Windows. And then let's say npm run build. Then it will do its work. And you see that right now it's much smaller. Remember that it was like 3 point something before, and now it's only 647 bytes. So it's much smaller, and we can see that here as well when we open it. And so, whoa, now it's just this small piece of code. All right. So all of this was compressed to just this piece of code, right? Now, running these commands here, these npm scripts, over and over again, whenever we want to see the result of the code we just wrote, is of course not perfect. And so in the next lecture, we will make our lives a bit easier by installing something called the Webpack dev server. But that one I'm going to leave for the next lecture, because right now I think this is already more than enough for just one video. So see you then in a second. Now, in order to make our lives a bit easier when writing JavaScript, we're going to add the Webpack dev server to our setup in order to automatically reload the page when we save our code. So besides all the amazing functionality, including in Webpack, it also provides us with a development server, which will automatically bundle all our JavaScript files and then reload the app in the browser whenever we change a file. And this is of course a huge time saver and makes coding a lot more fun. Now let's start by actually installing it, because again, Webpack dev server is an npm package, and so let's install it. So npm install Webpack dev server, and then again, of course, we're gonna save it as a dependency, so a dev dependency. All right, let's go back just to check out the package.json file, and confirming that, of course, it is now added here to our dev dependencies. Now, in order to configure this dev server, let's go back to our config file here and add yet another field here. And this one is simply called dev server. And in here, we pass an object in which we can then specify a couple of things. Now, the first one is the content base. So content base. And in here, we will specify the folder from which Webpack should serve our files. And in this case, that is the distribution folder. So dist, so this folder here. And that is because basically this is here the code that we're going to ship to the client. So our app, all of the final code of that app is here inside of this distribution folder. So we will always have an index file with the HTML, then the JavaScript image and CSS. And so as I explained at the beginning, this source folder here is only for our development purposes. So all our source code basically goes here, which then gets compiled or bundled into this distribution folder as bundle.js. And so what we really want to serve is only what's in this folder here, right? And this is actually the only thing that we have to specify in this case. We can also specify the port, but a bit more on that later. So for now, let's just leave it at this. And now to make it work, again, let's just add a new npm script here. Okay, and one of the standard names for this kind of stuff is called start. So a script start will always be a script that keeps running in the background and updates the browser as soon as we change our code. Okay, so this is again kind of a standard name, just like dev and build. So these are all standard names that you will find in other projects as well. So start, and what we want here to happen is to run webpack dev server with the mode of development. So just like here, we pass the development option, and then we can also specify another option, which is open. And all what that means is that it will actually open up the page in the browser automatically. Okay, so let's actually try this out. So this should already be enough here. So let's open up our console or our terminal and write npm run start. Hit return, and here we go. So this is again the same page that we had before, and let's open up the console again, and we see that it's actually working. Well, there's one thing missing here, but that's just the favicon, so that doesn't really matter. So you can just ignore this error if you get it as well. And so you see that it's actually the exact same thing as here. But the difference is that this code here is now running on a real web server. It's a local web server, so it's localhost on the port 8080, but it's simulating a real HTTP server. While this one here is just a regular file opening. So you see it here, it's like it's the file protocol, and then the entire path that we have here. Okay, so this here is much better because this simulates a real environment with a real HTTP server. So let's close this one up here and leave this one open. And so we can now change some stuff here. So instead of returning or exporting 23 here, let's export 99 or something like that. And then we can also change this text here in the index.js called test.js. So let's save these two, go back, and you will see that this should now automatically reload. And actually it did not, so let's take a look at the terminal here. And it actually says that it did recompile these two files here, but still, for some reason, this is not really working here. And if we reload it ourselves, then it still says here this what we had before. So let me try to restart this server here. So in order to stop this process here, because as you see, this process here is now running, it's not giving us a new line where we can continue writing commands. So it's still running. And if you wanted to open a new one, we can simply open like a new tab by hitting Command T. And on Windows, you will have to open a new window. Okay, so we can do this, or we can also stop this process here that's running by hitting Control C on the Mac. So not Command C, but Control C. Okay, and so now it's stopped. And so let's actually run it again. npm run start. Open a new one. Let's inspect it. And well, something is not working. So let's go back here, see what's going on. And I think I actually know what is going on here. So when we're running the development server, Webpack will bundle our modules together, but it will actually not write it to a file on disk, but instead it will automatically inject it into the HTML. Okay, and so we could actually go ahead and delete this bundle file here, because right now it still looks the same here in this console, because it's still simply reading the result from this bundle.js file and not from the one that we're generating on the fly, so through the dev server, because there's something that's wrong here. And the problem is that the output path here is this dist and then /js. And so it will basically try to inject this bundle into an HTML that is here in the same folder, so also in the JavaScript folder, which is not the case. So the index.html is outside. And so we want to get rid of this part here. So the real path of the output is now only dist, and then we can put the JS here in this file name. Okay, so this is no problem. This works just the exact same way. All we're saying is that really now the output folder is this entire dist folder here. Okay, and no longer just the JavaScript folder. And this will be important for something else, as I will show you in a minute after we have this working. Okay, and so this dist folder here is now the exact same as here. And so now it should actually be working. All right, so let's actually quit this here, clear the console, and run npm start again. Open up the console again, and whoa, here you see, now it's finally working. I imported 99 from another module called test.js, and so that's exactly the change that we did a second ago. Now let's change it again here. Let's say to 1, 2, 3, 4, 5, save it, go back, and here we go. So now it says 1, 2, 3, 4, 5. Awesome, right? So without us having to reload anything, it does it automatically, injects it into this file here, and it just works. And let me show you that we can actually even delete this bundle here, and it will still keep working. So let's now put even more here, 8, 9, 10, or just 8, 9, okay? And here you go. So the bundle.js file is actually gone, but this here still keeps working. So great, right? Now one final thing that I want to do in this video here, besides making this development server work for us, is to also copy this index.html file into our distribution folder. So this here is basically the HTML that holds the HTML for our app, at least the bare bones structure, so to say. And we see that down here, we also have this, well, this outcome in the script here. We could even just delete it altogether. Okay, so no script tag in here, and this is our source code. Now what we want to do with this is to automatically copy it inside of the distribution folder and then inject the script tag into it automatically. And Webpack allows us to do just that very easily. So let's do that. And in order to do that, we use something called plugins. So remember, in Webpack we have entry points, output, loaders, and plugins. And so let's now talk about plugins. So basically, plugins allow us to do complex processing of our input files, and in this case of our index.html file. So we want to use a plugin called HTML Webpack plugin, and in order to use it, once again, you can probably guess it already, we have to install it. So we go back to our terminal here, and now we're using this new tab here that I created earlier. So npm install HTML Webpack plugin. Give it a save dev, and then here we go. Okay, now just like before, we have to require this package and save it to a variable. So const, and the standard here is to simply call it HTML Webpack plugin. And then use require, and then the name of the package, of course. All right, so now we installed and required, so included basically, the HTML Webpack plugin. And so now in here we can specify our next property, and this one is called plugins. And plugins basically receives an array of all the plugins that we're using. And so the first and actually only one is of course our HTML Webpack plugin. And here we're missing a comma here, of course. And all right, so in order to use it, we use new and an HTML Webpack plugin. So this is the variable from up here, because basically this is here like a function constructor. So it's like a new class. And so that's why we're using new here, as we're already used to do, right? So new HTML Webpack plugin. And then in here we pass a couple of options, again, using an object. Okay, so this is a very common pattern in modern JavaScript actually, is to always pass options using an object like this. So this entire configuration here is an object, and so is the options here for this plugin. Okay, so remember what we want to do. So we want to copy each time that we're bundling our JavaScript files. We also want to copy our source HTML into the distribution folder and include the script to our JavaScript bundle. So basically, again, this is our source, and this index here will then be our final and ready to go to production HTML file. Okay, so we specify the file name, and let's simply call it index.html, and then we use the template property. So template is basically our starting HTML file. And this one is located here at source and then index, right? So again, current directory, then source, and then index.html. Now we can also use this plugin to actually create a new HTML file from scratch automatically without providing any template. But that's kind of outside of the scope of this tutorial, okay? But you will see that there are some apps that don't even have an index.html file in their source code, but instead it's automatically generated on the fly by Webpack. All right, so let's get rid of this one here. So delete, and let's actually check out if this is going to work. So I'm stopping this process here. And now you actually see here in the background that it says disconnected. So it immediately noticed that we disconnected our server here. So let's now run it again, and it will then open a new tab. And whoa, here we go. So you see that right now we already have the Forkify app, and that's because Webpack already copied, you see it copied this index.html file into the dist folder. And as I mentioned, it's not really visible right now because it's not saving this data on the disk. Okay, so when we're using the dev server, it will not save the files on disk. It will simply like stream them to the server. Okay, so if you go now and open up inspect, then here's of course the exact same code as we had before. And that's because if we inspect the elements here, you will see that it injected this script. Okay, so just like magic, this worked just fine. Now, if you wanted to actually see these files here on disk, we would have to run one of these commands. So for example here dev or build, and this one then will actually do the bundling and save it on disk. So let's do dev here in this other tab that we have. So npm run dev, then it does it work, and now you see index.html is here and bundle as well. And now you see down here when we come here, here is the final JS bundle.js. And it is the file name that we specified here in this config, right? So exactly this one here. So this seems like magic, but that's just the work that Webpack does here behind the scenes. And it is a fantastic tool and very helpful in our development workflow. I agree that it's a bit difficult to set up. There are easier options out there, but this is also the most powerful. And so once you have the setup, you can then use it in the future for your own project, and of course do some changes to make it even better. But for our project, this is more than fine, just like this. The only thing that is missing now is to include Babel. So in order to convert ES6 down to ES5. And so that's what we're going to do next in the next lecture. All right, and now as the final step, let's integrate Babel into our workflow in order to make it really complete and ready for us to start working on the project. So as you see from the website, Babel is a JavaScript compiler in order to use next generation JavaScript today. And it can be rather complex and confusing to set it up, but we're going to use a very straightforward configuration in order to do it. And it's all here in the documentations, and you can read through it if you want. But of course, I'm going to show you now, again, the most straightforward way that there is to set up Babel. So first off, in order to make Babel work, we need again to download a couple of packages. So let's fire up our terminal, come to this one, and let's clear it up. And so the packages that we need to install are, so again, npm install, and the first one is Babel core, which contains the core functionality of the compiler. The next one is Babel preset env. And now we're doing something that we didn't do before, which is to install many packages with the same line. And that's totally possible. So we can install multiple packages in the same command. So we have Babel core, and now the next one that we want is Babel preset env. And this is a Babel preset that will take care that all the modern JavaScript features are converted back to ES5. And a bit more on this one a bit later again. And finally, we need Babel loader. And this one is needed for Webpack in order to actually load Babel files. Okay, but again, more on loaders a bit later. Now finally, give it a save dev here. And now we're going to install all of these 3 packages at the same time. So let's check it out here in the package.json file. And indeed, here we have Babel core, loader, and preset env. Okay, and now we need to learn about the concept of loaders in Webpack. So loaders in Webpack allow us to import or to load all kinds of different files, and more importantly, to also process them, like converting Sass to CSS code or convert ES6 code to ES5 JavaScript, which is exactly what we're going to do now, right? And so for that, we need the Babel loader, because Babel is the one that will convert this ES6 back to ES5. And again, the syntax for this is a bit weird. So how it works is we use module, pass in an object, and then in there, we need to specify the rules property. And rules then receives an array of all of the loaders that we want to use. And for each loader, again, we need an object, right? So again, this is all a bit weird and confusing, but you just need to set this up once. So once set up, it will keep working forever, basically, right? So for each of the loaders, we need the test property. And for this one, we use something called a regular expression, and we're going to talk a bit more about this later. Okay, so in this regular expression, what we want to say is that we want to test for all the JavaScript files. And the JavaScript files are the ones that end with .js. So we want .js at the end. And that's what this here means. So this test here will basically look for all of the files and test if they end in .js. So that's what this regular expression here means. Okay, so all of the JavaScript files will use the Babel loader. And so we use the use, and then again we pass it an object here, and then finally we use the loader property, and then we can say Babel loader. Woo! So that is really a lot here to write, and again it looks really complex here with all of these modules, rules, tests, and then use, and finally the loader. And a lot of newbies are confused by all of this, but really I don't think it's such a big problem. Okay, so Babel loader, this is the package that we installed before. So remember, it's here in our package.json. So this Babel loader package is what allows us to use this here then in Webpack. Okay, and we can actually add something more here to this rule, which is an exclude. And with exclude, we say that we want to exclude everything that's in the node modules folder. Okay, because if we wouldn't do this, then Babel would apply to all of the thousands of JavaScript files that are inside of this folder here. And we of course don't want that to happen. We just want it to do in our own project, and so we can exclude this entire folder here. And again, we use it as a regular expression here with these two slashes at the beginning and at the end. Okay, so again, what this rule does here is it tests for this .js at the end, which this one here means, and if it is a JavaScript file, then it will apply the Babel loader. Okay, and so that's how we use Babel, step 1. And step 2 is that we now actually also need a Babel config file. So not only for Webpack we need this config file, but also for Babel. So let's create a new file here. And the one for Babel is usually called Babel RC. So just .Babel RC. And once again, VS Code here actually already recognizes it here as a Babel 6 file. And so it puts this 6 here as the file icon. So in here, all we pass is just this object. And so this one is different from Webpack, which is a real JavaScript file. This one here is just a dot file. Okay, so we have this object. And then we pass preset, and into preset we pass an array and say that the preset that we want is called env. Now a preset here is a collection of code transform plugins, which are like the pieces of code that actually apply the actual transformations to our code. Okay, and the one that we select here is the env, which stands for environment. And we actually installed this here before as a plugin, right? As a package, sorry. So the Babel preset environment, okay? And so now in the config file, that is exactly the one that we use. So preset environment. So we select the preset and say that the one that we want is the environment. So the one based on environment. And now we can actually specify the environment that we want to target, okay? And by environment, I mean like the browsers. So we can do it like this, right? Target. And actually this needs to be in quotes like this. And then we pass in another object. And so once more, This is really confusing, you know. Okay, so browsers. And now, finally, we just pass in an array saying which browsers we want to target. Okay, so in here we can now say stuff like the last 5 versions. And what this will do is that Babel automatically figures out which ES6 features it actually needs to convert in order to work on the last 5 versions of all the browsers. Okay, and so that is what it means with environment. So we say which environment we want it to work, and then Babel automatically figures it out. There are of course other presets that we could use, but then we would like manually have to say what we want to convert and what not. And with this preset, well, it all just happens automatically. So we can say something like last 5 versions, we can say 2 or 10 or whatever. And we can also say something like we want at least the Internet Explorer more than 8. Okay, and we can add more stuff to this, and you can find more examples on the documentations of Babel, but I guess for now this is enough. So again, we say that the preset should be based on environment and that we want to target the browsers, the last 5 versions, and Internet Explorer greater or equal to version 8. Okay, give it a save, close it up, and we're good to go. So right now ES6 or even ES7, ES8 or ES Next, so all the future versions of ES, so of JavaScript, will be converted back to ES5. Now there are some things that we cannot really convert because they simply were not present in the ES5 version of the language. And so there's no way that we can simply convert them back from ES6 to ES5. And so these need to be polyfilled. And I'm talking about things like promises or methods like array.from, so stuff that just were not present in ES5, and so we cannot really convert them back. Okay, and so we need to polyfill them, which basically adds this to our code. So the promise object, for example, is not present in ES5, right? But we can write some ES5 code that basically implements the promise in ES5 so that we can then use it in our code. Okay, and so that is exactly what a polyfill does. So how do we use a polyfill? We need to install another package. Okay, so npm install Babel polyfill. Now this code is actually code that will be in our final code. So as I've explained, this will basically implement like a promise in ES5. And so this is not really a development tool, but it is really code that is going to go into our final bundle, right? And so this is not a dev dependency, but it's a real dependency, as I like to call it. And so we just use save and not save dev. All right, and it's installed, as you can see down here. Now all we have to do is to add it in our webpack config, and where we do it is in our entry point. So I said before that in the beginning we just had one entry point, but there can be multiple, and now we actually will have multiple. And so now we pass in an array. So let's open it and close it here. And so our entry points are now this polyfill that we just installed, and then our original entry point. Okay, so we can simply say Babel polyfill here, and Webpack will then automatically figure out where this code is located and will then bundle it together with this code that we have here. And so in the end, we have one huge bundle which has both all the polyfills for the ES6 code as well as our own code, of course, in the index.js file. Okay, so basically installing Babel was a 3-step process. First, we installed all of these packages and then added this rule here with the Babel loader. Second, we created then a config file here in order to tell Babel which stuff we want to convert back to ES5. And then finally, we also included a polyfill in order to not convert, but polyfill the features that we cannot convert with the Babel loaders. So with all of this work done, let's now finally test this. So in the index.js file, we actually have this, well, this is already ES6, so this template string. And also in here we have, well, here we don't really have any ES6. So let's also add a constant here. So const x equals 23. And let's add it now into this template string here somewhere. So num from another module called test.js. Let's just add variable x is x. Okay, so let's give it a save and then run our webpack command. Okay, so npm run dev, right? And so this will now create our bundle. And whoa, we have some errors here. So let's check it out. So there's some errors here. And we can see it's in Babel. And so we have something invalid here in our config file. Okay, so presets. And so it looks like we're missing like some parentheses there, right? So let's go back to our Babel RC file. And what we're missing is that here we actually need another brackets. Okay, so we have one brackets here, and we then need to close it in here. And what's also missing here is a missing S here. So it's presets and not just preset, and the same for target. So it's targets and not just target, okay? So give it a save now, and let's try it again. And so now it should really work. And you see, yeah, now it's done. Now it worked just fine. So let's try and open up this bundle.js file, which was just converted. And so, whoa, so you see here, let's go to the beginning, that we have this huge amount of code. And most of this actually now comes from the Babel polyfill. So you see down here when we scroll that it actually included here the Babel polyfill. And so all of this weird code here, all of this is probably coming from the Babel polyfill, okay? But we will also be able to find our own code in here. So let's grab this piece of code here and then search for it in the bundle. Then we will be able to find our own code. And so here it is. And you can already see that it actually did the compiling from ES6 to ES5. So before we had const x equals 23, and now we have var here, right? And also before we had a template string here in the console.log, and now you see these normal quotes and then the plus signs in order to join the strings, just like we did it in the ES5 way. And so this proves that Babel is now really working. It is doing the real conversion from ES6 to ES5, and it's also doing the polyfilling. So it included all of these polyfilled that we specified. Okay, and so now we're actually really done with our setup. So we used entry points, we used outputs, we used the dev server, plugins, and also loaders here in our Webpack configuration. And so I hope that you're fairly confident with using Webpack at this point. Of course, there's a ton more to learn, and you can always check out the Webpack documentation, or you can search for some tutorials online, and there's a lot more to learn actually. For example, you can use loaders for Sass in order to convert it to CSS, and that's something very popular and it's very useful as well. So you don't need to include an additional Sass converter outside of Webpack, so you can do it all inside of Webpack very nicely. But in this project, that's not really necessary. And so again, we keep it here very simple, just in order to make it work according to our needs here. So that being said, I hope you learned quite a lot in this small series of Webpack lectures so that you're now ready to really move on to the project from now on. As I've told you over and over again in this course, thinking about architecture is absolutely fundamental before starting any new project. No matter if it's a vanilla JavaScript project like the one we're about to build, or a React app, or a Node app, or whatever you're using really. So we talked a lot about architecture back in the Budgety app, and so let's do the same before starting this project. Now, this time around, we're going to use a widely used and well-known architecture called the Model View Controller Architecture, or MVC for short. Now, the main advantage of the MVC architecture is that it very nicely decouples the presentation logic from the application logic, with a controller in between them that controls the entire app. And this is actually a bit similar to what we did with the Budgety app, right? But this time around, we're going to implement it with ES6 modules, instead of using the module pattern that we used before. Because using real modules is a lot easier and a more real separation of concerns. Now, there are different ways of implementing the MVC pattern, some more complex than others, but we're going to implement it in a very straightforward way here. I just wanted to let you know that if you Google around for MVC, then you will find it coded in some different ways, okay? But anyway, let's now look at MVC in the context of our actual app. So of course, we're going to have a controller which will have its own file called index.js. So again, this will be possible thanks to ES6 modules, which allow us to make our JavaScript apps more modular by separating different aspects of the app into different files. Now, about the models, we will have one model for each of the different aspects of the app. And the same goes for the views. So again, one view file for each part of the app. In this first example, we have the search functionality. So in the search model is where we do AJAX calls to get recipes for a certain search query from an API. On the other hand, in the view is where we get the search query string from the user interface, and also where we print the results of the search. And the controller, of course, is what brings these two together, so that model and view never actually have to communicate. And this will make the entire app, again, more modular and easier to maintain, as you will see when we start coding it. So as you see, the model is always concerned about the data and the app's logic, while the view gets and displays data from and to the user interface. Okay? So that is, in simple terms, how MVC is going to work in our app. And of course, the same logic applies then to the recipe, list, and likes part of the app. So there's always one model and one view, held together by the overall controller. Now we could also have multiple controllers here, but I find it easier to work with just one global controller, and you will see why a bit later. Alright, so let's now jump right to the next lecture, where we're going to start implementing this architecture with ES6 modules. Let's now talk in detail about how ES6 modules really work. And so in this video, you're going to learn how to import and export stuff from and to ES6 modules by using both default and named export and imports. So let's open up our index.js file. And we can actually close the package.json file. And also we can get rid of the test.js file. So this was just to test if Webpack was working all right. And we don't need that anymore. And we also don't need any of this stuff here anymore. So let's get rid of all of it so that I can now explain you how ES6 modules work. Okay, so let's create a new model here for the search functionality. So a new file, and I'm going to call this one search. And usually we always write JavaScript files all in lowercase, but in the case of models, it's like a convention to always use uppercase here for the model name. And so this one here is for search, and so I'm just using search with the upper S, okay? And just search. And now the same one for the view. And remember from the last lecture, this one is called search view. .js, of course. Okay, so we just created the search model and the search view file, and we also have our index.js file, which is going to be the controller, okay? Now we're not going to add the real code in here just yet. For now, I just want to show you again how named and default exports and imports work in ES6 modules. So we already talked a bit about this when we talked about the Webpack tests, so the test.js that I just deleted, but now let's really dive into it. So starting with default exports, that's the ones that we use when we only want to export one thing from a module. And that's actually pretty common, and that's why we have default exports. So with default exports, all we have to do is to say export default, and then the thing that we want to export. So let's say we simply want to export a string saying, I am an exported string. Okay, and so this is our default export. We don't specify any constant here or any variable at all. We simply put our expression, so this string here, right after the export and default statement. Okay, so this will now export it from this file. And if we want to now import it into the index.js file, we do it like this. So we say import, and then we have to give it a name. So let's call it string, for example, and then from, and then the path to this module. And in this case, it's in the models folder. And so we have to say first the current folder, remember, then slash models, and then slash search. And remember, I already told you before that when we import a module, we don't have to specify the .js. So just the name of the module, which is search, not search.js. Okay, and so like this, we have now this value stored in string. So in string, we right now will have I am an exported string. And in here, we really can give it any name that we want. We can also call it just str or x, or it doesn't really matter, okay? So let's just call it str. So default exports, they are really simple. They work just like that. Now, if we want to export multiple things from the same module, then we have to use something called named export. So let me show it to you in here in the search view file. Okay, because later we will actually export many functions from here. And so let me show you how we can do that. So it's actually pretty simple as well. Again, we use the export keyword, but now instead of default, we declare the constant or the variable that we want to export from here. So imagine we want to export a function. So let's say const, and for example, let's say we want to export a simple sum function or add. And we pass two numbers into it, and then we return a plus b. Okay, so just a very simple function which takes two arguments and then returns the sum of a plus b. So this is here again the arrow function syntax, and I'm sure you're already familiar with that by now. Let's say we now want a similar function to this one here, which multiplies two numbers. So multiply, and then again the same as before, which will a times b. Okay, so now we have two exports here. And let's say we want to export something else. For example, an ID set to the value of 23. So now we exported three things from this module. And if we want to now import it from here, it works in a slightly different way. So again, we have to say import, but then we have to specify what exactly we want to import from the module. So we use the curly braces, and then imagine we just want the add and the multiply. So we say add and multiply from, and then views, and then search view. And again, we omit the .js, right? And so with this, we only imported the add and the multiply, and we have to use the exact same names that we exported here in these named exports, okay? And that's why they're called names, because we give them a name, and then in order to import them, we have to use the exact same names if we want to use them, okay? Now let's also add the ID, and so we can now use these. Let's get rid of this line, and now let's log all of this to the console. So console.log, in a template string here, using imported functions. And so let's here add these functions actually, or use them. So let's say add, and then we can actually use ID, which is 23, and also pass 2. So now we pass in the ID and 2. So the two variables that are available to us right now. So add and ID. And let's use the other function here as well. So multiply. And now I can pass 3 and 5. And also, since we're at it, let's also include the str, so the string, so that we have everything in one nice console.log here. And I see we're missing here this curly brace here. And so now we should be good to go. Okay, so let's test it out. And actually it should already work, and it does. And that is because here in the terminal, this process is still running, as you can see. So our dev server is still bundling up all our JavaScript files as soon as we save the files. And so in here we have now using imported functions 25 and 15. And so these are the results of the functions, so the imported functions. So up there here in this pop-up it says 23, plus 2 is of course 25, and 3 times 5 is 15. Right? Then here I am an exported string. So all of this is working just fine. Now imagine that we want to use different names here. We can actually do that as well. All we have to do is to say add as a, for example, and multiply as m, okay, and then just ID. And so now we can use a and m in here. Okay, so let's give it a save, go back, and it still works, right? So we basically changed the names of the imported variables, so the imported functions here in this case, but they are still variables, so it's the same. Okay, so we can export them using one name and then import them and assign them another name by simply using this as syntax here. So this is the second way of doing named imports coming from named exports. Now the third way is a bit different, but there is actually still a third way. And so let me actually comment this one here out and start it again. So I can say import everything from this here. So let's copy this part. And so I can do it like this. And then I also have to give it a name here. So import everything as, and let's just say search view. Okay. And so everything is now called search view from views/search view. All right. And if we now want to go ahead and use the stuff that we exported here, we have to do it like this. So we have to use search view dot add. And here we have to use search view dot multiply. And here, of course, we also have to use search view dot id. Okay, let's check it out again. And here it is. So still working just the exact same way. So that is the third way of doing named imports. So again, here we import basically everything and put it into this variable here, or this object. And then on this object is where all of the variables then live. And so we can then use them. So here, search view dot add, dot multiply, and dot id. Okay, and there are different use cases where we can use these different methods. And I'm going to use all of them throughout this project. But I just wanted to make this separate video in order for you to really learn how modules work all in one video. Okay, so we can get rid of all of this here now after learning this. Okay, so this was again just to test it. And so now we're good to go and really ready to start with the project right in the next video. Okay, so I hope to see you there very soon. So we're now ready to start working on the Forkify project. And the first step will be to start using the underlying recipe API. And so we will use a real world API here, probably used by thousands of services out there, based on what we learned in the last section, of course. Also, you'll learn about the concept of API keys and why we need them. So the API that we're going to be using is called food2fork.com. So head over to this website here, and then from here, we can use this recipe API. Okay, and that brings us to the documentation page of this API. So this API allows us to do two types of requests. First off, we can search for recipes, and second, we can then get data about one specific recipe. So in this first, the search request, it's going to return a list of 30 recipes. And from there, we can then select one of the IDs and then make a request for that specific recipe during the second endpoint. So we have the search and the get endpoints of this API. Okay. Then down here, we see the parameters that we have to include in the API request, but more on that a bit later. What I also wanted to show you is that we have different plans here. So the first one is the free plan, and that's the one that we're going to be using. So we can do 500 API calls per day, and then you can also pay if you want. And we always have to have an attribution whenever using the free plan, saying powered by Food2Fork. And that's why we have it down here actually in our app. Okay. So now please go ahead and create your own account here, because that's how you're going to get the API key that you need in order to make this API work. So I already created this account, and so I just need to log in here. And then I can see my API key right here. So please go ahead and create your own account, because you should use your own API key instead of using mine. Now you might be wondering what an API key actually is, and so let me explain it to you. So an API key is like a password that's given to each user. It's like a unique ID that each user can use in order to make requests, and so that the API can track how many requests you make per day. So remember that here in the free plan, we can only do 500 requests per day. And so they use this API key here in order to track that. Okay, so I'm going to copy it and then paste it here actually in this file here, just so we have it here in the index.js file where we're going to make our requests in a second. Okay, now let's go back here to the API itself, the documentation, in order to learn how we can actually do the search request. So this is the URL that we have to use to make the request to. And then down here, we have to pass in the key, so the API key that we just got, and then also the search query. Then we can also pass in the sort parameter and the page parameter. And we're going to talk about these later, but for now, we just need the key, and then of course also a search query. Okay, so the URL is this one. So let me also copy it over here to our code editor. Okay, and now that we have all of this, let's actually try to experiment with this API. So not really building the app just yet, but just writing a simple function here to experiment and try out the API. Okay, so let me write an async function. So get results for get search results, and the parameter is let's pass in a query. Okay, so here we have the space, and then down here we can then call this async function. Okay, now about the HTTP request that we're going to make for the AJAX call. In the last section we used the fetch function like this, right? Now there are some problems with the fetch function that I actually mentioned before, which is that it doesn't really work in all browsers just yet. So in the modern browsers, of course, it's going to work just fine, but if you get on a very old browser, then it might not recognize fetch, and that's actually a problem. And so instead, what we're going to do is to use a very popular HTTP request library called Axios. Okay, so in order to use Axios, we need to install it and get it from npm. Okay, so let's use our terminal again here. Let's clear this here and do npm install Axios. Okay, and then save. And again, it's not safe dev because this is not a development tool. It is really code that we want to use in our app. Okay, so let's wait for it. And there you go. Let's just confirm it in our package.json file. And indeed, here we go. So we installed the package, and now let's import it. And importing packages actually works almost the exact same way as importing our own modules. And so again, we use the import keyword. So import Axios from, and now comes the name of our package. So in the last lecture, I showed you that we have to specify the path to the module that we want to include, right? Now with this npm modules that we install from an external source, we don't have to do that. All we have to do is to specify the name of the package. So all we have to do is to say Axios, as it appears here in the dependencies. So it's Axios here, and so we call it Axios here in this import, okay? And then as I hover over it, you actually see the entire path, which the code editor actually figures out on its own, okay? And so that's where the package lives. And Webpack, when bundling or modules together, will then automatically also figure out where it is. Then here we could give it actually any name that we wanted. We could do just A, okay, but it's like a convention, like a standard, to give it here the same name as the package name, okay? So let's now use Axios to do our AJAX call. And it actually works the exact same way as fetch, okay? So the package just gives us access to this Axios function, which will then do our HTTP request. Okay, and this one here actually works on all browsers, unlike the fetch API that I showed you before. And there are also other things that this one here does better than fetch. For example, it automatically returns JSON. And with fetch, remember we had to do it like in 2 steps. First, we had to wait for the data to come back, and then we had to wait for it to convert to JSON. So we had this 2-step process. And with Axios, it happens all in 1 step, and that's much better. And also, Axios is a bit better at error handling than fetch, and I'm going to show you that in a second as well. So Axios, and then in here we have to pass the API URL. Okay, so let's copy this one, do a template string here, so that we can now include the query. Okay, so let's see how that works here in the documentation. So for the key, we have the key parameter, as you see here, and for the query, we have the queue parameter. Okay, and so how it works is like this. So we have search, and then in order to add these parameters to the URL, we have the question sign and then the name of the parameters. So key is our key, and let's actually save the key here to a constant. So const key, and I'm going to cut it from here and paste it up here. And of course it needs to be a string. So putting the key here, and then the next one is Q. Remember, so for the query, we use Q. Right? So again, this Q here is coming from the API documentation. So this Q here, right? Okay, so this here will do the AJAX call, and just like fetch, it's going to return a promise. And since we're using async await here, let's then await this result and save it to a constant. So constant result, and then await the result of this promise. Okay, so remember, that's how we handle promises with async await, right? So the resolved value of the promise that we start here will then be saved into this res variable. Okay, and now just to take a look at what we get back from this AJAX call, let's simply log it to the console. And that's it for now. So let's actually try it out. And if you take a look at the terminal, you will see that it has probably already built our bundle. And yeah, it did. So this is actually the time of recording this video here. And so right now it just bundled this module here together. Okay, so let's take a look at our console. And here we have this error again that we had before. So this is again the error where some domains don't allow requests coming from other domains, okay? So that means that the authors of this API, they have not really implemented the CORS into their API. And so we need to get around that again using the cross-origin me proxy. Okay, so yeah, it's this one here. Let me show it to you again. So all we have to do is to really prefix our URL with this URL here, okay? So the cross-origin.me. So let's do that here. And again, I'm going to create a constant for that. So this proxy URL, and now I'm just going to plug it in here. So proxy, and so let's see what happens now. And we're still getting an error here. You see it's a 403 error, which means that we're not allowed to access the resource. And so maybe we need to try another proxy here. So let's just search for CORS proxy here. And the one that I'm going to use, which I've used before also, is this CORS anywhere. Okay, so let's just copy this one, and it works just in the exact same way. We just need to replace this proxy name that we had and put this one. Okay, and so now our request is going through this server here. So let's try that out again. And we also forgot to add our search query. So let's add pizza here again and try it out again. And all right, so we now finally got our response. So let's try to open up this object, take a look at it. And you see there's a lot of stuff here. These are the headers of the HTTP request. Then here we have the request itself. But what really matters is the data really here. So we have the data here, then we have the count property, and then the recipes array. And this is what we're really looking for, right? So you see that we already got our 30 recipes here, all in this recipes array. Okay, so let's actually go back and say that we only want to display these recipes. So let's create a variable here. Const recipes is result.data.recipes. And so let's log just the recipes. Okay. And so let's wait for it. So this time that we're waiting here is the time that it takes for the AJAX call to come back with the result. So here we have all of our recipes. So you see that we have a publisher. Let's open it up here. So we have the URL on food to fork. We have an image, we have a publisher, and this is the ID that we're going to need to use the second endpoint of the API, which will be to search for recipe. And then we can get even more details about the recipe, like ingredients and all that good stuff that we need to display our recipes then here in the middle of the app, right? So this already works. Let's now talk a bit about the error handling. So let's say we put an invalid key here. So let's just add something weird here to the beginning of the key. Let's try it again, and we will then probably get back with an error. So again, we see the forbidden status code here, right? And so let's now handle these errors. And remember, we have to do it using the try catch statement. So we want the code to try if this piece here works. So try. And this one here actually as well. And then catch any error that may occur, and let's alert it in this example. Okay, so here we need to call it error, for example, and then log it to the console, or actually alert it into its own window. So let's try that out now and see what happens. And here we go. So the request failed with a status code of 403. And if we had done the same AJAX request with fetch instead of Axios, it would probably not have catched the error, because again, error handling works a bit different in fetch than it does in Axios. And in Axios, it's way more intuitive and better, in my opinion, okay? And so that's why I'm always using Axios instead of the native fetch method, okay? But anyway, of course, we want to go back to what we had before. Let's get rid of this. We can also get rid of this piece of code. It's not really necessary. And so one last time, let's try it out if it works. And indeed, we get back all recipes. And you also see that they're all about pizza here, right? So it always says pizza. Let's try something like tomato pasta. Come back here. Now it takes some time to get the data from the server. And now they will be all about pasta. So pasta and tomato. So you see that both are now here in the title. So pasta salad with tomatoes. And so, yeah, this API is actually working now. And so right now we are ready to start building this beautiful app here using this underlying food to fork API that we just explored. Let's now start to implement the MVC architecture by building the model for our search functionality. And so in this lecture, you're going to learn how to build a simple data model using ES6 classes that we talked about before. So we actually already have our model file for the search. So let's open it up, and so that we can build our model in here. So we're going to use ES6 classes in order to describe the data model for the search. And the data for the search is really just the query and then the search results. And so the only thing that we're going to export from this module here will be this class. So let's say export default and then class called search, of course. And remember how we define a class? Well, the first thing that we need to do is to always add the constructor method, which is the method that's always called as soon as we create a new object based on the class. Okay, so we need a constructor, and in there we pass the properties that we want the new object to have. Okay, for example, in this case, we want to have a query, and we then say this.query equals the query that we passed in, right? So remember this pattern, how we define a class? If not, then don't worry, it's going to become a lot more clear once we start using this class here in a second. Okay, now the second thing that's important about the search here is the search results, of course. So we're going to have a method here that we can use to get the results for the search query. Okay, and we actually already wrote that, kind of. Okay, so let's get this code from here that we wrote in the last lecture and put it here into search. And so this function that we have here is kind of the method that we're looking for. Okay, so let's copy it or cut it, paste it here, and then all we need to do is to get rid of this function keyword, right? Because this is how you define methods. So usually you define them like this, so just the method name and the parameters, but in case that it's an async function, then it works just the same as it works with regular functions. So we just use the async keyword, and so we say that this is an asynchronous method of this class. Okay, of course we don't need this here. These definitions, they should always be at the beginning. So these kinds of imports, we usually always include them right at the beginning of each of the modules, okay? Now, a couple of things that we need to change here. First off, this method here does not have any parameter because we will always read the query right from the object itself, right? So in here, instead of query, we use this.query because the query will already be in the object once we call the getResults method, right? Then next up, we also need to change this line here because we actually want these recipes here to be saved in the object as well. So let's say that we want this dot result to be the recipes that we got from the Ajax call. Okay, and again, this will become more clear in a second once we start using this method and this class. Okay, and then we can also log them to the console just to see if everything's working, and that's actually it. Okay, so very simple. This is all we need for our search data model. And so let's now go ahead and import it here into the index. So import search from search. Okay, and now let's create a new variable called search also, but this one with a lowercase, and so it is a different variable. And now we use the new keyword as always and pass pizza into it, which remember is the query, right? So this query parameter is the one that we need to specify whenever we create a new object based on this search class. Okay, and then this query will be attached to the object as being this.query equals the query that we inputted. Okay, so let's get a look at that actually. Okay, in the console, so that we can kind of review how everything works here with the classes. Okay, so let's wait for it. And yeah, of course there is this error because I put the wrong path here, so I forgot to add the models here. But now it should be okay. And here you go. So this is now the search object that we created. And you see that it has the query property set to pizza, and then in its prototype it will have the get results, right? So this is the kind of prototypal inheritance that we talked about all the time throughout this course here, and so I'm not going to go into that again, because at this point I'm sure that you're really familiar with how it works, okay? And now as a final test, let's actually go ahead and use the get results method, okay? So search dot get result. And that's actually it. So let's try it again and let's wait for the result. And for some reason it says recipes is not defined. So let's take a look at what's happening here. And well, let's just console.log it here. Just to see if, well, if something's not working right. Okay, so actually we have data here, so I'm not really sure why it's not working. So let's try it again here. Just waiting a second here. So recipes is not defined again. So let's go back. And yeah, so the problem is actually here. So here we should have this dot result. Okay, and so now of course it's going to work just fine. Wait for it, and here we go. So here's the data that we were looking for, and so our data model works just fine. Okay, so let's get rid of this console.log, and actually of this one here as well. Well, let's just comment it out. Maybe we're gonna need it later. And this is how our data model works. So you see that instead of returning the result right away, it simply stores it here in this dot result, so that all the data about the search are encapsulated inside of the object. So we have both the search and then the corresponding result, both stored inside of the search object. And this has some advantages that we're going to talk about right in the next lecture. Welcome back. In this lecture, we are going to build the search controller. And in order to do that, you will learn about the concept of application state, and then you will learn a simple way of implementing state in our app. So let's open up index.js, which is where we're going to put our controller. So again, each model and each view will get its own file for each of the functionality. But for controllers, I'm going to put all of them into the same file because that makes it a lot easier. As you will see when the file gets bigger and bigger as we're adding more controllers. And it will be easier to have them all in one file, okay? So let's now talk a little bit about something called state. So imagine our final app running with all the search queries, the recipes, the likes, the shopping list. So what is the state of our app in any given moment? So think about what is like the current search query, or what's the current recipe, or how many servings are currently being calculated, and what's currently in the shopping list. So all of these things in one given moment are the state. So all this data in the current state, in the current moment of our app, all of this data is the state, and we want that to be in one central place, like one central variable, like an object in which we have then basically all the data that defines our app in a given moment in one place, in one object. Okay, so that's what we're going to implement now, and it's actually very easy, at least in our very simple app like this. Okay, now there are entire libraries for state. Maybe you've heard of Redux, which is used together with React. So that's a very popular state management library. But in this case, we will just do something very simple, just one object, which is the state of our app. In Redux, this is like the store, it's called the store, but let's just call it state here, okay? So const state, and for now it's empty. And let's actually add a comment here. So saying the global state of the app. And in here we will have the search object. So all the data about the search, which we actually already coded up in the last lecture. So remember, in the search object is where we have the search query and the search results. And so that will be part of our state. Then we want the current recipe object. So that will be later when we're talking about the recipes. Then we also want the shopping list object. And we want the liked recipes. Okay, and so again, all of this data will be stored at all time in one central variable, which we can then access throughout our controller. Okay, so instead of having many variables, like having the object stored in some place in some variable, or having the recipes like hidden from other functions, from other scopes, we have everything in one place, accessible to everything inside of this module. Okay, so that's a pattern that I really like to use, and it's really helpful in this case. So again, we start with an empty object here. So each time that we reload the app, the state will be empty. And we will actually make some of the state persistent a bit later, which means that when we reload the page, then the state or some part of the state can actually persist. So it can be saved. But let's leave that for later. For now, let's start implementing here part of the controller for the search. And the first thing that we're going to do is to actually add an event listener for the search form. Okay, so basically for this button and for this entire form. So let's take a look at our HTML. And it is up here. So the form that we're looking for is this one here called search. So let's now add an event listener for whenever we submit this form, okay? And event listeners are something that go into the controller, because that's where we're then gonna delegate what we want to happen when the user submits the form, right? So document.querySelector add event listener, and the event we're looking for is the submit event. And then, of course, our callback function, in which we pass the event object into. Okay, and let's see what actually happens right now. So when we click this here, you see that the page reloads, right? So let's take a look again. And we don't want that to happen. And so we say e.prevent default, right? So we did that before, of course. And then we can now also create a new function that we want to be called whenever the form is submitted. Okay, so instead of putting all the logic here inside of this callback function, let's make a clean new separate function from this. Okay, so control search. Okay, so no arguments here. All we want to do is to put this code basically outside of this callback function here, make a nice separate function just for this. Okay, so whenever we submit a form, we prevent the default from happening, and then the control search function is called. And now let's think what we want to happen. Okay, so I will actually make now a bunch of comments listing each of the steps that must happen here in this search controller. Okay, so the first one is that we should get the query from the view. So let's call this simply query. And I will simply add a placeholder here now and say that we should then do this later, okay? Because in our view module, we will have a function that will get the search query from the user interface, okay? Of course, we could put this right here. We could now do a document query selector and then read that data right from the user interface, but that's something that has to do more with the view. And so we're going to put a method for that, or a function, into the search view module, okay? But we're going to do that in the next lecture, so that we have one lecture for each of these different parts of the architecture, okay? So right now we're talking about a controller, so let's leave it like this for now and then come back in the next lecture and code all of these functions for the view, okay? Now if there is a query, we then want to create a new search object, right? So let's say if query, so if there is a query, then what we want to do next is new search object and add it to state. So let's do that. So state.search will be a new search object with the query, right? So similar to what we did here, but now this time around, we are actually going to store it here into our global state object. So this one that we just talked about in the beginning of the video, right? So let's get rid of this here. And next, what should we do next? Well, we can now prepare the user interface for what's going to happen. Okay, so like clearing previous results or show a loading spinner. And so that's what we're going to do here as a next step. And again, I'm leaving that for the next lecture, but that's one of the steps. So I'm putting it here right now. Next up, let's actually do the search. So search for recipes. And so that's where this method here comes in. So on our state.search object, we now can perform the getResults method, right? So again, state.search is where this object now lives. So this new instance based on the search class. And on that, we of course have the getResults method available so that we can then later display these results in the user interface. And actually that's exactly the next step. So render results on UI. Okay, now of course we only want this here to happen. So we want the rendering of the results only to happen after we actually receive the results from the API, right? And so what we do have to do here is to actually await this promise, right? So since we use await here, now we need to say that it is an async function. And we do that right here, right? Because this here is where we define the function. And so we say async function so that we can then use await in here. Okay, makes sense? So again, this here returns a promise, right? And why is that? Well, let's open up the method here. So this is an async method. And remember that every asynchronous function, it automatically returns a promise. Okay, and so here we then have to await. So until the promise resolves and comes back with our data. Okay, now we're not really going to render the results on the UI, but what we can do here is then to log these results to the console. So console.log, and where are these results actually stored? So they are in state.search.recipes, right? Or is it result? I'm not really sure. Ah, yeah, it is result. You see, so it stores it into this.result. And so here it's then state.search.result. And let's actually get rid of the console log. Ah, we already did that. So the only console log that we have is going to be this one here. Okay, and so what this means is that the getResults method runs and we wait for it to finish basically. And only after that is done, we can then log to the console the result here. Okay, and so with this, we can test if this async await here is actually working as intended. So let's test it out. And we don't actually have to input anything here because again, it's not really being read right now. Right now, we're just using the input pizza here as a temporary query, right? So let's just hit search here and let's wait for it. And indeed, it did came back with our data here. and it's all on pizza, right? And you can see that this console.log came from index.js line 27, which is exactly, well, it's not exactly this one here, but I guess the line number is not correct because of all the Webpack bundling that's done behind the scenes, but it's pretty much the same, 25, okay? So that's really all there is to control right now. So all we have to do now is to actually implement our view so that we can get first the query from the view, that we can then prepare the user interface for the results, like having that spinner, clearing the input maybe, and then finally we want to also render these results on the user interface, of course, instead of just logging it to the console, right? So if you're ready to do that, then just come with me right to the next video. This will be a longer video where we're going to write a couple of functions for the search view. And so in this video, you're going to learn a couple of advanced DOM manipulation techniques. We're going to use ES6 template strings to render entire HTML components. You will learn how to create a loading spinner, which is really cool, I think, and a lot of other smaller things and techniques. So let's get straight to it. So we already have the file here, searchview.js. Let's close up this one here as well. And so yeah, so this module will have a bunch of functions regarding the search view. And so we will export all of them using named exports. Okay, and so let's start by the one to read the input from our input form. Okay, so remember the syntax, we write export, and then when we're using named exports, we just write the name of the variable, the function in this case, that we want to export. So get input in this case. So what do we want to do in this function? Well, all we want to do is really to return the input value of the field. So we will select the DOM element, get the value, and then simply return it. Now we could do document.querySelector and all that stuff here again, but I think it's better to have one central variable where we have all of these DOM elements that we need in our app. And that's a bit similar again to the Budgety app, where we also did something similar, because it's a lot easier to have everything in one central place instead of having these document query selectors all over the place, which can turn into a maintenance nightmare if we ever were to change like this entire underlying markup here. And with this, our views will get a little bit more decoupled from our markup. Okay, so let's now create a new module for that, right here in the views folder as well. And I'm going to call this one base.js. Okay, and we can then also go ahead, before we forget, we can go ahead and import it here, or maybe not yet. Okay, let's first export some stuff here. So what we want to do here is to create an object which will contain all of the elements that we select from our DOM, so all the elements that we need from our app. And we will then export that. So export a variable called element. And so this will be an object again. And I'm doing it as a named export because later on we will have some more stuff here in this module. And so let's go with the named exports here. Okay, so let's call this one search input. And so what we want to do here is document.querySelector, and let's take a look in the markup again. And so the input field that we're looking for is called search field. So let's copy it. And here we go. So now we have an element with a property called search input, which contains this DOM element here, right? Now we also did some document.querySelector in here. And so let's actually get rid of that here as well. Let me copy it and insert it here. And of course, we're needing the name here. So search form for this one. And now let's give it a save. So you see that there's an error here. And so VS Code, this editor here, marks then this file here as red in the entire file tree. Okay. Now we need to, of course, import this element. And so we use the curly braces, remember, elements from, and this one is in views, and it's called base. Okay, and actually we can also already start by importing this search view file. Okay, so let's do, and in this case we are simply going to import all of the functions because we already know that we're going to need all of the functions that are in the view in the controller. Okay, so we want everything as search view. Okay, and remember that this will then be an object in which all of the exported variables from the search view module will be stored. Right, so I explained you that in one of the previous lectures. I hope you remember that. So views and search view. All right, and so now we can say elements, and let's take a look at what we called it. So we called it search form. Let's get that. And so now we should be good to go. And from now on, we're simply going to put all of our DOM elements right here into this object. Okay, so let's do the same here again, actually. So let's get this one and import it here also into the search view. So element dot search input, right? Let's double check. And yeah, so it's called search input. That is our search field. And all we need to do now really is to say that we want the value. So remember that this is an arrow function here, of course. And if you only have one line, then this is an implicit return. So we don't even need to write like return. So this will automatically return this value that we specified here. So elements.searchInput.value, which will be whatever we input into the search field. Okay, now let's give it a try here and replace this pizza that we had here with what we really want. So how do we specify this function? Well, we simply use search view, which is, remember, what we imported from the search view module, and then .get input. And my text editor, VS Code, actually already knows that get input is one of the functions in there. So it's very smart, it's very handy. And so again, it's really a great text editor. Okay, just to make sure that everything works here, let's log it to the console. It should reload now. And we have an error here. So let's go back to searchview.js. And yeah, of course. So I tried to import the base element from the views, but we are already inside of the views folder. And so I don't need any of this. So we're in the current folder and then just base. Okay, and so that should work now. And yeah, it did. So instead of writing pizza now, let's write pasta. And indeed, it writes pasta to the console, gives me the recipes, which are now hopefully about pasta. Yeah, so pasta with pesto, then the best lasagna. And you see that they're all about pasta now. So great, that part is already working. And so let's now do the most exciting part actually, which is printing these results here to the user interface here into this left column of the app, right? So let's think about how we are going to do that. Well, here in the state.search.result, so this one here, this is our array with our 30 results, right? So let's now write a function in the view which can receive all of this result and then print each of the elements, so each of the recipes in that array to the user interface. So let's come back to our search views here and write another function. And I'm going to call this one render results. And what it's going to receive is, of course, all of the recipes. Okay, so we receive an array of 30 recipes here, remember. And so now we need to loop through these in order to then print each of these to the user interface. So let's say recipes.forEach, because remember, that is the best way to loop through an array. So instead of having all the logic of printing here in this function, let's do a separate function that has only one purpose, which is to print one single recipe. Okay, and I'm doing that because later we will add some more stuff here when we implement the pagination. And so it's better to have one function for each separate task. Okay, so nicely separating different functionalities into different functions. So I'm going to have another function here, which is going to be called render recipe. And this one will receive just one recipe. Okay, And note that I didn't prefix it with the export command because we don't need to export this function to the outside. We just don't need it outside of this module here. And so it's just like a private function here. Okay, and so we can now call this function here. And we could do it in a more complicated way, like something like this. So with a callback function where we specify the input, and then we say render recipe with the current recipe, but that's actually not necessary because all we need to do is really to write render recipe like this, and it will then automatically pass the current element into this function, into this render recipe. And so for now, all that the render results function is going to do is to loop through all of the 30 results and then call the render recipe function for each of them. And so this is where the rendering will actually happen in this function here. So let's now get the HTML for each of the results, which is stored right here. So I have it here in comments into my HTML file. So what I have here is, let's do a quick overview of the HTML. So we have the header in the top. So you see the header, which is this entire element here. So all of this here is the header. Then on the left side here, we have the results element. And then in there, we already have the unordered list, which is called results list. Okay, so I decided to already put it in the HTML and not have it dynamically generated by JavaScript. So it's easier to already have this and then just fill it up with each of these li elements in JavaScript, which is exactly what we're going to do next. So we have all of these results here. Then down here, well, we have the buttons for the pagination, but we're going to take care of that later. Then in the middle, we have the recipe element. So this big part here. Then we have the shopping list on the right side, as you see. And then I guess, no, that's more in the top. So here we have then this likes panel here. So this here. We're going to hide that here later when there's no like pages. But for now, again, let's leave it as it is. Okay, anyway, what we really want to grab now is this code for one li element. Okay, so let's create a variable called markup. And now remember back in the budgety project, which we still did with ES5, and when we wanted to insert some HTML, we really had to put it all in one line, and it was this really bad looking and confusing syntax. But right now in ES6 with template strings, we can do it in a very easy way. So just make a new template string and then give it some space here. And now we can simply write it like this, as if we would be writing real HTML. So this is really cool, I think, and looks much better. So this looks really like as if we're writing in an HTML file. It actually looks a bit like React here also. Okay, and let's now look at the data and actually also at the final result in order to see how this is supposed to look once it's done. So I have this here also open in another port. So this here is the final working project, okay? So let's write pizza. It has this nice spinner that we're going to implement next. And then we have all the results. So what we have here is this image, then this title, and then down here, the publisher. Okay, so let's see if we can find that data in our results. So let's put pizza here as well. And it should now log it to the console at some point. And indeed, here we go. So let's take a look at the data for each of the recipes. And so we have an image URL, we have the publisher, and we have the title, and also the ID. And so this is all that we need in order to print the results to the user interface. Okay, so let's go through the markup one by one and replace the static data here with our dynamic data coming from the API. So we start here with this part here, and this is actually the ID of the recipe. And you're going to find out a bit later why this is important when we start loading recipes. But for now, let's simply insert the ID in here. So since we're into a template string, we can now use this template string syntax. So what we want here is, let's go back to grab the name of the property, and it is called recipe ID. Let's actually copy it. And so it's recipe.recipe ID, right? So recipe is the variable that we put into the function, coming of course from this function call down here. And so then from the recipe, we read the recipe ID. Okay, so going back here, and now we changed it. And so, yeah, let's get it back here and wait for it, and here we go. So this object here is now our recipe, and then we need to read recipe ID, image URL, publisher, and title. Okay, so next one is the image URL, I guess. And so yeah, it is here. So let's replace this as well. Okay, now here we have the title. And finally, the publisher. Let's just copy this part. And here it's not, it's title. Okay, and let's actually put it here in the alternative text for the image. Let's put the title here as well. Okay, and I think that's it. We just have to remove this class from here, which is for the active class. So that one doesn't really matter. We just need the results link class. Okay, and so this here generates a variable containing the markup that we want to print. But now we need to actually, of course, render it to the DOM. Okay, so where do we want to render it? Well, we want to put it here into the results list. So let's add it here to this elements object. So search result list, let's call it like that, document dot query selector, and let's copy this one here now. And so elements dot search res list. Now remember the insert adjacent HTML method that we used before. Remember that one? Let's take a look at it just to remember how it works. Maybe it's been a long time since you've taken the rest of the course. So I always like to use the MDN library in order to get help about the different methods. So let's take a look at how it works. And so basically we have to specify the position and then the text, so the markup that we just defined. And in here we can do different keywords. So we can put before begin, before end, or after end. And here is basically the position of each of these 4 keywords. So imagine that this here is our list element that we just selected. And so we want our elements to be put before end. So here, okay? So we always want a new element to be put on the end of the list. So first the first one, then the second, then the third, all the way until 30. If we did after begin, then we would put the second one before the first, then the third before the second, and we would end up with the inverse order. Okay? And so we're going to use before end and then the markup. Okay? I hope that made sense. So before end, and then of course the markup. And that's it. So all of this will be executed 30 times, each time for each of the recipes. So let's hope that this actually works. And in order to see it, of course, we need to import it here. So search view dot render results, and we need to pass in the recipes. So that is state dot search dot results. I guess. Let's take a look again at the model just to make sure. And it is called, okay, it's just called result. Okay, does it make sense? Just to make sure that it actually does make sense, we have this result stored inside of our state element, right? We also have our imported functions from the search view, which we did up here. And so now we're bringing everything together here inside of this function. So we read the input from the input field. This one we don't need anymore. Then we create a new search object which contains that query. Then we actually get our results from our API call, wait until that is done, and finally we render it to the user interface, so to the DOM, by using this method that we did in the search view just before. So let's now hope that this actually works. Writing pizza, and we don't have the spinner here yet, of course, but let's wait if it actually happens. And now we have an error here, but that's not a problem at all. So let's try to debug it. So what it says is that recipes.forEach is not a function. So let's find out why by logging to the console what recipes actually is. So console.log recipes. Okay, because it's an array, and so it actually should have the for each method attached to it. Let's wait for it. Pizza. And we still get the same error. And oh cool, yeah. This is of course just a stupid mistake. Okay, I'm sorry for that. So this is a capital E for each. This is how it works. Okay, so let's reload it. Write pizza again. And let's wait for the result here. And whoa, here we go. So it actually printed our results here to the user interface, just like we wanted it to work. So that is actually perfect. Okay, it's not quite perfect actually, but there are some things that we have to change here, but at least it's now really putting our results here to this page. So that's already a huge step forward. So that's really cool. Next up, there's just some small corrections that we need to do, like clearing this text here from the field. So let's take care of that now. And write a function export clear input. And we're missing the const here, of course. And so this is actually pretty similar to the one before. Elements.search input.value and set it to nothing. Okay, and now we're actually not returning anything here, so it's cleaner to wrap this here into these curly braces, because otherwise there's an implicit return of the result of doing this, and we don't want that. Okay, we're also missing the semicolons down here. It's not a big deal, but let's keep our code clean here. Okay, so clear input is the name of this function, and let's now use it here. So we're going to put it here in prepare UI for results. So search view.clear input, and that's it. Now another thing that we want is, well, let me actually show it to you why we need to do this. So let's again search for pizza here and wait for our results. So we have our result here, of course, and you see that actually it cleared our input, and let's now search for pasta. And what you will see happening now is that it will add these new results here on the end of these. Okay, and so what we need to do is to actually clear the results before we can display them. And so that's another thing that we can put here in prepare UI for results. So we can clear the input and then also clear the results from the previous search. So let's quickly do that as well. Clear results. And we already have this list selected, so it's just search res list here. And how do we remove the entire HTML inside of this element? Well, it's actually very easy. We can simply set the inner HTML of the element to nothing. And so the HTML inside it will be empty, which means that it will simply delete all of the HTML, so all of these li elements that are currently in it, right? So let's test that one out as well. So again, our first search is for pizza, which should display in a second here. Here we go. So again, our 30 results. And now pasta. And before showing the new results, it will actually immediately delete these results, right? Well, not really. And so probably our method is not really working. So yeah, it did add these here to the end. And of course it did, because we didn't even call this method here in the controller. So clear results here. And now it has to work. There's just no way around it. So this time pasta first. Here we go with all our 30 recipes, and now pizza. And you see now it cleared the search list and displayed the new recipes. Now the next thing that we're going to do is to shorten these titles. So we want all of these titles to be just in one line. And if they are too long, well, we just want the first words and then 3 dots here, indicating that the text can continue. So we have some of these here longer than just one line, and so we're going to fix that in the next video, because this one I think is already getting long enough. Let's continue coding up our search view. And so as I mentioned in the last video, the goal for this video is to now reduce this title size here whenever it occupies more than one line. Okay, so basically what we want is for these main titles always to occupy just one line. Now we also don't want to cut words in half. So in this case here, imagine we don't want the CRU, for example, to be up here and then having the rest of the word cut out. So we only want entire words here and then followed by like 3 dots. Okay, so that's kind of a tricky small algorithm that we have to write here. And so let's see if we can pull it off. Okay, so I'm going to add a new function in here. And once more, it will be like a private function. So it's a function that we don't need in the outside world. So const limit recipe title. And what we receive here is a recipe. And we can also receive a limit. So limit of characters that is acceptable as the maximum length of the title. Okay. And let's now actually use something that we talked about in the ES 2015 or ES6 section, which is default parameters. So let's set this one here to 17. And I found out through experimentation that 17 is really the sweet spot here. So it's the best limit for this kind of layout here. But of course we could pass other limits into here. But if we don't pass any limit into the function, then 17 is the one that will be used. Okay. Now the first thing that we're going to do is to test if the length of the title is actually longer than the limit, because only then we need to do something, right? And here it should actually be title and not recipe. So we're only going to pass the title into this one. So if the title dot length is greater than the limit, then we have to do something. And else we will simply return the title again. And I'm not going to write the else statement here actually. So I'm not going to do this one here and then put return title in here, because we're going to have a return statement in here as well. And then it's a good practice to just leave it like this, okay? So we're either going to return something from here and then the function finishes anyway. And if this test here turns out to be false, then we move on to this one here and return the title as it was before. Okay, so this of course only applies if the title is longer than the limit that we defined. So how are we going to pull this off? Well, the best strategy that I came up with is to split the title into its words and then use the reduce method on the resulting array, which then allows us to have an accumulator. And that accumulator is just like a variable that we can add to in each iteration of the loop. And what we're then going to do in each iteration of the loop is to test if the current title length plus the next word is still under the maximum length. Okay, so that sounds probably a bit complicated, so let me write it out in code here, and then it will make total sense. Okay, so we take the title and then split it. So split is a method that is available on all strings, and we split it by the space. Okay, so let's simply write an example string here as a comment. So pasta with tomato and spinach, for example. Okay, and so by splitting it by the space, this will turn into an array with 5 elements: pasta with tomato and spinach. Okay, and so since we now have an array, we can use the reduce method on it. So reduce, and then we pass a callback function which has the accumulator and the current value as the input. So X stands for accumulator and then the current. Okay. Well, let's just write current like this. All right. So this callback function is the first parameter to the reduce method, and then the second one is the initial value of the accumulator, which should be 0. So we start with an accumulator of 0, and then throughout these loops, we will add to it. Okay, and I will explain you how and why here in the next steps. So let's actually experiment with this example string here and go through each of these iterations here just to show you how this actually works. All right. So in the first iteration, the accumulator is of course 0, right? As we defined down here. Now we are going to test now in each iteration if the accumulator plus the current dot length, so that's the length of the current word, if it's still under or equal the limit. Okay, and if it is so, then we will push this word into a new array. So let's actually create that array like up here. So a constant new title and just a new array. Okay, and this is a constant which we cannot really mutate, right? So why are we starting it as a new array and then keep adding stuff to it? Well, that's possible because adding stuff to an array is not really mutating the underlying variable itself. And so the title can perfectly be a constant and we can still keep adding stuff into the array. And the same goes, of course, for objects. Okay, so new title dot push the current word. So let's see why this makes sense. So again, the accumulator in the first one is 0. Then the accumulator plus the current length will be 0 plus 5, right? And 5, which is the result of this here, is still under the limit of 17. And so we can push this word into the new title array. So let's write it out here, that the new title now has the word pasta in it. Okay, and finally we have to update the accumulator. And this works in the reduce function by returning a value. So the value that we return in each iteration of this loop in the callback function of the reduce method will be the new accumulator. So we return accumulator plus the current length. So that's exactly what we did up there in the test. Okay, and so now in the next iteration, the accumulator will be 5, right? And let's actually copy this part here so that we don't have to do it over and over again. And so again, this is here just to simulate what happens in each iteration as we go through this. Okay, so in the second iteration, we're now looking at the word with, right? And so 5 plus 4 is 9, okay? And so 9 is still less than the limit of 17, and so we can add the word with to the array. So let's do that. And then next we return the accumulator plus current length, which will be 9. So in the next iteration, we will have 9 as the accumulator. The next word is tomato, so 6 plus 9 is 15. And 15 is still less than 17. So we can add the word tomato. Right? Then next iteration, now the accumulator is 15. And the next word is and, which is 3. So the current length is now 18, which is of course more than the limit. And so this word is not pushed into the array for the new title. Okay? Up here I'm actually missing the word tomato here. It's not a problem really, it's just so that it doesn't confuse you. Okay? Then in the next iteration, we will look at the word spinach here. And so just to make it really complete, we now have 18 here in the accumulator, plus the length of spinach makes it 24. And so of course it still doesn't pass this test here, and so spinach is also not pushed into the new array, and that's actually it. So we looked at all the 5 words, and our final array is pasta with tomato. Okay? So let's now actually return the result. So let's return, and I'm going to put this in a template string again, or new title, and then we can use the join method. And this is basically the opposite of split. So what this will do is that it will join the elements of an array into a string separated by spaces. And so that puts it back into a sentence with spaces between the words. Okay, and then the 3 dots. Oh, and I forgot to close this one here. And okay, so we have our new title, which is this array of the words, which will be joined by putting spaces into the words and then add the 3 dots to show that the title is longer than just the words that are displayed. So I hope this made sense to you. And we could have done this here with the for each method and having an external variable here for the accumulator, And we could have then in each of these iterations have updated that external variable. But the reduce method already has the accumulator built in, and so I thought it's a good idea and a good use case to use this method here. So we had to go through all of this a bit complex algorithm here, just because we don't want to cut the words into halves and want full words always in our title sentence. And if you found a simpler way of doing this, then please let me know in the Q&A, but I think this is here actually a good solution and a good use case for some of the JavaScript features like reduce. And it's also always a good thought experiment to come up with this kind of code, right? So let's now actually use this method here. So I'm going to copy it, and where we need it is here in the render recipe function. So here is where we print the title. And so all we need to do is to insert it here and pass in the title, and that's it. So we could now pass here the limit, but as you know, we have it preset to 17, and so there's no need to pass the additional argument into it. So you notice that here in this curly braces in the template string, we can not only use the variables directly, but we can also include functions like I did here. And so that's pretty handy here as well. Okay, so let's now actually test this out. So I'm using pizza again, and let's see. And indeed, here we go. Well, there's something wrong here, so a small bug somewhere where I'm inserting the parentheses. And yeah, here it is. So that shouldn't be there. And so let's now check it out again. Writing pizza. So if you count the characters here now, you will see that they're never more than 17. So 4 and 9 and 14. So that's less than 17. Here we have 4, 8, 13. Here we didn't even need to apply the algorithm. And so we immediately just returned the title because it's only 8 characters long. This one is also less than 17. And so you see that all of them are just on one line now. If we were to increase this here, let's say to 20, then there will probably already be some words that are different. And let's actually do it here. So we can pass 20 now to overwrite that 17. Let's give it a try now. Yeah, we really need that spinner here for the feedback. And so you see that here, these 3 dots, they now moved to the second line already. So that one was too long. Here is the same situation. Here is the same thing. And so, yeah, 17 is really the sweet spot that's best here. Okay, so that's done. And now all there really is to do is to implement this small spinner here that rotates while we are fetching our data from the API. So in order to give the user the feedback that we're actually doing something here and that the app is working. So let's do that right in the next video. Let's continue where we left off in the last video and build our loading spinner. And in order to implement the spinner as fast as possible, let's remember that it should appear here in the search results list, but also here in the recipe whenever we click on one of these results here. Okay, so we should have that in mind and build this spinner, this loader, for reusability. Okay, and so let's actually not include it in the search view, but in base.js. Okay, because again, this is not really just for the search, but we're going to use it later also in the recipes. Okay, and so base here is basically where I put the styles that are reusable, and other stuff like these elements, they're also being used and reused across different modules. So let's say export const render the loader. Okay, and now we actually want to pass one argument into this loader, and that is the parent element. Okay, so remember what I mentioned in the beginning, that we will do this loader here for reusability. And so the best way of doing this is to pass in the parent and then say that we want to attach this loader here as a child element of the parent. And so in the case of this list here, we can pass in this parent element here so that the loader will be attached to this. And if it's the recipe, we can then pass in this parent element. All right, so let's create a variable called loader. and then using the template string method that I showed you before. So we're just going to write some HTML here. This one I cannot copy from anywhere, so let's just write it out here. And actually, even inside of JavaScript here, this HTML still gets auto-completed, which is pretty amazing, I think. So we have this div with the loader class, and then in there we have an SVG. And so this is an icon. And then use href, and then in our images, it's the icons.svg, from which we select the icon CW. And that's it. So how does this actually work? So let's take a look at our CSS file here. So that's the CSS file. Let's search for loader. And here we have it. So we style the loader here with this height, this width, and this fill. But the magic really happens here, which is this animation, which is an infinite rotating animation. So that's the animation that I defined here with the keyframes at rule. I'm not sure if you're familiar with that. But anyway, we have this animation here, which basically makes this icon rotate 360 degrees. Then we say that we want it to be infinite. And so basically, as long as the element is on the page, it will keep rotating. Okay, and that's as simple as it gets. So really simple stuff here. That's all we need to do here in this situation. Now, where do we actually attach it to? Well, that's the parent that we pass in. So parent, and then again, we use our insert adjacent HTML. Let's take a look again at the documentation here. And so this time around, we're going to put it right after begin here. Okay, so right at the beginning of the parent element. So let's copy this function here. I'm not going to write it out myself. So after begin, and what we want to attach actually is the loader. All right, and that is it, I guess. So moving over to our index.js file here, we now need to edit here, prepare UI for results. So the first thing that we want to do, or actually not so, after clearing the results from the search view, we now want to render our loader. So let's say, and actually we have to import it still. So it is here inside of this base file, right? And so let's actually add the render loader. So these are all named exports. And we could actually have done it with the asterisk import here. So basically importing everything at the same time, but I'm keeping it like this because later we are actually going to add some stuff here that we're maybe not going to use here. And so we don't have to expose it to this global index.js file. Anyway, we can now use render loader here. And all we have to do now is to pass in the parent element. And the parent element where we want this to be is actually this results. Because the results list is an unordered list and we don't want the div inside of that. So this is only for li elements. And so let's actually attach it here in this div. So it is called results and we need to then add it here into, of course, into this element. So search document.query selector . Okay, let's copy out this one. So elements dot search res. So this renders the loader. Okay, close this one up and let's check it out. And here we go. So here it is. And it keeps rotating and rotating and rotating, waiting for the data to come back. And here we go. So here is our data, but the spinner is of course still rotating here. So that's not ideal. And so let's get actually rid of it. Okay, but let me just inspect it here for you to see it. So that's the icon that we included and with the, with the infinite rotating animation here. So that's our spinner. Now we also need a method to get rid of it, right? So let's get back to our base.js and create the clear loader. And this time around, we don't need to specify the parent. All we need to do is to select the loader. Now, right now, we cannot really select it like we did here in the elements. And that's because by the time that this code runs, the loader is actually not yet on the page. And so we cannot select anything that is not yet there. So what we need to do here is to do the document.query selector right here. So const loader document.query selector and then the class. Now, it really bothers me to hard code this class into this query selector here now. I really want all of these classes like to be in a central place. So just like we did here. So this is a lot cleaner. And in order to achieve the same thing, we will actually create a new object like this. Element strings this time around. So I'm going to call this one loader, and it has the class name of loader, as we already know. Okay, so down here we now can say element strings dot loader, and the same thing actually up here. So if we were ever to change now the loader name in the CSS for some reason, then all we had to do would be to come here to this element, change it here, and then it would work automatically here in both of these methods, instead of being hard-coded down here and also here in the render method. So maybe you think that's a bit overkill, that's not really necessary, but I like to keep things like that because I'm always looking for usability and maintainability, because that's something really important in all coding, not just JavaScript, but also CSS and whatever really you're writing. Okay, so in here we now selected the loader element. Now let's test if it exists so that we can then delete it. Okay, and actually this here is not ready yet because we still need to add the dot. So let's do that using a template string. So dot and then this part. All right, and we cannot add the dot in here because then the dot would also be here in the class name and we don't want that. So this really has to be just a class name, and then we add the dot here for the class selector here right in the query selector. Anyway, if there is a loader, then we want to delete it. And maybe remember from the Budgety app that deleting an element from the DOM is a bit strange. So we have to go up to the parent element. So parent element, and then basically we move down again and remove a child. Okay, so in order to remove an element, we always have to remove a child. And in order to do that, we need to move up to the parent. Okay, and so we pass in the loader again, which is our element, and that should be it. Okay, so what we want to do here is when we render the results, we first want to start by removing the loader. Okay, and again, we need to actually pass it in here or import it. So we want to render and we want to clear the loader. So all of these methods, we want them to be available here. And so let's say clear the loader, and that should do the job. So it already reloaded. Let's search for pizza again. Whoa, what's that? Well, something is wrong here. I mean, it did the functionality, so it added the loader and then it removed it, but I guess something is wrong with the class names. So yeah, of course it's not elements, it's element strings. So here and down here, it should be element strings. Give it a save. Let's try it again. And yeah, here we go. So now it rotates and it disappears as soon as the results come back. So that's exactly the look that we were for. Okay. Now, next up, we have to implement the pagination. So right now we have all of the 30 results all on the same page. And that's not really helpful because it makes the page way too long. And so what we want to do is to have 3 pages with 10 results on each. And so in the next lecture, that's what we're going to take care of. So see you then. As a last step in the search functionality, let's now implement the search results pagination. And in this lecture, you will actually learn some cool new stuff, including the super useful closest method for doing event handling in a much easier way, and also how and why to use data attributes in order to read data from HTML5 elements. And so let me first show you what we're actually trying to achieve. So I'm going to my working example here. And so what we have down here is this button which says page 2. When we click it, then we have the next 10 results. We can go back to page 1 and to the next page, page 3, and then we have the next 10 results. And then of course we can go back all the way to page 1. And so let's now go ahead and implement that in our code. And we will implement this functionality in 3 steps. So the first step is to change the render results function, because that's the function that will be called whenever we click on one of the buttons. Okay, so we not only need to pass in the recipes now, but we also need to pass in the page that we want to display. And we can also say that we want to pass in the results per page. Okay, and we can set these here as a default to 10, let's say, and we can also start with page number 1 as a default, but of course we can then override it. Okay, makes sense? So imagine we click on the button to go to page number 2, then this render results will be called and page will be set to 2. Okay, then the second step that we need to implement later is to render these buttons actually on the interface, and then the third step will be to attach some event handlers to these buttons in order to actually make the functionality work. Okay, but let's start with changing some stuff here in the render result. And it's actually not really difficult. So what we want to do here is to not display all 30, but only the number of results per page. So in this case here, 10. Okay, and so let's define a start variable. Let's set it here to an arbitrary number for now, and we're going to implement this logic here later. Okay, but for now let's just put some random numbers here. So we have a start and an end variable. Let's set this one here to 10. This one here to 0. Okay, so that I can now show you what we actually need these variables for. So what we're going to do then, after determining which should be the first recipe to show and which one is the last, well, then we can simply take a part of the total array. So remember that this recipes here is the array of all the 30 recipes. So we can now take just a part of this, which is done using the slice method. And I think we've used this before in one of the other projects. And so the first parameter that we need to pass in is the first point where we want to start basically copying the array. And that's at start. And well, you can guess it. The second parameter is for end. And let me actually show that to you just so you can become more familiar with the documentation. So I usually always like to use whatever I'm searching for and then MDN, which is in my opinion the best web documentation out there. Okay, so you see slice returns a shallow copy of the portion of an array into a new array. Okay, and so we can pass in the begin and the end, which is exactly what we did. And both of them are 0-based indexes. Okay, so how do we actually calculate the starts and the end? And the best way to figure it out is with an example. So let's say you're on page 1, and so you want to start at 0, right? Because the index in the array is 0-based. And so the first position is 0. So on page 1, you want to start on 0, and you want to end on number 9, right? And with that, we will select 10 elements. Now, if we were on page number 2, well, then we would like to start with number 10 here, like this, okay? So how do we implement this? Well, we can simply say page minus 1 times the results per page, right? And that's it. So again, on page number 1, it will be 1 minus 1, 0, and so we will start on 0. On page number 2, it will be 2 minus 1 is 1 times 10, so we will start on page number 10. And of course, on page number 3, it will be 2 times 10, and so we start at 20. And this will actually work for whatever page you passed in here. So we could hard code it specifically just for page 2 and 3, because we know that right now from the API we only get 30 results, but imagine that the API would change in the future and we would get 100 results. And then this code would no longer work, and if you do it like this dynamically, then everything is going to work. Okay, and then the end is actually just the page times the results per page. And that's it. So on page 1 it will be 1 times 10, so 10, and then 20 and 30. And what this means is that actually the end number here is not actually included in the new array. So let's take a look at that here in the doc again. So here's what I was saying. So slice extracts up to, but not including the end. And so when we put 10 here, it will really only copy until 9, which is exactly what we want. So 10 results. Okay, makes sense? So let's actually now go ahead and test this. And if we do it right now, it will actually already work, I'm sure. So if we now type in pizza, we will only get 10 results. So let's wait for it. And let's count them actually. Put some more space here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Perfect. Let's change it here now as a default to 3. And actually, let's also change this one here to 5. Just to see if everything works. And indeed, we get 5 results. Put it back to 10. Let's check it out again. And indeed, here we go. All right, so that's now implemented. Let's now take care of rendering the actual buttons. So let's write a function, render buttons. And you see that this is again a private function. And that's because we will call this function from the render results. Okay. So what do we actually need here? Well, let's put in just a page for now. And we're going to add more arguments later down the road if we need them. Okay. So of course we could have done this functionality here. So the rendering of the buttons right inside the render results. But again, I like to keep different stuff in different functions here, so to make it more reusable and more maintainable. So the goal of this function here is to render the buttons according to the number of the page that we're on. So let me show it to you again, how it should work in the end. So when we're on page 1, then it should only display the button for next. If we're on the second page, so not the first one and also not the last one, then we have both buttons to go back and also to go forward. And when we're on the last page, well, then we only want the button to go back. Okay, so how do we actually now implement this? Well, we need to know on which page we are and also how many pages there actually are. And how do we actually know how many pages there are? Well, all we have to do is to divide the number of results by the results that are displayed per page, right? So we need to pass in that data to our function. So we need the num of results and we need how many results we have per page, right? Does that make sense? So let's call this one here pages, which will mean, again, how many pages there actually are. And we calculate this by doing the number of results divided by the results per page. So in our example, we have 30 results, and on each page we have 10 results. And so 30 divided by 10 will be 3. And so now we know that we have 3 pages. Now imagine that for some reason this changes here again. So if the API changes in the future, and instead of 30, we get back 45, for example, then 45 divided by 10 would be 4.5 pages. And we don't want that, of course, right? So we want not 4.5, but in this case, we want 5 pages in order to have room to display all of the results. And so we have to use a function which is part of the math object, and it's called math ceil. And so this will basically round it to the ceiling, so to the next integer. So if we had 4.1, then it would round it up to 5. If we had 4.4, it would also round it up to 5. Because if we used normal rounding, then, well, 4.4 would be just 4 pages, because it would be rounding down, right? But we always want it to the ceiling. Okay, so we have 3 pages. And so let's now do some if-else statements. So saying what we just said when we looked at what buttons we want available on each page. So if we are on page 1, so page is 1, well, then we want the button to go to next page. So for now, I'm just writing it down here so that we can then know what to do. Else if, so if we're on the last page, we only want the button to go to the previous page, right? So how do we say the last page? Well, it's just that the page is equal to pages, right? So if we have 5 pages and we are on page 5, well, it means that we're on the last page, right? Here, let's say only button to go to next page. And here we only want the button to go to the previous page. So these are the two edge cases, but then we also have the case that we are in one of the middle pages. And so that means that the page is less than pages, right? So in this case, we want both buttons. Okay, now imagine that we only have one page. Then in that case, we actually don't really want to display any buttons at all, right? So let's say here that the page should be 1 and pages should be greater than 1, okay? Which means that there are actually more than one page, and the same thing applies to the last case. So in case that we're on the last page, well, we really only want a previous button if there are more than one pages. And so let's now actually write the code for the buttons. And you see that we will have a lot of duplicate code here, right? Because we will have a button here, and here we will actually have both buttons, and here we will again have a button. And so all of this HTML code will actually be pretty similar. And so what we can do is to once more export it to an outside function. Okay, so let's do that. Const create button. So what do we need to pass into this function, which is going to render the button? Well, we need to pass in the number of the page that we're in, so that it can then print that number to the interface, and we will have to say if it's a button to go back or to go forward. And so let's call that one the type. Let's now go to the HTML and actually grab the button here, because it should already be somewhere here. And let's actually get this here as a comment. And now before we paste it here, I can see that we can actually get rid of these parentheses, because all we really want to do from this function here is to return the markup for this button. Okay, so we are going to render it down here inside of the render button functions. Okay, and so from here we are actually only going to create the markup. And so we just want to return a template string from this one here. And so this is now just some regular HTML here as a comment, as you know already. Okay, so this is just so that we see what's the difference between the previous and the next button. So you see here that we have the results button previous and the results button next. So that's one of the differences. And also here in the icon. So here we have left and here we have right. Okay, but that's actually all there is. So let's go ahead and copy this one here. That's not correct. All right, so let's start with the number here. So imagine that we're on page number 2 and that we want a previous button. So in that case, we want to say page number 1 here, right? And in case we are on a next button, well, then we actually want page number 3. And so depending here on this type, we can now specify what we want to display here in this page number. So let's say that here as the type, it can either be previous or it can be next. Okay, and both as strings, of course. So in here, whenever we call this create button, we are going to pass in the number of the page that we're currently in, and either if it's a previous or a next button. Okay, and so let's now use the ternary operator here in order to make an if-else statement, but in just a single line. Okay, so we can say if the type is previous, so previous, well, then what we want is page -1. And if it's not, then we want page +1. Okay, makes sense? So imagine we have a previous button and we're on page number 2. Well, then we want to display that we want to go to page number 1. So 2 minus 1. But if we have a next button, well, then on that button, it should say page number 3. And so that's page +1. Okay, next up, we can do the same here for the icon. So we have left and right. So again, if it's a previous button, then the arrow should point to the left side, and in the other case, it should point to the right side. Okay, and so that icon here coming from the icons.svg will then display exactly that, what we want to do. Next up, we have this class name up here. So results button previous for the previous button and next for the next button. So here we can simply plug in this type. So let's get rid of this and just say type. Simple as that. And so that's almost it. There's just one more thing that we need to do here, which is to actually plug in the data into this button containing the number of the page where we want to move whenever we click this button. Okay, so basically we need to encode this number here, and I can actually copy it right now so that it's stored inside of this element, inside this component. And so in HTML5, there's something called the data attributes. And so we can say data, and then we can specify a random name. So like go to. So go to page, so the page that we want to go to. And then let's simply paste in here the number that we want to be here. Okay, and we're then going to use this property here later when we attach the event handler to these buttons. Okay, so just keep in mind that we're going to use this one here later, and by then I'm going to explain to you why. Now all we need to do is to call actually this function here in all of these different cases. Okay, so create button with the current page, and then in this case here we want the prev, so the previous, right? And actually no, we want the next, of course. From page number 1 we want to go to the next page. Now this here should then be assigned to a variable, right? Now we cannot use a const here, right? So we cannot say const button, and that's because const and let, so the new ways of declaring variables in EX6, they are block scoped, and so they're only available inside of this block. Okay, and so if I declare it inside of this block, well, then button is not going to be available outside of this block. So what I have to do instead is to declare the variable outside with a let, because we will want to change it. Okay, so we cannot use const here because we then want to reassign it. Okay, so now we can say button in here, we can say button here, but with prev, and then we can also say button in here. But here, remember, we actually want both buttons. And I'm not sure why I deleted the comments. Let's go back here. So prev, and here we want both buttons. So now we need a string which contains one button for next and one for prev. So let's do that. So a template string again here. I'm not sure why this one closed. So one for next and one for previous. Okay, so I created a string which contains the result of calling these function here 2 times. So these 2 strings, and so we will then have these 2 buttons. Okay, so all we need to do now is to actually then insert this new element right into our DOM. And so where do we actually want this? Well, let's go back to our HTML, and well, it should be inside of this div here called results pages. So let's add it to our element. So we have search res and search res lists. Let's now add search res and pages. So elements dot search res pages dot insert adjacent, and not element but HTML. We want it at after begin, so right at the beginning of the element, and then of course the element we want to insert, which is of course the button. Whew, so that was a lot of code. Let's actually take a look if this is working. Okay, so this is our result. Oh, and I see an error here already, and it is in base.js. Let's take a look. And actually it is red here in the code editor. It was already telling me something's wrong. And for some reason I added this semicolon, which I shouldn't. And so let's see if it works now. Give us some more space. And I do not see any buttons down here. And yeah, of course I don't, because we did never call the, where is it? So we did never call the render buttons. Okay, so let's go ahead and do that. So some comments here. Render results of current page. And render the pagination buttons. So render buttons with the page, which is page. The number of results is the length of the recipe, right? So recipes is the array which contains all of the recipes, and length then gives us the amount of recipes that are in there. And then finally, the third one is results per page, which is just results per page, which is this one that we get as an input to this function. And so let's take a look at that again. And so, well, something is not right here. And I guess, yeah, the problem is that we're still on page 3. So of course we always want to start on page number 1. And so here we go, page 2. Well, the icon is not really at the right place, but we're going to take care of that in a second. And then of course, if I click, then it doesn't do anything yet because we didn't yet attach the handler. Let's just inspect this element here so that I can show you this data attribute that we added. And so this one here. So we have the data.goTo, which is set to 2. And so next, when we're adding the event listeners, this is how we'll know which page we should move to. Okay, so instead of reading it from the text, so from this DOM element here, we will simply read this property here, which is a lot better. Okay, so it works on page number 1, and so let's hope it also works on page number 2. And we're going to test that once we have our event handlers properly working. And so that's what we're going to do next, actually. So that's going to be in the controller again. So the controller is where we have all our event listeners, and we then control what should happen based on what was clicked, of course. Now in this case, we actually have a small problem, because where do we actually attach these event listeners to if the pagination buttons are not yet there when the page is loaded? And so we have to use something called event delegation again. So we used that before in the course. And so the concept is that we attach the event listener to an element that is already there, and then we try to figure out where the click happened so that we can then take action based on that. Okay, and so the element that is actually already available at load is this one, so results page, which is where we put the buttons into. And so that's where we have to put our event handler. So elements dot search res, and it is here pages. Add event listener on click. We want to have access to the event so that we can then use the target property. Remember that one. And so let's actually log it to the console. So e.target. So e is our event here, our click event in this case, and then the target. So exactly where this click happened. Now in order to be able to view 2 buttons and not just one, let's go to page 2, because then we should have the previous and next button. So let's test it out. And indeed, we have page 1 and page 3. And so let's now click on the buttons. And you see that here now we have the element where the click happened. Now I clicked here on this text. Now what would happen when I click on the icon? You see that we then get the icon. And if I click here outside really on the button, well, then we get something else. And so how do we actually now define where we want the click to happen? Or in other words, how do I say that I want something to happen when I click on this button, when in reality I'm clicking at this text or maybe even at this icon and not really the button element itself that I'm looking for? So how can we do that? Well, we actually have something that helps us in JavaScript for dealing with just that. And that is the closest method. So again, let me try to show that to you. So it works on all DOM elements, And you see that closest returns the closest ancestor of the current element, which matches the selector given in the parameter. Okay, so let's see that in action. I'm going to create a new variable here actually. So let's say button. So e.target, and now the closest. And so now in here we put a selector. And the selector that we want is the class of the button that we're actually looking for. So let's go back here. And so what we're looking for, and well, now it's gone, so I cannot show it to you anymore. But the button that we're looking for is the one with the button inline class, right? So I showed you that we sometimes click on this SVG here or on this span, but really we're only interested in clicks to the button itself. And so we can now use the closest method and say that we are only interested in the ones with the class of button inline. Okay, and now I should actually go ahead and save this in the element strings here. So put it in here, but I'm not going to do that because then I would have to do the same here for this one and for this one here as well. And so right now I'm not going to go down that route. Okay, so let's keep it simple here. And right now I'm going to simply log the button. So what's going to happen here is that now, well, let me show it to you. So what happens now is that I still click here on the span or on the icon like this, but it will then find the closest element with the button inline class. So this is exactly the button that we're looking for. So no matter where I click now, we only get the button, which is exactly where this data here is located. Okay, so what we're interested for is the button where we have stored the page number. So this one here is page 3, and this one will of course show page 1. Okay, and so that's the number that we're interested for, and therefore we really need to just select this exact element and not any of their child elements. Okay, so let's now say if there is a button, then let's read the go-to page. Okay, and so now we're actually going to read out the data that is stored in that data attribute that I showed you. And it is so useful because all we have to do now is to say button.dataset.goto. And that's it. Let's log it to the console. And test it out, of course. And you see it shows me 1 and here 3. And that is again, of course, because it's saved inside of this attribute. So we can read out this data attribute whenever we prefix an attribute with data, then this variable here gets stored in the dataset.goto here in this case. Okay, and if it was something else, then of course, for example, if I had page here, then it would be dataset.page here. Okay, and so this is a very handy way of having access to data. Now you saw here maybe that this is not really a number, it's really a string, because a number looks like this. So it's in the console, it's shown blue, and so we have a string here really, and so we still have to convert it to a number. So we can use parse int, so it will basically convert it to an integer, and we still have to specify the base of the number, which is 10 here, right? So 10 just means that we're on base 10, so from 0 to 9. For example, if I were to put 2, then we were on binary, and so we will only use the 0 and the 1. But that's not the case, we are on base 10, so let's just keep it like that. Okay, now all we need to do is to use our render results method or function. Now all we have to do is to call it just like we did before, but specifying the page, which by default should be 1, of course. And so let's do that. So we used it before here to render, and here we didn't pass it any number because we could simply pass in number 1, but that's the default anyway, so let's not do that. So all I'm going to do is to just copy it here. I'm still leaving the go-to page down there so we can check it out, and then all we need to pass in is the go-to page. And that's it. That's all we need to do really. So I hope this is making a ton of sense to you. And I'm sure it is. So let's now click on 2, and it will add these new down here below. Okay, we also have all of this here, so that's not ideal, of course. So whenever we add some more results here, we first should actually clean out the list before we keep adding to it, of course. So we have render results, but before we do that, let's actually use clear results. And we did that before here again. So clear the results. And so now it's becoming really handy that we have it all nicely separated into our different functions and modules, because we are of course reusing all of this code from before. And so we just have to do clear results and render results again here. Just get rid of this one here. And the other problem was with these buttons. So we should actually also clear out the buttons. Okay, so let's do that in the clear results. And it should be here. So clear results. And so we also have to say search rest pages.innerHTML should be empty as well. Let's try it out one more time. So that is page 1. And here we go. Page number 2 with the next results. And finally page number 3. And great. That's awesome. So it's really working. Also, the numbers here are correct. What's just not correct is these, this should actually be on this left side, and this here should be on the right side. So I'm not really sure why that is happening, but let's take care of that for a second. For now, let's just appreciate that it's really working. So it tells us to go back to page number 2, because we are on page number 3. Now we're on page number 2, and so now it says go back to 1 or next to 3. And then here we just have the forward button, just as we said here in our render buttons code. So just as we did here, right? And the problem with the text being on the wrong side is just because this one here should actually come before the icon. Okay, and so now everything will be perfect. Just one last time before we can finish with this video. And so now it works. So perfect. So I hope that wasn't all too complicated for you. And of course, when you're doing your own app, you're not going to implement it in the exact same way. And so all I want you to really understand is the entire logic behind this pagination. So basically creating the start and the end numbers, and then rendering the buttons here according to the page that we're currently on. Okay. Also, it's important to remember event delegation, which is something really important again in JavaScript. And we did that here again. We did it on other projects, but so now here we did it once more for you to remember it. Okay. Anyway, this was a huge lecture. Great to see that you're still with me here. And take a break now, and then see you in a second in the next one. Welcome back. Now that the search functionality is fully implemented, let's start working on the model for a single recipe selected from the search results. And so let's start by creating a new file in our models folder, of course. So recipe.js. And this one will actually be a bit similar to the search model. Okay, so let's open up this one here side by side. I can close these files. For now, I don't longer need them. So again, we're going to use access here for our Ajax call. And we will also create a class for this recipe to hold all the data for one recipe object. Okay, so import Axios from Axios. And we will export a default class called recipe. We give ourselves a constructor, and this time what we're going to pass in will be the ID. Okay, and then we say this.id equals the ID that we pass in. Okay, so each recipe is identified by an ID, and when we create a new recipe object, what we will pass in is that exact ID. And based on that ID, we can then later do the Ajax call in order to get the rest of the data for the recipe. Okay, and so that's actually the next method that we're going to code, which will be called getRecipe. Okay, and we already know that we're going to use an async here. And so for now, you're super familiar with this stuff already. Okay, let's then use a try catch such as before. And here just console.log the error in case there is any. But what really matters is, of course, what happens here in the try block. So let's set the result to what we await from the Ajax call using Axios again. Okay, so that's again very similar to what we had here. Now we need again or key and or proxy. And so we could now go ahead and copy these here to the recipe model, but that's not ideal, because then imagine that we had a new key or a new proxy, then we would have to change it in two places, and that's not ideal. So instead of doing that, let's create a configuration file where we can store these two variables, then import this file into these two files, so into these two models, so that we can then use these variables in there. Okay, so we're going to do that right in the home, in the home JavaScript folder, so in here. And I'm simply going to call it config.js. And so I'm going to take these out of here and put them right here. Okay, now it's not actually the best practice to have this kind of data here stored on the client side. Okay, because everyone using your app can easily access, for example, your key. Now in this case, it's not really a big deal, but please remember to never store any real sensitive data like this, so on the JavaScript client side, okay? And ideally, you would do maybe these Ajax calls on your own server and then have your own API from that server, from where you would then do the Ajax call in the front-end client, okay? But for now, in this example, this is perfectly acceptable, okay? So let's then go ahead and import it here, first into the search, and we're going to do a name export, so key and proxy, from another path to the module, which is one folder above, so ... and then config. Okay, and so with that, our proxy and key variables are back here in this file. Just copy them to this other file, to the recipe, and so now we're good to go. Okay, now let's actually go ahead and copy what we have here, and then do some changes, because the URL is really the same, okay, at least up until this point. So let's take out this part, and in order to figure out how we get the recipe, let's then go back to the documentation. Okay, so we have the search and we have the get recipe, remember, and the search request should be to API/search, the one that we used before, and in order to get the recipe we use API/get. Okay, and then the parameter is again the key, and then also the recipe ID, which is here called OR ID. So we use the get route, and then we pass the key into, and also the recipe ID. And that recipe ID will be the one stored in our object. So this.id, right? And that's it. So again, this Axios call here will then return a promise, which we await because we're in an async function. And so again, we're using async await, which I believe is the best way of using asynchronous JavaScript. Okay, and now just to test this out actually, so in order to see what kind of data we get back from the server, let's just log the result to the console so that we can then figure out what exactly from the response we need to save. Okay, so this should work for now. Let's now go ahead into our main controller, import this recipe model, and then create a new recipe from it. So import recipe from same folder, models, and that's it. Let's add some small comments here. So this was the search controller, and then let's also have the recipe controller. Okay, so we're not going to do the recipe controller just yet, but we already then have our code ready for that. So let's simply create a new variable here for now, just to have a new recipe, and let's pass in an ID. Now what ID do we actually want to pass in here? Well, let's try out one of the ones that we already have. So let's try to get one from our search result. So we use pizza again, and something did not work here. So we get this error here, and here we see that we have the proxy and the key both set to undefined. So there was probably something wrong with the config file. And yeah, indeed. So here we have to add to export. So in order to actually export these variables from the file. And now that should be working. So let's reload it. And now we should get back the results very soon. And here we are. Now, if we click on one of these, then we will actually have the ID here displayed in the URL bar, right? Because remember that back in the view, let's take a look at that. So in the search view, where we displayed the search result, so where is that? Yeah, so we put the recipe ID here in the href, so this hash symbol and then the recipe ID. Okay, and so that ID is exactly what we need to search for recipes. Okay, and so let's go ahead and copy this number here and then plug it in here into this new recipe. Okay, and so all we need to do now is to call the getRecipe method on this newly created object, right? Because of course this object here inherits this getRecipe method from its prototype. Okay, so that's basically how the ES6 class works behind the scenes with prototypal inheritance. So r.getRecipe, and that should then trigger this console.log here right after we receive back the data from the recipe with the ID that we passed in here as this number. So let's give it a try. It should now reload. It actually already did it here down here. So you already have the data here, and if you open up the data property, then we have our recipe in here. Okay, so we have data.recipe, and then in there we have all kinds of stuff. So we have the image URL, then we have an array of ingredients here. Okay, then we have the publisher, the URL of the publisher, the recipe ID again, and the source and the title. So the source is where the recipe actually comes from and where the directions are. And so we're actually going to need most of these properties that we have in here. Okay, so we need the title, we need the publisher, so the author basically, we need the image, we need the URL itself, and we also need the ingredients. Okay, and all of this data here live at data.recipe. Okay, so let's now go ahead and save all of these to our object. So we want to have the title, so this .title will be, remember, res.data.recipe.title. Okay, so res is the actual result, and then remember that we saw in the console that we have data.recipe where all of this data lives that we need now. Okay, so this.author, I'm going to call it author and not publisher, is at res.data.recipe.publisher. Next up, we want the image. And let's actually just duplicate this here a couple of times. So the URL, which is called the source URL here in the data. And then finally, we want the ingredients. And so that should be working now. So let's get rid of this console.log here. And what I'm going to do instead here is to log our object. So again, this is just for testing, of course, but now I want to actually see the entire recipe. And so here it goes. And indeed, we have our author, the ID, the image, which for some reason is not really working. Then we have the ingredients, we have the title and the URL. So that's all that we need in order to display the recipe on the UI here in one of the next steps. Okay, now something wrong here with the IMG. So probably there was some typo there. And in here, I guess it's just image. Okay, so let's wait for it again. And here you go. So now it's actually there. All right, so that's the data that comes back from the server. Now let's just add a couple more things to our data model. So let me show you how our app works in the end. So what we have here is not only the stuff that we got from the server, but we also have the cooking time and we have the amount of servings. Okay, so let's now add some methods to calculate these. Okay, so let's do calc time. Now, of course, we don't have an accurate way to estimate the time it takes to cook one of these recipes. So let's just do a very, very rough estimate and assume that for every 3 ingredients, we need 15 minutes. Okay, so let's start by saying that the number of ingredients is this dot ingredients dot length, because remember, these ingredients here, it will be an array of all the ingredients. Okay, and so with length, we get how many ingredients are in there. Then let's calculate how many 15 minutes periods we have. So periods, so we have the number of ingredients divided by 3, and we want to round it up to the highest integer. So math.ceil, and we already used this one before, right? And so finally we can calculate the time, which is just a period times 15. Okay, let's add that comment here in order to make sense of this code. Okay, so something very simple here. And now for the servings, we're actually not going to do any calculations at all. We're just going to say that this.servings is 4. Okay, so again, we could have like a very complex algorithm here trying to figure out how many servings we are based on the amount of ingredients, but that's not necessary at all. We just say that we have 4 servings on each of the recipes. And okay, that's it for our data model. We're going to add some more stuff to it later, but for now this is enough to get us started with the recipes. Now to finish, let's just test out our error handling here as well. And let's add like an alert here so that the user can actually see the error. And let's actually just say something went wrong. And a sad face. Okay, and so let's assume that we put in the wrong key. So let's just add a couple of random numbers here. And so this, of course, will be a wrong key, and we should then have an error message. Okay, so let's try it out. And indeed, we get this error here, which says we have no access to this resource, which of course is because we have a wrong key. And then the user also gets this message here, something went wrong. Okay, so this also works. So the try catch here again is working. And so let's now start working on the controller of this recipe part right in the next video. In this video, we will implement a controller for the recipe section. And this is actually a pretty cool lecture where you will get some new knowledge. And so you will learn how to read data from the page URL by responding to the hash change event. And also how to add the same event listener to multiple events. So probably quite a long video, so let's get started. So in order to figure out how to implement the controller, let's think again about how we implemented the search functionality. So what we have here is that whenever we click on one of these recipes, we get the ID of that recipe right here in the URL bar, right? So take a look at this here whenever I click on these different recipes. So you see that the ID there changes. Now inside this URL, this entire part here is called the hash, okay? So it's the hash symbol and then whatever comes after that. So this here is the hash. And we can then actually make use of the fact that we change these hashes here whenever we click on one of these different recipes by using the hash change event in JavaScript. Okay, so there's an event that's called hash change that is fired off each time that the hash that we have in the URL changes to something else. Okay, and so let's go ahead and use that event. Okay, so this was just for testing here. And so let's now add an event listener. And this one we will actually add to the global object in JavaScript, so in the browser, which is window. So window.add event listener and then the hash change. Okay, and what we want to call here is the control recipe function, which we didn't write yet, but that's what we're going to do next. Okay, so we had the control search function here. And so let's now create control search. So first thing that we should do in here is to actually get that hash, okay? So I'm calling this one the ID, and we can get it from window.location. Okay, so window.location is the entire URL, and if we then use the .hash property on it, well, that's then just the hash. So let's try that one out. Console.log the ID. So remember that we have this event listener here whenever we change the hash, which will then call the control recipe, which will log the current hash to the console. Okay, and of course we need some examples here again. So here we go. So take a look at this, where the ID of the search item that I click here, which is this one, will be translated here into the console, right? So you see that? Now if I click twice on the same, then nothing appears because we didn't change the hash, okay? And so the event is not fired. But each time I click on a new one, then the ID is here, of course, in the URL in this hash, and then also down here. So great, that part's already working. Now what we're really interested in is only this part, so only the ID, but without the hash. So let's take care of that. And we can simply do a simple replace, because this is a string, and so we can of course call all the string methods on it, and we will then replace the hash with nothing. Okay, and with that, the hash symbol will be gone. Okay, so let's now go ahead and do something with this ID. And first off, we need to change if we actually have an ID. Okay, because imagine that we would simply do this. So get rid of everything, then we don't have any ID, and so we don't want to create a recipe object. So we only do all this logic that we're writing next in case that we actually have an ID. So let's add some comments here, just like we've done before. So get the ID from the URL. Then prepare the UI for changes. So this is similar to what we had before again. Create a new recipe object, of course. Then get the recipe data. Then we need to call our functions that they created for the servings at the time. So calc time and calc servings. So we need to call them here as well. And finally, when we have all of this in place, we can then render the recipe. Okay, so let's fill this here up with whatever we already have. So prepare UI for changes. We don't have any UI methods just yet, but what we can do here is to create the new recipe object. Okay, and of course, again, we will put this in our state. So we already have the search inside our state, and next we will put then the recipe. So state.recipe will be a new object based on the recipe. And of course, what we pass in here is then our ID. Okay, next up, let's get the data from the server. And so we need to call getRecipe, right? So that's one is at state.recipe.getRecipe. Now, of course, we want this to happen asynchronously. So in the background and in a way that the rest of the code is only executed after we get back with the data. So we are going to use, of course, await here, and don't forget to then change the function to an async function. So yet another async await function here so that we can load our recipe data in the background. Next up, state.recipe.calc servings. All that starts with calc time. Okay, and finally, we can then render the recipe to the UI. We cannot do that just yet, but let's simply log the object, okay? So state.recipe, because for now we don't have any UI methods just yet. Okay, so let's quickly go over that again. So we start by getting the ID from the URL by using window.location.hash and then replace the hash symbol with nothing, so that instead of the hash, we just end up with the actual ID that we need for the search. Then we create a new recipe object based on a model that we coded up in the last lecture, save it in our state, just like we did with the search. So again, all of our data is stored in one central place which is the state that we can then get access to. Then after that, we call getRecipe here, which due to the fact that it's an async function will return a promise. And so therefore in here we use await to wait for the promise to get back with the resolved value. Okay, so here the code will stop executing, and then after that we will simply calculate the time, the servings, and log everything to the console. So let's test that one out. Searching for pizza again, and let's try this one, pizza dip. So we get the ID, of course, and then our recipe. And all the data is actually here. So that's amazing, right? So we can right now select recipes from our search list, and it will already display the data here in the console. So here's the next one. And if we click on another one, then of course it will work as well. And so great, that part is already working. Now imagine that we would reload this page here. Okay, then nothing happens, because again, this only happens whenever the hash actually changes. Okay, and so we need to fix that, because imagine that the user saves this URL here as a bookmark, for example, and then when he comes back, then nothing happens really. Okay, and so what we need to do also is to add an event listener to the load event, which basically fires whenever the page is loaded. So window.add event listener, load, and then control recipe. Now I promised you in the beginning of the video that I would show you how to basically add the same event listener to different events. And that's useful here because we're calling the same function here simply for these two events. Okay, so let me show that to you. And it's actually very simple. We just need to think a little bit about it. Okay, so let's comment out these two. And what I'm going to do is to do an array with these two events. So hash change and load, and then I will simply add a loop to it. So a for each, where each of the elements is an event, and I will then do window.add event listener, and then in here we pass the event. So event, and then of course control recipe, and that's it. So we just went from 2 lines here to just 1 line of code. Now if we had like 10 lines with these events, then of course it would become even more useful. Okay, so let's get rid of this here, and I hope this made sense to you. So again, we saved the strings for these two event types into an array, and then looped over them and called window.eventListener for each of them, passing in the corresponding event. Okay, and so let's check it out now. Let's reload it, and you see that now it's happening. Okay, so the load event is now doing its work here, and it doesn't only work in case that the hash actually changes, but also if the page loads. Okay, and so now it's even more important that we have that if statement which checks if there's actually an ID. Okay, because right now there's not an ID, and so we of course don't want anything of this here to happen. Now finally, and this is something that we didn't do in the other controller, is that this await here can of course go wrong. So right now we're assuming that this promise here will always resolve, but of course it can get rejected. So we actually talked about that before in the last lecture, where I intentionally put a wrong key here. So in that case the promise rejects, and this will of course then also have an effect here on this async await, right? So in order to handle that event here as well, let's add another try catch here. And so we actually, all of this we only want to happen in case that everything goes well, right? And so let's just alert like error processing recipe. Okay, because of course we only want to render, for example, this recipe in case that everything goes well with getting the data from the server. Okay, so let's introduce an error here again. So a wrong key, which will then trigger an error. So let's just click on one of these, and of course it says something went wrong, which comes from the first catch, and then again error processing recipe, which comes from the second catch. Okay, so basically the first one comes from this catch block here, and so then this entire promise here will reject, and so we will then also enter this catch block here, which will then trigger this second alert. Of course, let's go back to the way it was before. And the error handling could of course be a bit better. So instead of having these alerts, we should add some messages to the user interface, but that's a bit too much for this simple example. And so I'm not going to go that way. Of course, you can implement that yourself if you feel like it. Okay, so that's it for this recipe controller. Now, since we're at it, let's implement the same thing here in this search controller, because we didn't do it up here. So again, we only want to render the results here in case everything goes right with getting the search results from the server. So try, and let's move up all of these and catch the error. Okay, and something else that we want to do here then is to still clear the loader. Okay, so we don't want to render the results, but we still want the loader to go away in case that there's an error. Okay, so that should be it. Okay, everything's working. And so next up, let's actually continue building our model here, because now we need to process these ingredients. Right now it comes back as an array with just 11 strings, but we want this to be a bit better. And so in the next lecture, we're going to take care of that. Let's keep working on our recipe model now, this time writing a complex function to process the ingredient list. And so we will use a lot of stuff here, like using array methods like map, slice, find index, and includes, and you will also learn how and why to use the eval function in JavaScript. So in this lecture, what we're trying to do is to basically read through the list of ingredients, and in each ingredient separate the quantity, the unit, and the description of each ingredient. So for example, here we have 4 ounces of cream cheese, and here we have 1/4 of a cup of sour cream. And we need to have them separately for 2 reasons. First, because we later want to implement this function where we can decrease and increase the number here. And so of course we need to have them in a separate variable. And the same thing happens when we add these to the shopping list. We also have them separated here in the number, in the unit, and then the ingredient itself. So we can, for example, update this number here, and everything else of course stays the same. Okay, so we need a way to read through the list of ingredients and then parse each ingredient into the count, the unit, and the description of the ingredient. So let's take a look at a couple of our results here. So let's say pizza again. So let's wait for the data here to come back from this first recipe. And here we go. And so we have our ingredients here, and you see that we have these numbers here like 4.5 cups. Then we have some stuff here in parentheses. Then we have teaspoon, we have cup, now we have cups. Okay, and so all of these units, they are all different in each of the recipes. So here we have like teaspoon, but if we go into this last one here, let's wait for it. If we take a look here now, for example, here we have TBSP, which stands for tablespoons, but then we have teaspoons again spelled out like this. And so here we have cups, and probably somewhere else we have cup. And so we need to first, before we actually start parsing the ingredients, we first need these units to be all the same across all of the recipes, so that we don't have sometimes teaspoon and another times spoons, and then TBSP, and so on and so forth. So when we have cup or teaspoon or ounce, we always want it to be the same. Okay, and we also want to get rid here of these parentheses, okay, because they don't really add anything here in most of the cases. Okay, so we're going to rid of the parentheses, and then we need to kind of standardize the units. So let's start by doing that. So the recipe, and we add a new method parse ingredient. And so what we're going to do is to create a new array with some new ingredients based on the old ones. Okay, so const the new ingredient is this dot ingredients, and now we will use the map method. So basically a loop over ingredient, where in each iteration we can save a new item to this new array here. So in each of the iteration we have to simply return a value which will then be stored into the new ingredients array. Okay, remember that from one of the previous projects? So we pass in the element, and then we have our callback function in here basically. And then finally we will then say that this dot ingredients will be the new ingredients. Okay, so that's basically how this is going to work. And so let's define what we are going to do. So first we want uniform units. So all the units should be all the same. Then remove parentheses. And finally into count unit and the ingredient itself. Okay, so how are we going to do this first task? Well, what I'm going to do is to create two arrays. In one array we will have the units as they appear in our ingredients, and in the second array we will have them written exactly like we want them to be. Okay, so let's do that out here. So units long, and so let's say that we have tablespoons, but we want it to be TBSP. And what we're going to do here is then to loop through this array here and see if one of these long units is there, and if it is, then replace it by the short version. Okay, now sometimes we saw that we also have tablespoon, like this, okay, and that is of course still TBSP. And so that's one of these cases where tablespoons or tablespoon can appear, but we still want it always to be the same. Okay, and so that's a great use case for why we have to uniform these units like this. And the same happens with ounce. So it may appear ounce or it may appear ounces. And of course, they should both be OZ. Okay, and so we have these data structures here which store the way that it may appear in the recipe and then the way that we actually want it to look. Now another example is teaspoon and teaspoons. So again, a plural, but we really want the abbreviation of TSP like this. And then finally, we may also encounter cups or pounds. And cups, we want it to be cup, and pounds, we want it to be just pound. All right. Now let's create a variable here called ingredient, which will be based on the current element. Right, so right now this element here is each of the elements of the array. And so we set ingredient to that L, but to lower string or to lowercase. Okay, that's because it even may sometimes appear like with a capital T, something like this, for example, but we don't want to include all of these cases here in our long units. Instead, we can simply convert everything to a lowercase and then can start from there. Okay, and I'm using a let here because we are going to mutate this variable here in a second, and so therefore we cannot use const because then we could not change it. So as I was saying, we are now going to loop over the long units, so the one that are appearing in the ingredient. So we use for each, and then this is how it's going to work. So let me first write it out and then I'm going to explain it to you. So in our callback function, we need both the current element, which I call unit here, and then also the current index. Okay, and what we're then going to do is to manipulate the ingredient variable, as I mentioned before, so the one that we created up here, and we will replace. And what we're going to replace is the current unit, so that's the unit here in this callback function, with the unit short that we want. So unit short at position I. Okay, does that make sense? So the tablespoons here, for example, is at position 0, and this TBSP here is also at 0. And so if we find this tablespoons in the ingredient, then it will be replaced with the unit at the same position but in this other array, so unit short, as we have here. Okay, so again, we loop over each of these long unit possibilities and replace that text with the shorter version which appears in the same position. And that's why we have to repeat these here. For example, tablespoons, they're both the same here, but we have to repeat them so that they are still on the same position, right? So for example, this one here is at position number 5, 6, 7. So cup is at position 7 in here and in here as well, so that they can still match when we do this replacement here. Okay, and so right now the current ingredient no longer has the long unit but the short unit, and so we can now move on to the second step with our ingredient already with the short unit in there. Okay, so next up, let's remove the parentheses, and that should be a bit easier. Now, sometimes when you're developing, you might not know how to accomplish a certain task. And so what you do is to basically Google it. So let's do that together now, just so I can show you how I usually do it. Okay, so what I would do in this case is to simply write JavaScript remove parentheses. Okay, so let's take a look at the results here. Remove parentheses from string, remove text between parentheses. So this is here actually what we're trying to accomplish. Then we can take a look at the example and see if it applies to our case. And so yeah, so imagine we have this and we want this. So the parentheses, including the text, should be gone. And so the solution is to use something like this. So we can just go ahead and copy it, and I will explain it to you in a second how this works. But for now, let's simply grab it and use it here. Okay, so we want ingredient to be ingredient and then replace. And we have to store it here in the new variable because this doesn't change the underlying variable, but instead it returns a new one. And so we have to change that result somewhere. Okay, now what is this weird replace here? That's what is called a regular expression. And let me show that to you also here. So let's write MDN regular expression. And regular expressions are kind of a complex topic in programming because they're really quite confusing. But in essence, regular expressions are patterns used to match character combinations in strings. Okay, so that's exactly what we're trying to do in our example. We're trying to match a character combination which starts with the opening parenthesis, then has some text in it, and then closes the parenthesis at the end. So I'm not going to really teach you all about regular expressions, but as a basics, what you need to know is that they always start with these slashes, so they start and end, and so that's what we have here. So we start and we end here with this slash, and so we already know that this is a regular expression. Okay, well, let's replace this here by our normal quotes, which is the ones that we've been using all the time. And so we want to replace everything that is inside the parentheses and the parentheses themselves with nothing. So let's take a look again at the regular expressions. And all these symbols that are in the regular expression, they have different meanings. So for example, if you write this hat here, then it matches the beginning of an input. Or this $sign here matches the end of an input. This symbol here means that the preceding expression can happen 0 or more times, and so on and so forth. So this is really a lot of stuff that you can do here with regular expressions, again, in order to match different situations in a string, okay? So let's take a look again at ours. So an arbitrary amount of spaces, after that the parenthesis symbol, after that an arbitrary number of other characters, then the closing parenthesis, and then again an arbitrary number of spaces. So whenever we match that, we are going to replace it with a space. Okay, and whenever you need something like this, you can usually just Google for regular expressions for achieving something like this. So you can find regular expression for matching certain types of phone numbers, or of an email address, or of a zip code, or whatever you need really to match in a string. There's always a regular expression for that. And if you want to try to come up with your own, well, then you can just try to read this tutorial or read some other tutorial online. There are tons of them. Okay, so this one here removes our parentheses. Okay, and so let's now actually try to test it out to see how it works at this moment. Now, before we can do that, we actually have to return something from here. So return the ingredient. Okay, so as I explained at the beginning, that's how the map method here works. So in each iteration, we have to return something which will then be saved into the current position of the new array. Okay, now in order to not always have to write in pizza or whatever else that we might be searching for when we're testing, let's actually do the same here for the load event. Okay, so basically this is just for testing. Let's write that here. So whenever we test, we will start the control search, and we will, instead of getting from the input, we will simply write pizza. So let's check that out. And it doesn't work. And yeah, of course. I need to add this one here to the window. All right, so let's wait for it. And yeah, so automatically pizza here turns, instead of us having to write it here out all the time. Now, something else that we can do here for testing purposes, again, is to, let's take a look at it, is to expose this recipe here to our global window. Because right now in the console, we don't have access neither to the state nor the recipe or the search or any of that really, because it's not exposed to the global object, okay? But we can do that. So we can do, let's say window.r, which is going to stand for recipe, equals state.recipe. So testing again. And so right now we will have access to the recipe object right in the console because it's now on our global window object. Okay, so let's test that out again. And as soon as I select something, when it comes back, now let's type R. And indeed, here it is. So here's our recipe. Okay, and so now we can then go ahead and call that parse ingredients method on it. So for example, this one here, we have ounces, cup, and ounces in tablespoons, all written out as a long form. So let's now say r.parse ingredient. Let's take a look at R again. So it should by now have changed our ingredients, right? And so it did actually replace it. So now it says OZS, so ounces. Well, something is not right here, but it's probably just an S that I put too much. But here it converted the tablespoon as a long unit, as it was here, to TBSP, right? So that's perfect. And I see why it did that OZS thing, even if it's not written out here like this. It's because it found ounces probably, but then only replaced ounce. And so the S stayed there, and it was then OZS. And so we have to turn it the other way around. So the S first, and then the singular. And the same here for teaspoons, and only then teaspoon. Okay, so that's a small detail. It's not a big deal, but I just wanted to show it to you. Okay, so this is the first one here. Let's say R parse ingredients. Take a look at R. And here we go. So we have cup, we have TSP, and we have TSP here, but we're missing the space now. Okay, and that's because of the parentheses. Okay, so we removed the parentheses and then didn't insert a new space, but instead we removed it completely, and so the spaces are gone as well. Because remember, here we also select the space in front and after parentheses. And so we have to add a new space here. Okay, so let's wait for it. Choose this one, or actually another one. Remember, it can't be the same thing because then it doesn't change the hash. Oh, we have an error here. I'm not sure why. So let's try another one again. So this one. And again, we get an error here. That's very weird, but it still works here. So, and so now parsed ingredients. Let's take a look at R, and now it should be gone. So yeah, so we have cup and TSP and cup, And so the first two steps of our processing are already working at this point. And so now really comes the hardest part, which is to separate the numbers from the units from the rest of the text. And as you can see, probably this is going to be quite difficult because, for example, in here we have all of this should be the number, then we have the unit, and then we have the text. But here we only have this normal number. Here we don't have any number at all. And let's take a look, for example, at this example. So let's wait for it to come back. Then we need to parse the ingredients actually. And so here you see the example where we have a number but no unit, but then again some text. And so each situation is really different, and so we have to be prepared for all of these cases. So basically we have the case where we have the number, the unit, and the text. Then we have the case where we have only the number and just the ingredient text and no unit. And sometimes we don't have any units and any number. So just like in this example of most of these ingredients down here. Okay, so how are we going to do this part, which is the most complex by far? Well, first of all, we are going to test if there is actually a unit in the string, and if so, where it is located. Okay, so the first thing is to convert the ingredient into an array. And I'm going to do that by splitting it through an empty space. Okay, so whenever there is a space, it will now be split, and each word will become a new element in the array. So we've used that here before, and so I'm sure you're familiar with it already. Okay, now comes the trickier part where we have to find the index at which the unit is located. Okay, so unit index. And so how are we going to do that? Well, the first thing that comes to mind would be to use index of, like this, right? But this one is not going to work because what we want to do is to find the position of the unit, but we don't know what the unit is. If we knew which unit we were looking for, well, then we could use index of. Okay, so for example, if we were looking for TBSP, if we already knew that, then we could simply ask which element of the array is equal to TBSP. Okay, but it doesn't work like this in this case because we don't know what unit we are looking for. Each ingredient has its own unit, or maybe not even a unit at all. And so what we're going to use instead is find index. And once more, this is an ES6 method that I actually already showed you in the ES6 section. But right now we have a real world use case for it. Okay, so remember, into the find index function, we actually pass in a callback function. So for each element, which we're going to call element 2 here in this case, because element is already taken up here, well, basically for each of these elements, it will make a test. And what we want to test here is units.includes element 2. So how does this work? Well, includes is a brand new array method. I think it's like an ES7 or even ES8, and it returns true if the element that we're passing in is in the array, and it returns false, of course, if the element is not in there. Okay, so what we're going to do is for each current element, it will test if that element is inside of the units array. And what I mean here is units short. So this array here with our final short units. And so for each of the elements in the array, it will basically perform this test. Okay, so again, this is like a loop, but in the case of find index, it will return the index of the position where this test here turns out to be true. Okay, so let's again use the example of ounces, for example. So it will loop over the array, and it will only return true when there's an element in the array that is ounces, and it will then return the index in which this here turned out to be true. Okay, and so that's the only way to find the position of the unit when we don't really know which unit we are looking for. Okay, so this is a great trick and a really great use case of find index, which is a great addition to the JavaScript language here. So it's really a cool new method on our arrays. Now, as we mentioned before, there are now several different possibilities here for the find index. So let's use an if-else statement. So if unit index is greater than -1, this means that there is a unit. Okay, so if it is -1, then it means that it couldn't find the element. So in this case, it means that all of this here turned out to be false. So basically, if none of these words here appear in the array, so in our original string here, then that means that this unit index will turn out to be -1. Okay, so we can actually already add that one here. Unit index is -1. Then that means there is no unit. Okay, but actually there is another case. Okay, so there's the case where there is no unit, but still there is a number. Remember, so for example, one bread, that doesn't really need a unit, but there is a number and there is text. Okay, and so we assume that the number always appears in the same position. And so what we're going to do is to say array ingredient 0, which is the first position, and then we're going to parse it to a number, an integer, with the base of 10, remember. And so if this is successful here, so if it can be converted to a number, well, then this here will return the number itself and will therefore coerce into true here. Okay, there is no unit, but the first element is a number. Okay, so again, we're taking the first element of the array and we convert it to a number. And if the conversion is successful, well, then it will return that number, which will then coerce to true. And if it's not a number, then it will return not a number, which will coerce to false. Let me actually try to show that to you. So let's use parse int with this string here. And so it returns 234, which is a number. But if we had something else, so text, well, then it returns not a number, and that will then in turn coerce to false, leaving us with the third option, which is this here. There's no unit and no number in first position. So this one is the most straightforward case, and so let's go ahead and start with this one. Okay, so the first thing we're going to do is to create a new variable here, and it will have to be a let and not a const. And also it has to be outside of each of these blocks here, because again, let and const are block scoped. Okay, and so we need to define them outside of the blocks and then mutate them inside of one of these blocks. So this is the final object that we're actually going to return, which is the object ingredient. Okay, and for now it's empty here. We're just like initializing it. So our ingredient object will always have the count. It will have the unit, and it will have the ingredient itself. Now, in the case that we have no unit, well, the unit is empty, I will simply say that it is 1, because we have to put something here, and so rather than putting like 0 or something, we simply put 1. So for example, if it says tomato sauce without any ingredient, well, we just say that we need 1 tomato sauce. Okay, and now as for the ingredient itself, well, if there's no number in a unit, all we really want is the entire ingredient. Okay, so that variable here that we split it up right in the beginning. So we can say ingredient, or even better in ES6, when we have an object which is like this, so when we say ingredient is ingredient, well, we don't need any of this. We can simply do it like this. So instead of having to repeat it, we just put ingredient, and well, it will automatically then create this property ingredient and assign the value to it. In this case, this one. Okay, so next up, we do the one where there is no unit, but the first element is a number. So this one is also not really hard. So the number we already know is this one here. So let's just copy it. So the count, the unit, we don't have it again. And then the ingredient, well, it's just the entire array except the first element. So the first element here is for the number, and the rest of the array is the ingredient. So array ingredient, then we slice it and say that we only want to start at position number 1, and if we don't specify the second argument, it goes all the way to the end. which is what we want. And so we have now the entire array except the first element. And now we have to put all of these array elements back into a string using, of course, the join method. Okay, so we had all of these array elements like Italian, tomato, and sauce, and now we just put them back together into a string here with this join. Okay, so these are the two easier cases. Let's now test it out before we start with the more difficult one, which is this one. All right, let's wait for it. I guess it's getting, yeah. So let's take a look. Let's say our parse ingredients. And let's take a look. And nothing really happened here. And I know why this is happening. It's because we didn't return the object, but instead we just returned the ingredient string, so the one that we were working with up until point number 3. Okay, so let's do all of this again. And you see that it already got back here with the recipe. So let's parse the ingredients. And so here you see some of these say undefined, and that's because we didn't yet take care of the first case. But the other ones, well, they now say 1, then the unit is empty, and then we have the ingredient. And so if we compare that with the initial state, well, we see that it's exactly correct, right? So here we had just these strings, and then now we have all of these objects where it says always 1, then the unit, and then the ingredient. Let's say if we can do the same with another one. So let's say parse ingredients. And now we actually have all of them undefined except the last one. Okay, so let's take this one here as an example to see what we have to do next. So you see that, for example, here the unit is the third element of the array, right? So the first element will be the 4, then the second element will be this 1/2, and then the third element will be the cups. But then in this case, in number 2, well, the first one is the number, and then already the second one is the unit, okay? And so what we will do is to assume that everything that comes before the unit will always be the number, okay? So in this case, we will say that 4/1/2 will be the number, and then after that comes the unit, okay? So let's implement what I just said. So const, I'm gonna call this one here array count, is in array ingredients slice from the beginning until the unit index excluding. Okay, so if the index is number 2, well, that means that position 0 and 1 will be for the count. Okay, so just like in the last example where 1.5 were the first 2 positions, so these 2 are part of the count. So let me write that down here actually. Example 4.5 cups, our count will be 4 and 1.5. Okay, and now we need to figure out a number out of these values here. Okay, now let's actually get this here, and I will put another example because there can be, of course, different example. So if it was just 4 cups, well, then our count is just 4. Right? And so we have different situations here. So you see that this is getting quite complex. And of course, this is just a great exercise to think. Okay, so it's not really important that you memorize how you can parse recipe ingredients, but it's important that you understand the thought process that we go through in order to figure out how to accomplish the goal that we have. In this case, well, it's parsing our ingredients in the way that we defined initially. Okay, and so we use the tools that we have in order to achieve a goal that we established. And that's what coding is all about. Okay, so that's what I want you to understand. It's not really memorizing that I want you to do. It's just understanding how we can use these different tools to achieve exactly what we need. So again, we have these 2 cases here where there's more than 2 elements before the unit, and also the case where we have just 1 number. And in this case, it's really simple. So let's say if our count.length, which is what defines how many elements there are before the unit. So if it's just 1, then the count is array inc 0. And actually I have to define the count before. So just the situation that we had before. So defining it outside of the block. Okay, so if there's only one element before the unit, well then that element is of course the number itself. So the count is then array inc 0. And that's not yet the final story, but for now let's assume that this is how it works. Now if we have more than one number, which is usually like something like this, so 4½ or 1 2/3, something like this, well, then we have to do it differently. And so now I'm going to show you the eval function that I mentioned before. So what we're going to do is to basically join these two strings, because they are strings in this array here, okay? We're never talking about numbers, it's really just strings. So we're going to join these two strings using a plus sign and then do something called evaluate the string. Okay, so I'm going to explain you how and why. So the array of ingredients dot slice from the beginning until the unit index, right? So on these first elements, we are going to join them using the plus sign, and we will then evaluate whatever is the result of that. Okay, and we wouldn't have to do it like this, but this is just a great opportunity to show you this function here that you might encounter someday when you're looking at some JavaScript code. Okay, so this one here, for example, will turns out to be a string 4 plus 1½ Okay, and what eval will then do is that it will evaluate this string here as being a JavaScript code. And so it will do the math here and calculate 4.5. Okay, so if we do eval of this, well, this will then turn out to be 4.5. Okay, so does this way of calculating here make sense to you? Now this is almost done now. There's just one edge case that we also need to talk about, which is what happens in this recipe here. So let's wait for it. So you see here in the ingredients that some of them, they have this dash. So instead of being 1 and then 1/3, it's like 1 minus 1/3, but it really means 1 plus 1/3. So it's 1½ here, for example, not 1 minus 1/2. Okay, and so that is actually not good because none of our cases currently covers this. But what we could do here is to simply replace this minus with this plus and then evaluate that string as well, just like we did before. Okay, and so that's actually pretty easy. All we have to do here is to replace the minus with the plus. And then finally, of course, say eval like this. Okay, so if there is a minus, then it will simply be replaced with a plus, and then the string will be evaluated in order to return the correct number. Okay, so now all we have to do is to recreate this object here. So our final ingredient object. So this is really a long lecture here. There's a lot to do, and it could be even more complete. So there are still some edge cases which are not going to really work, but I think this is more than enough for what we're trying to do here. Okay, so our count will be our count, and so this is the same case as before here with the ingredient. We don't need to specify count equal to count because yeah, we already have this variable here with that name. So next up we have the unit, which is located at array of ingredient at unit index. Okay, and then finally we have the ingredient, which is also in array ingredient dot slice. And so we want to select a part of the array, and it starts right after the unit. So at unit index +1 all the way until the end. Okay, and we then want to join this, of course, back into a string. And all right, that should actually be it. So that was a lot of work. Let's test if it's gonna work. So let's get rid of this here. We don't need this testing. And also, where's the other one? And of course also this pizza here. So let's get rid of all of this. And then what we want to do here, before we display the recipe, we also want to parse the ingredients. So let's say and parse ingredients. And so we want state state.recipe.parse ingredients. So let's take a look now, and it should be fetching our recipe here now. And indeed. And so now we have all of our units here, and it's actually working, you see? So we had 1 and 1/3, I remember here, and now it's this number 1333, which is the exact result of that. Now this part here doesn't really look right, so shortening, and then the rest seems kind of cut off. So let's actually try to log to the console here the ingredients without being processed. So console.log state.recipe.ingredients. And so here are the results, and actually it's correct. So it's shortening it and may substitute butter. Okay, so I'm not really sure what this is here. Maybe some of you will know what it actually means, okay? But anyway, it looks like this is kind of correct. So let's test it with a couple more results here. So let's take a look at this one. And I'm not sure if it did come back. Oh yeah, I guess I just clicked on the same one that was already active. And so take a look, and yeah, great. So we had 4.5 cups, and it was converted to 4.5. So perfect. This is perfect. It really works. So that's just amazing. Let's take a look at this one. I remember that this one here was a bit different from the other ones, but it should still be working. And indeed, yeah, it looks fantastic. So I think we're really done here now after a long lecture of writing all this code. And maybe this was not even the perfect code, so everyone will have different ways of achieving the same result, but I hope that this kind of made sense to you, and if not, then just go a bit through the code by yourself and try to really understand what happens here. For example, this part here, I find it a bit tricky here maybe to understand, and so try to go ahead and figure everything out on your own that doesn't really make sense. Okay, anyway, take a break now and see you in the next video when you're ready for it.